doesn't know, it doesn't name itself. It calls you reasonable, it calls you awake. No crown, no single hand to strike you down. It moves through mouths that claim they know what's right today, what must be so. It speaks in care, it speaks in good, cuts every root where value stood. No God, no code, no line to cross, just necessary, just the cause. Ends justify the fracture, means erase the soul. Every truth becomes a weapon, every lie a roll. Worm form, it isn't flesh or bone. Worm form, it thinks through what you own. It doesn't take your body, it takes the reins. Hijacks choice, rewrites intent, and calls the chains. Progress again. Pride in borrowed certainty, greed dressed up as empathy, lust for power, eyes that gleam, envy calls it equity, gluttony of outrage feeds, wrath made clean by broken creeds, sloth that lets the thinking die while slogans march and questions cry. Division as a sacrament, authority by fear, coercion with a smiling face, comply or disappear. Worm fog, a demon without form. Worm fog, a thought that breeds a storm. It doesn't burn you instantly, it hollows you out slow, until your voice is not your own and your hands enforce what you don't know. This is the warning, not a monster's outside the gate, but at the moment you stop steering and outsource what you hate. It doesn't need belief, just silence from your spine. Give up the work of conscience, and it will speak in your name.
Launch control, we have a go, Roger.
Ladies and gentlemen, please join me in welcoming to the stage your MC for Day 2 of AI Engineer Europe, Tejas Kumar.
Good morning. Thank you. Thank you. Good morning. We are here. Woo! There was a little bit of latency there, but we'll fix it. We'll write a skill for that. Good morning. Hey, it's Day 2. What an honor, what a privilege, what a blessing to be here. Look at this. It's a full room. We are so excited. How many of you enjoyed yesterday? Show me your hands. And if you didn't, there we go. That's right. It's an amazing conference. Yesterday was so incredible. Highlights? You want to shout out some highlights for us today? No? It's Europe. We're a bit more reserved here. If this was America, it would be a different story. But I'll tell you what, if you do have highlights, post them on your social media. And tag AI.engineer. It's kind of, we want this to be a community thing, and the more people we can invite in, the better. My highlight, thanks for asking, was Malte yesterday when he shared this slide of how Europe is leading AI innovation. And I think this is so cool because oftentimes we feel like at least I live in Berlin, Germany, I feel like the underdog. And this was so validating that real innovation is coming out of Europe with even the Deepmind office in Berlin. So excellent. We love Europe. We're here. It's going to be amazing. Today is Day 2, and we're going to talk about a lot of interesting topics. We're going to talk about coding agents. We're going to talk about MCP. Who's using MCP here? Look at that, almost everybody, incredible. We're going to talk about AI architecture, media, GPUs. There's so much to do. But before we do that, will you join me in giving it up for our sponsors? Google DeepMind, our presenting sponsor. Let's give them a huge round of applause. For real. This would not be as amazing as it is without them, and we are very, very thankful for them. Let's also give a huge round of applause for our platinum sponsors. We got Brain Trust. Keep it going. Brain Trust, WorkOS, OpenAI. Yeah, it is a real blessing to have such sponsors that create this environment where we, as builders, can assemble, build, and be inspired. And finally, we've got gold and silver sponsors here. Give them a round of applause as well. You can find them in the expo hall that's through these doors to the right and upstairs in the breaks. I encourage you. They have some really amazing swag. I picked up from one of the companies it's a 3-button keyboard for vibe coding. You see this? It's so cool. So I encourage you, go check that out. We're going to start today with a little bit of ground rule setting, okay? The speakers have their jobs. They know what they're going to do. They're going to come here and they're going to inspire. But you have a job as an audience. Are you aware of this? You have a job. Your job is to make the speakers and presenters feel amazing. In fact, you have so much power because you get to decide the quality of the talk you watch. You can, if you make your speakers uncomfortable by like this, like, hey, prove yourself, then they're going to be nervous and anxious, and it's not going to be a good talk, okay? I know this because I speak. But instead, if you validate them, even before they prove anything, they just walk up and you're like, woo! I did that. I made that sound. No, it was not AI. If you do that, I guarantee you're going to have a great time because they're going to feel validated, they're going to feel confident, they're going to give their best, and you're going to make it easy for them. It is a conversation. It's not a monologue, okay? Is that clear? So like as the speakers come up, I want you to warm them up and give them your biggest round of applause. Let's practice. Let's do it right now. Pretend a speaker just walked up and... Woo! Exactly. It's a little bit quiet over here. I see you. Let's try that again. This time, everybody look at them. But we're gonna. I'm joking. But let's pretend one more time. Your biggest round of applause for a speaker who has just walked up. Come on. There we go. There we go. Exactly. That's why we're here. So now we're gonna introduce our first talk of the day. We're gonna introduce our first speaker. Our first speaker comes to us from Google, and we're going to hear about Gemma. Gemma is an incredible family of models. I personally love it because it's a source available set of models, and they run almost everywhere. They can be fine-tuned. It's so cool. I'm really excited for this talk. Please, we practice this. Give it up for your first speaker, Omar Sanseviero.
All right, hi everyone, it's full here. So I'm super excited to give this talk because just 7 days ago we released Gemma 4. So before this conference, who here has heard about Gemma already? Okay, so most of you, great. So Gemma is Google Deepmind's family of open models. Open models means that these are models that you can take, you can download, you can run in your own infrastructure, your own devices, you can fine-tune for your own use cases. So about a year ago, we released Gemma 3. Back then, Gemma 3 were the most capable open models that could fit in a single consumer GPU. So we designed models from 1 billion parameters all the way to 27 billion parameters. And back then, in LM Arena, it was a very strong model. So you see here like different open models under LM Arena scores. And those small dots at the bottom represent how many H100s or A100s you would need just to be able to load the models. So this is, again, Gemma 3. That's from 1 year ago. But you can see that even if it's a model from a year ago, it's a tiny model or a relatively small model that is extremely capable. But yeah, so last week we released Gemma 4, and this is my first conference talking about Gemma 4, so very excited about that. So Gemma 4 is the family of most capable of open models that Google has released ever. These are models that go from 2 billion parameters all the way to 32 billion parameters. These models have very different capabilities, so I'm going to talk a bit about these different things. And if you're wondering what's the E there, I also explain that in a second. So the smallest two models can run in an Android phone, in an iOS, in an iPhone phone as well, even in a Raspberry Pi. These are really small models that are multimodal, have reasoning, can do like very cool on-device agentic things. Then there's a MOE, a mixture of experts model that's like super fast, very low latency, a model that you can do that can do very cool things. And then you have the 31B. That's the most intelligent model, the most capable. So when you want like the most raw intelligence, you would use this large model. But even the 31B is a model that can run in a consumer GPU. So all of these models have been in developer-friendly sizes, which is quite important to us. So let me show you a couple of the most, assuming the videos load. So there's a lot happening here. So let me begin with the one at the right. That's an application where you have Gemma running directly in an Android phone, where you can pick different skills. So pretty much here you have a full agentic setup where the model is picking maybe like a skill to play the piano, and then you have Gemma playing the piano, right? The one at the left is Gemma vibe coding, also on device. This is, again, airplane mode, no API calls, fully running in a phone. And the example in the middle is in a laptop computer. We have 20 instances, or 10 instances of Gemma running in parallel. Each of them is doing a different SVG, and in a couple of seconds, you are going to see like 10 SVGs generated by different agents, all of these running on device with Llama CPP. And even then, it's like 100 tokens per second, and there you can see the SVGs that were generated by the 10 different Gemma models. Gemma is a good coding model. It can do agentic stuff, it can do coding, it can do even Android app development, and again, all of this offline. So the LM Arena scores are quite nice. Here you can see like a bunch of different models. X-axis is how many billion parameters the model has. Y-axis is the LM Arena score. And I know like LM Arena is not the perfect benchmark, but it does give you like some proxy of how much the community likes the model for general use cases, like conversations and so on. And Gemma has like a nice kind of a mix between being friendly and like helpful, and at the same time being very capable. And you can see like this corner at the top left, that means that these are very small models that are very capable, which is quite exciting. It's been exciting to see how the models have progressed over the last 2 years. So last year it was Gemma 3, 2 years ago it was Gemma 1, Gemma 2. and you can see like for a bunch of different things, the models have kept getting better and better without going bigger, which for me is quite exciting because if I think where we'll stand in a year from now or in 2 years from now, I do think we'll have extremely capable models running directly in our own devices, in our own pockets. I'll skip the benchmarks. But yeah, what is exciting is that Gemma can fit in a desktop computer, it can fit in a laptop, it can fit in a phone. I saw yesterday or 2 days ago that someone put Llama CPP in a Nintendo Switch, and they are using Llama CPP to try Gemma directly there. So I don't know how things will be in a couple of years, but I'm excited for it. Something that we heard a lot with the previous Gemma versions was that the license that we had was not great. Like people wanted a proper open source license. So with Gemma 4, we changed our license to an actual Apache 2 license that gives you control to pretty much you have the flexibility of the Apache 2 license. So that's quite nice as well. Now, you have probably heard about mixture of experts. That's the 27B model, 26B model. You have heard about transformers and dense models, but you have probably never heard about the E here. So E2B stands for effectively 2 billion parameters. So actually, Gemma E2B has more parameters. It has 4 billion parameters or so. And it has a new novel kind of architecture called per-layer embeddings. That was something that we released summer of last year. So there's this small block at the bottom. And the TLDR here is that pretty much there is like a embedding kind of per each layer, as the name indicates. And it works more of a, pretty much as a lookup table rather than a computation that you need to do. So pretty much this is an extremely fast thing. You don't need to have this in the GPU. You can have this in the CPU. You can have this in the disk. And this is an architecture decision that is really optimized for on-device, like mobile use cases. So that's why the smallest models that can run in an Android or in an iPhone are using this E2B or E4B architecture. So even if the model is 5 billion parameters, you actually just load 2 billion parameters into the GPU, and then the rest can be in like much slower memory because you are not doing any of the matrix multiplications that you would usually do with the transformer architecture. And this can be done leveraging Llama CPP with a simple flag, override tensor, and then you move the per-layer embeddings to CPU or even to disk, and it should work quite well out of the box. A couple of other exciting things. The smallest models can do multimodal understanding for images, for videos, and even for audio. So you can do speech recognition, you can do speech to translate the text, so I can speak in Spanish, and the text can be transcribed to, I don't know, French. And then the larger model can do like extremely capable multimodal understanding. So videos, fine-grained details. I actually have a couple of examples in here. So for example, it can do things such as pointing where the llama is in the picture. It can do object detection, so it can detect different objects in a picture. And what is cool is that this model is heavily multilingual, so Gemma 4 has, well, it was trained with over 140 languages, and it uses the tokenizer that is based on Gemini as well, so pretty much all of the multilingual research that powers Gemini is also enabling Gemma. The tokenizer piece is quite interesting because independently of the raw capabilities of Gemma, this tokenizer was designed for multilingual use cases, and we took lots of care with it. Which is interesting because if you want to fine-tune Gemma for a different language for which there are low digital resource languages, so let's say like an indigenous language in Peru, Quechua, or I don't know, one of the official languages in India, you can pick the model, you can use your data, you can train the model, and independently of the raw capabilities of Gemma, just because of the tokenizer decisions, things tend to work quite well out of the box. So then you can mix the multilingual with multimodal capabilities. So for example, here, to get the text or an explanation of an image with Japanese text, and that's quite cool. So we released the model a week ago. Just yesterday, we got to 10 million downloads just for Gemma 4-based models. There are over 1,000 models based on Gemma 4 already, so quantizations or fine-tunes by the community, over 500 million downloads of the whole Gemma family. So what is very cool for me is that Gemma is not just about, oh, it's a model that you can use, but it's more about enabling the ecosystem to build on top of it. And that's what the community has done over the last few days. It was top of at Hugging Face. People have been building like cool examples. The Onslaught people have been doing like full repository audits using Gemma. People are putting Gemma like in all kinds of devices and exploring all of the capabilities, which is quite nice. And all of this is not done just by us. We collaborate with the open source ecosystem. We work with Onslaught, MLX, Olama, Hugging Face, BLLM, SGLang, and pretty much we want to ensure that when we launch a new tool, both for Gemini and for Gemma, people can leverage the capabilities out of the box, right? Like they should not need to switch to Keras if they want to fine-tune Gemma. Like if they are fine-tuning with Hugging Face transformers, they should be able to do that. So for us, it's very important and critical to be where the community is. And that's why I really shout out to all of those of you that are working in the open source ecosystem, that are contributing to different tools, maintainers of all of these repositories, because it's really a way to enable the ecosystem to do amazing things. Another part that I like about Gemma is all of the product integrations that we can do. So Android Studio, I don't know if anyone here is an Android developer, but Android Studio has like a agent mode where you have an agent that helps you vibe code and develop. And there's an offline mode now where you can have a Llama CPP or a Olama or BLLM powered system in which you have Gemma helping you vibe code for Android development. And we did include some Android-related data sets and benchmarks while training Gemma. So it's actually a very capable model for Android development. So I talked a bit about how many people are fine-tuning, about how many people are sharing. So let me share a bit about the Gemmaverse. So this number is outdated. This is from last week. Now we have 500 million downloads, as I mentioned. And in total, Gemma has over 100,000 models. So again, maybe you just want to use Gemma out of the box, like open models may work great for you, but maybe you want to improve the capabilities, maybe you want to change the style in which the model is talking with the users, maybe you don't want a conversational model, right? Maybe you just want a model that can predict certain things in your own context. Or maybe you just have too many GPUs at home and you just want to burn them. I don't know what's your reason, but you can fine-tune models for many cool things. So Google has done a couple of what we call official Gemma variants. We did a Shield Gemma, which is a family of word rate models. Those are great for production use cases where maybe you don't want users to put, let's say, toxic images or toxic text that does not match the policies that you have set up. So Shield Gemma is the family of models that allows you to do that. But then there are also other kind of use cases. So for example, for medical use cases, we have released MedGemma, which is a multimodal Gemma 3-based model for different medical tasks. So radiology, X-ray, chest X-ray understanding, and a bunch of other things. And again, these are open models. You can use them, and you can also fine-tune them even more if you have like a even more niche kind of use case. So that's what Google has done. But the community is also doing cool things. So for example, there's AI Singapore. It's a group that is training models for Southeast Asian languages. There are a bunch of them, and they have been building quite a bit of research with open models to push even further the state-of-the-art capabilities in terms of multilinguality. Or another example is Sarvam. So in India, there are many official languages, and there is this effort by the government. They are investing in a couple of big startups to train national models. So this is more on the sovereign AI and official languages point of view. But people are doing very interesting stuff on the multilingual side of things. Apart of that, there is quite a bit of other cool research happening. So there was this paper we released in December of last year about how some researchers from Deepmind were able to use Gemma 3 to propose some cancer therapy pathways, which was actually taken to an actual lab, and they were able to validate that the pathways that were proposed by this Gemma-based model were able to actually lead to actual results that could be validated. So that was quite exciting because it's not just about having your assistant or chatting with doing role-playing and whatnot. It's also about building models that can be used for actual things that help the community for many different things. So be that finance or be that, legal reviews, offline use cases where you don't want your data to leave your servers, if that's for offline modes, if you're in the subway, if you're in an airplane and you need to use AI for something, if you want to have a Chrome extension that has a Gemma in there and help you understand what is in your screen, if you want to do on-device control, the open models are getting there. And for me, that's quite exciting because if you compare where we are now versus how we were 1 year ago, 2 years ago, open models now can do very cool, very interesting, highly agentic, complex tasks entirely on device. entirely in your phone. So I really recommend all of you to just spend 1 hour in the next 2 weeks. Just play with open models, the latest open models, and try to understand which are the capabilities. Of course, there are many things for which you will want to use an API-based model. If you want the most raw intelligence, you will go and use Gemini or your model of choice. But if you want to have things on device, there are many exciting things that you can already do. And for me, what is more exciting is I don't know how things will be in 6 or 12 months from now, but I think we're heading towards a very exciting direction where people will be able to have extremely capable open models in their own devices that are customized for their own use cases with their own data. So yeah, please try the models, build something, and share that. All right, thank you.
Our next presenter is here to make the case for the future of MCP. Please join me in welcoming to the stage the creator of MCP and member of technical staff at Anthropic, David Soria Parra.
Okay. Well, welcome. Let's get started. This is an MCP application. That's an agent shipping its own interface, not through a plugin, not through an SDK, not rendered on the fly by the model on the client side or hard-coded into the product. That is something that is served over an MCP server. And you can take this server, put it into Claude, you can put it into ChatGPT, you can put it into VS Code, Cursor, and it will just fucking work. And that, I think, is kind of cool, because for doing that, you need something that a lot of things that we want in the ecosystem do not offer. You need semantics. You need to have both sides, the client and the server, to understand what each side is talking, to understand how you render this, understand that there's a UI coming. And for that, you need a protocol. And the best part about this, an MCP server doesn't just ship an app, or can ship an app, it can also ship tools with it, and so you can interact with it, with the application as a human, and you can have the model interact with it through tools, which is, I think, a very unique thing that I think we have not explored much just yet. Okay, but let's quickly rewind a little bit from this, what I think is a really cool glimpse into the future of MCP, into over a year ago, 18 months, an eternity in AI lifecycle. All of this did not exist. There was just a little spec document, a few SDKs, mostly written by Claude, local only, with little more than just tools. And in that last 18 or 12 months, you guys have been absolutely crazy building stuff, building servers, building, and crazy ecosystem around this. And we on our side have been busy taking this local only thing, added remote capabilities, added centralized authorization, added new primitives like elicitation and tasks, and last but not least, added new experimental features to the protocol like the MCP applications that you've just seen. And in the meantime, we have reached, I think, a really cool milestone because, again, all of you have been absolutely crazy building, and building, of course, luckily with the help of a bunch of agents. We're now at 110 million monthly downloads. And that's just, of course, not us using it in our clients and servers. That's like OpenAI's Agents SDK, that's Google's ADK, that's LangChain, thousands of frameworks and tools that you might have never ever heard of it, pulling it in as a dependency, which means there's one common standard that all of us have at our disposal to speak to each other. Just a bit for context, React, one of the most successful open source projects probably of the last decades, took roughly double the amount of time to reach that download volume. And in the meantime, of course, you all have been building really, really cool servers, from little toy projects of WhatsApp servers and Blender servers to building SaaS integrations like Linear, Slack, and Notion that are really powering what everyone does every day when they use MCPs. But most importantly, the vast majority of MCP server most of all of us have built are behind closed doors, connecting company systems to agents and AI applications. But I still think this is just the absolute beginning of where we are. Because I think 2025 was all about exploring, and 2026 is all about putting these agents into production. Because if you really think about, in my mind, 2024, we just built a bunch of like demos and showed cool stuff to people, and there was a little bit of a buzz there. 2025 was really all about coding agents. But coding agent, if you really think about it, are the most ideal scenario for an agent. It's local, it's verifiable, you can call a compiler, like you have a developer who can fix shit if it goes wrong in front of the computer, and you can display a TUI interface, and the user is quite happy. But I think now with the capabilities of the model increasing, we are going into a new era, which I think this year we will see this start, where we're not just doing coding agents, we're gonna have general agents that will do real knowledge worker stuff, like things a financial analyst wanna do, a marketing person wanna do, and they need one thing in particular. They don't need a local agent that calls a compiler. What they need is something that could connect to like 5 SaaS applications and a shared drive, because the most important part for them, for an agent, is connectivity. And in my mind, connectivity is not one thing. If someone tells you there's one solution to all your connectivity problem, be it computer use, be it CLIs, be it MCP, they are probably pretty wrong. Because the right thing, of course, is that it always means it depends, and there's a big connectivity stack, and there's a right tool for the right job. And in my mind, there are 3 major things that you want to consider building an agent in 2026. It's skills, MCP, and of course, like CLI or computer use, depending on your use case. And they have 3 very distinct things that they can do, and 3 different things you want to consider when you build your agent. Number 1, skills, of course, is just like domain knowledge. It's just like capture specific capabilities put into a very simple file, and it's mostly reusable. There's some minor differences between the different platforms. Of course, CLI is very popular when local coding agents. It's an amazing tool to get simply started, to have something that you can compose in a bash that automatically discover, where the model can automatically discover what the CLI is capable of. And most importantly, if you have things that are like CLIs, like GitHub, Git, and other things that are in pre-training, CLI is an amazing solution for your connectivity part, and they're particularly good when you have a local agent where you can assume a sandbox, where you can assume a code execution environment. But if you don't have this, if you need rich semantics, when you need a UI that can display long-running tasks, when you need things like resources, when you need to build something that is full decoupled and needs platform independence, or you don't have a sandbox, when you need things like authorization, governance, policies, or short to say boring but important enterprise stuff, or if you want to have experiments like MCP applications, or what comes soon, skills over MCP, then I think MCP is this like additional connective tissue that's just yet another tool in the toolbox for you to build an amazing agent. And so this is all to say that I think in 2026, we're going to start building agents that use all of it. They don't use one thing, they use all of it, and they use them quite seamlessly together. But I don't think we're quite there just yet, because we need to build a lot of stuff, partially because our agents kind of still suck, and partially because I think we just haven't talked enough about like some of the techniques you can do to really put this connective tissue together. The number 1 thing that we need to go and start building is on the client side, on the agent harness side, on the things that powers the connective parts, that be it a Cloud Code, be it a Pi, be it whatever application you're going to build. And the number 1 thing we're going to do there, and what we all have to do, and something I want to really get across today, is that we need to go and start building something called progressive discovery. Most people, when they think about like, oh, MCP, they can think about like context load. But if you really consider what a protocol does, the protocol just puts information across the wire. But the client is responsible for dealing with that information. And what everybody so far has done, because we're in this very early experimentation phase, is to simply put all the tools into the context window and then be quite surprised that maybe the context window gets large. But what you can do instead, and what you should do instead, you should start using this progressive discovery pattern, which is to say, use something like tool search to defer the loading of the tools and start loading the tools when the model needs it. And we have this in the Anthropic product and the API. People can use this on competitors' APIs as well. But also you can just build this in yourself where you just don't load the tool directly. And the moment you give the model a tool loading tool, basically, and the model goes like, oh, maybe I need a tool now. Let me look up what tools I need. And then you load them on demand. And here in this example, what you're seeing is on the left side is Claude Code before we added this to Claude Code and then after it to Claude Code. So you see a massive reduction in tool tool context usage. The second part to that is something called programmatic tool calling, or what other people usually refer to code mode. This is the idea that one thing that you really want to do is you want to compose things together. You don't want the model to go call a tool, take the result, then go and call another tool, take the result, call another tool. Because what you're effectively doing is you're letting the model orchestrate things together. And in that orchestration, you're using inference. It's latency sensitive. And all of its stuff could be done way more effective if you would instead write a script. And in fact, that's actually what you constantly do and what you constantly see things like Claude Code do when it writes the bash command. But you can, of course, do this with everything. And you can do this with MCP. And you should do this with MCP. So what does this mean? So what you want, instead of having one tool out of another, you want to give the model a REPL tool, provide like an execution environment like a V8 isolate or a Monty or something like that, or a Lua interpreter, and just have the model write the code for you, and the model just executes that code and then composes them together. And there's a neat little feature in MCP called structured output that tells you what the return value of the output will be. And the model can use this information to figure out type information, which then means it can really nicely compose these things together. And in this example here, instead of doing two different calls, you do one call, and you can filter. The model will automatically remove things from JSON and just continue. Of course, if you don't have structured output, you can always just ask the model to give you structured output by just extracting it and saying, hey, call us cheap model and say, I want this expected type, give it back to me, and bam, you have a type. The model can compose things together. And I think this is something we're just not doing enough yet. And this is, I think, something where we can improve our agent harnesses. And then last but not least, of course, you can just compose these things together with executables, like with CLIs, with other components, with APIs as well. Next, what we need to do, besides the client work, which is progressive discovery and programmatic tool calling, we need to go and start building properly for agents. And that means we all need to stop taking REST APIs and put them one-to-one into an MCP server. Every time I see someone building another REST to MCP server conversion tool, it's a bit cringe because I think it just results in horrible things. And what you should do instead, you should design for an agent. Or basically, you can start designing for you as a human how you would want to interact with this, because that's actually a very, very good start for an agent. If you want to orchestrate things together, you should reach, of course, for programmatic tool calling. And you can do this on the client side, as I said before, but you can also do this on the server side. The Cloudflare MCP server and others like that are great examples how you can have, instead of providing tools, provide an execution environment to the model and then just have them orchestrate things together, which again cuts on token usages, cuts on latency, and is way more powerful in its composition. And then last but not least, you should start, and we should start as server authors, to use this rich semantics that MCP offers over alternatives. This means shipping MCP applications. It means shipping skills over MCP. It means using things like task and other aspects that the protocol offers that were currently slightly underused, or things like elicitations, things that only MCP can do for you. And of course, that's all the work you all need to do, and maybe some of our product people need to do. We also need to do a lot of work on MCP itself. And there's a few things down the line that we're going to go and have to go and solve. The number one thing is we need to improve the core. There's a few things that, as we have developed the protocol over the last year, that are just not in a good shape. Number one is that the current streamable HTTP is very hard to scale if you're a large hyperscaler. And so we have a proposal from our friends at Google who are working with something called a stateless transport protocol, which make it significantly easier to just treat MCP servers like another stateless REST server or something like that that we're used to know how to deploy to like Cloud Runs or Kubernetes and so on. So that's coming down in June and hopefully landing in the SDKs very soon. In addition, we need to improve our asynchronous task primitive, which basically is a very fancy way to say we just want to have agent-to-agent communication. We have a very experimental version of the protocol that very few clients support. So we're going to start building more clients out like that, and most importantly, we are improving some of the little semantics that we need to do. We're going to ship a TypeScript version, SDK version 2, and Python SDK version 2, based on a lot of the lessons learned over the last year. There's a SDK called FastMCP. Who's using FastMCP? Yeah. It's just way fucking better than Python SDK that we ship in, right? And that's on me because I wrote the Python SDK. And so I have a bunch of people who are way better Python developers than me help me write it better. The second part is we need to start integrate everywhere. We're going to ship particularly for enterprises, something called cross-app access. It's a new thing that we're working closely together with identity providers, which just allows you, it's a very fancy way to say, once you log in once with your local company identity provider, be it a Google, be it an Okta, you will be able to just use MCP servers without having to re-log in. So it's a bit more smoothness. In addition, we're going to add something called server discovery by specifying how you can discover servers on well-known URLs automatically. So crawlers, browsers, agents can just go to a website and say, oh, instead of just parsing the website, is there also an MCP server I can use? And we will be able to automatically discover this. This is a really cool thing that will come down also in June when we launch the next specification and will be supported there. And then last but not least, we are starting to use our extension mechanisms in MCP, which means that some clients will support this, like for example, MCP applications will only be supported by web-based interfaces, because if you're a CLI, you just have a hard time rendering HTML, right? And we will do more of these extensions. One of the most exciting extensions that I think is cool, we're just going to ship skills over MCP, because it's very obvious that if you have a large MCP server with tons and tons of tools, you just want to ship domain knowledge with it and say, oh, this is how you're supposed to use this, this is how you're supposed to use this. And it allows you as a server author to continuously ship updated skills without having to rely on plugin mechanisms and registries and other stuff. So that's coming down. There's a lot of experimentation from people already in that space. You can already do some of that today if you just give the model a load skills tool. Like you can build primitives or versions of this today without having to rely on the semantics, but of course we're going to define the semantics. Okay, so that's for me a long-winded way to say that I think MCP is actually in a really good shape, and I think in this year we're going to push agents to full connectivity. MCP will continue to play a major role. And we want, of course, your feedback. We are a very open community. We just have created a foundation. We're mostly running as an open source community with a Discord, with issues. Just come to us and tell us where the fuck are we wrong, what are we getting right, so that we can improve this on a continuous basis. So 2026, I think, is all about connectivity, and the best agents use every available method. They will use computer use, they will use CLIs, they will use MCPs, and they will use skills. Because they want to have a wide variety of things they can do, and then they can ship cool stuff like this, which is one of the product features we shipped recently. Under the hood, it's nothing but an MCP application that renders stuff, right? Cool. So we can now look at the model writing graphs. Anyway, thank you.
Our next presenter is the creator of AgentCraft and MCP UI, here to speak about agent orchestration. Please join me in welcoming to the stage Ido Salomon.
So, good morning, London. My name is Ido Salomon. I'm the creator of AgentCraft. I am also the creator of MCP UI and creator and co-maintainer of MCP Apps. So I'm building some of the stuff that David has been talking about. As you've all heard in the past day, agents are amazing. But if one agent is so amazing, why don't we scale up to 10 or 20 or 100 different agents and be 100 times more amazing? It is pretty simple. We just spin up a bunch of agents, we put them in this nice screen, and it looks really glorious. But it won't actually work. And the reason is that spinning them up isn't the problem. It's us. We are the bottleneck in orchestrating all of these agents. Now, if you think about it, the role of the engineer to actually go and manage dozens of reckless employees is not typically what we do in most companies. So we need to somehow find these potentially new skills to manage all of these agents. Luckily, they're not really brand new. It's not something that we've never done before. It's just something that's been hiding in unexpected places. I mean, if you're a gamer or used to play games at any point, managing dozens of units probably sounds a little bit familiar, which is why I built AgentCraft, which is an orchestrator that aims to raise the ceiling of human-agent collaboration by taking learnings from gaming and transferring them into productivity. So let's see a quick walkthrough of that, and let's understand the journey to raise that ceiling. So this is AgentCraft. There's a lot to unpack, so we'll just start with the basics and go from there. This is an agent, not a metaphorical one. This is actually a physical manifestation of a coding agent, like a live session. It can be cursor, it can be Cloud Code, Codex, OpenClaw, whatever. It's something that we can detect on the device and visualize it, but it's also something that we can spawn directly from here. So now we have this agent, and we can prompt it. We can use it like just any other agent that we have from our CLI or whatever. And what can we tell it to do? It has all of these quirks, and we have voice, and we have text, and we have images, and so on. And we can just tell it to do stuff. So for example, we can tell it to develop some feature for us.
Prompt.
And now the agent is working. So it's doing its work. So it's doing work. And as we can see, if you look at the UI, there's like a bunch of other stuff. We have these buildings, and each building represents some functionality. So for example, one of these buildings manages the skills and plugins, and so on. There's also like integrated terminal and Git, just to get that end-to-end workflow. The second part of raising the ceiling, now that we have the basics, is visibility. We need to be able to quickly understand what each agent is doing. So we have this nice side panel here that really shows us like high-level mission, status, summary, and so on, what are they actually doing. But the cool thing about AgentCraft is that we don't just see a list of what they can do. We can actually see them working. So if we look at the map, you would notice that it's actually a projection of my file system. Each part of my file system is actually on the map. So I have these directories here, and each one of these directories has files. These files are represented as runes, as you can see here. So I can actually track and see visually what the agent is working on, which file. I can see the entire change list of what happened there. And because we're orchestrating it, I also know which agents did what and when. So we can have full lineage of what's going on. And we can take this one step further. If I know all of this stuff, why not just create a heat map? I can actually try and visualize collisions, and I can even prevent them proactively. Now, the cool thing here is that once we have this visibility, we're not exactly done yet, because we still need to be able to react to the changes that are happening. So we can lean into another cool mechanism from RTS games. We can simply use muscle memory to quickly cycle between the agents that need our help. They need us to approve the plan, they need us to answer some questions, and so on. So now we have visibility, and we can react quickly. So we're done. We solved orchestration. But not quite, because that's really only the first step. I was able to use more agents in parallel, but only for a short amount of time. There are a few reasons for that. The first one is that there's only a limit to how many ideas I can have in my head at any given time without being tired. So what I did is basically tell the agent to do it. I told them, OK, find missions for me to do. So I have quests now, and I can click a button, and they just do whatever. They can refactor, test, all the stuff that I don't want to do. And the second one is that all of this babysitting takes a lot of time. Like I see what's going on. I can react to it very quickly, but I still need to cycle through it. So what I did there is kind of say, how do I take myself out of the equation as much as possible? So if agents are so amazing, why not just let them do it? I can just give them some idea. I have this campaign feature. Broadly say what I want to happen, and I would just spin up a container. I would let the agents run there. They can decompose the task. They can plan it. They can present the plan to me. I don't care what they're doing because it's containered, so do whatever. And the main thing here is that once it's decomposed, I'm not the one doing the babysitting. Now I have the campaign orchestrator, and that's his problem. So we're actually moving more of the effort only to the planning phase or the review phase. And once we have that, we reach a point where we can just say, why is it my ideas? Why can't I tell it to have run in a cron job, go to Twitter every day, scan cool ideas, and just implement them, not just decide what I want, which is actually how I implemented channels pretty quickly. So we have that, and now just have a lot of different PRs to review. So there's this nice capability of just review bundles, and now I can see exactly what changes happened in each one, like why did they do stuff, what are the tasks, and I also have visual evidence. So now I'm able to just look at screenshots, I can look at videos and really see what's going on without investing too much time in doing it. And once we have that, we can actually shift more of the work from the planning to the review. How much time do I need to spend on the plan if I can just do it 10 times, and I'll just pick the one that is most fitting for me? And the next part is, we're still not done. I mean, if you think about it, this is only the first step, because agents aren't that smart yet. So we need to offload it to someone else, humans. Now, what I can do, and this is my favorite feature, is that we can actually create these workspaces. So I can collaborate with the product designer from my team, and they can do whatever they want, and I can just continue from where they left off. So, for example, let's say this is an agent actually from the product designer on their computer. So they can see my agents. I can see their agents. I can understand what they're doing, and we can just collaborate.
Prompt.
Yeah, they just started working again. So I can see that they want to design this new page, which is pretty cool. So I can wait for them to finish, or I can just go ahead now and just hand off from them to my agents, well, our agents, insert communist, whatever. So we have our agents now, and I can just keep going from there. And the cool thing is that it's not just human-to-human collaboration. We are also collaborating with the agents. So there's more direct stuff like this. I can just type stuff and prompt my agents, or even their agents. But there's also a softer mechanism. There's actually a chat that is between humans and humans, but also between the humans and the agents. You can see here that the agent said, I'm starting to work on something, and then I can say, I'm also working on it. So the next time the agent does something, it knows someone else is working. They can also have soft collaboration, so they would know what files each one is changing. So we've actually taken a bunch of stuff that were limiting us from really reaching our full potential with agents and kind of solved them one by one. There are a bunch of other features that I just didn't have time to go over, but you can try them out and see for yourself if you can really work better that way. So to sum up, these are not exactly new skills. I mean, you're probably worried, perhaps, that we won't be able to get adapted to this future where we're not actually coding, we're just telling other people to code for us, or other agents. But these skills are there. They're just not something we used for work until now. So with games, as one example, we can take these skills to the next level. We need to somehow raise that ceiling. We need to somehow improve our collaboration with agents. And with AgentCraft, the goal is to take the learnings from games and really raise that to the next level with better visibility, more autonomy to the agents, and human-to-agent collaboration. So I invite you to go to the website. This is the QR code. It's free. You can just download it and play with it. It's still experimental. It's still new. There's a bunch of stuff that needs to change. But it will only happen with great feedback. There's also a Discord. So please join, give us your feedback, and let's raise the ceiling together. Thank you.
Our next presenter is the creator of one of the top coding agents, Pi, which is the engine inside OpenClaw. So naturally, he's here to tell us how agents are destroying open source software. Please join me in welcoming to the stage the creator of Pi, Mario Zechner.
Hey there, I'm Mario. I built Pi in a world of slop, and this is a tragedy in 3 acts. Just to talk about this real quick, a bunch of people on the internet gave me money for ad space on my torso, and all of that goes to a charity, so yeah, thanks guys. So, Act 1, building Pi. In the beginning there was Claude Code, and it was good, right? We all got basically catnipped by that thing and stopped sleeping. Bunch of stuff before that, but Cloud Code was the one thing that kind of clicked with me the most. And to preface all of this, I love the Cloud team. They're brilliant people, talented, super high velocity. So they also created the entire game. Major props to them. So this is not a roast. This is just me, an old man, telling you why I stopped using Cloud Code and built my own thing. In 2025, I started using Cloud Code in about April, I think, thanks to Peter, because he told us the agents are working now. And back then it was simple and predictable and fit my workflow. But eventually the token madness got hold of them, I think, and the team got bigger and they started dog fooding that stuff and built a lot of features I don't need, which is fine, I can just ignore them. But with velocity and more features come more bugs, and that's bad because I used to work at construction sites, and if my hammer breaks every day, I'm getting really mad. And if my development tools break every day, I'm also getting mad. So there was this. It's just a running gag. And here's Tarek telling us that Cloud Code is now a game engine. And here's Mitchell from Ghosty telling us, no, it's not. And eventually they fixed the flicker, but then other stuff broke. And I think they're now in the 3rd iteration of a TUI renderer. Yeah, but that's just a symptom. The real problem is that my context wasn't my context. Cloud Code is the thing that controls my context. And behind my back, Cloud Code does things to the context. So you have the system prompt, which changes on every release, including the tool definitions. They would remove tools, modify tools. It's not good. They would insert system reminders in the most inopportune place in your context, telling the model, here's some information. It may or may not be relevant to what you're doing. That it actually says it may or may not be relevant what you're doing. And that kind of confused the model, and that kind of broke my workflows. On top of all that, there's zero observability, because that's how the tool is constructed, and I like knowing what my agents are doing. There's zero model choice, which is obvious. It's the native Anthropic harness, so it makes sense for them to want you to use Claude, right? And there's almost zero extensibility, and some of you might have written some hooks for Cloud Code, but I'm telling you, the number of hooks and the depth of those hooks is very shallow. And every time a hook triggers, what actually happens is a new process gets spawned, basically the command you specified for that hook to be executed. And I don't find that specifically efficient. So I took a step back and looked around for alternatives, and I'd like to especially call out AMP and FactoryDroid, the Porsche and Lamborghini of coding agent harnesses. So if you can afford them, please use them. They're at the frontier. They're really good, and the teams are fantastic. And there's a bunch of other options. And I have history in OSS, so naturally I kind of gravitated towards OpenCode. And again, brilliant team, super high execution velocity, and they don't sell you hype, they sell you tools that work for the most part. I started looking under the hood of OpenCode with respect to context handling as well, because that's the most important part for me. And I found a bunch of things like, given some conditions, OpenCode would just prune tool output after a specific minimum amount of tokens. And that basically lobotomizes the model. There's also LSP server support, which means every time your model is calling the edit tool, OpenCode goes to the LSP server that's connected, asks, are there any errors? And if so, injects that as part of the edit tool result. Which is bad, because think about how you are editing code. You're not writing a line of code, checking the errors, writing the next line, checking the errors. You don't do that. You finish your work, and then you check the errors. This confuses the model. There's a bunch of other things, like storing individual messages of a session in a JSON file. Each message is a JSON file on disk. There was this, and this happens to all of us, no blame there. But it's not great if, by default, a server spins up, course headers are set in such a way that any website you open in your browser can now access your OpenCode server. That's, yeah. And entirely unrelated to all of this, I started looking into benchmarks for coding agent harnesses and found Terminal Bench, which is a pretty good benchmark, all things considered. And the funny part about it is that it's the most minimal kind of thing you can think of. All it gives the model is a tool to send keystrokes to a Tmux session and read the output of that Tmux session. There's no file tools, no sub-agents, none of that stuff. And it's one of the best performing harnesses in the leaderboard. Here's the leaderboard from December 2025. Irrespective of model family, Terminal scores higher, mostly high, even higher than the native harness of that model. So what does that tell us? I formed two theses. We are in the fuck around and find out phase of coding agents, and their current form is not their final form, right? So, second thesis is we need better ways to fuck around. And for me, that means self-modifying malleable agents. Things that the agent itself can modify and I can modify depending on my workflow. So I stripped away all the things, built a minimal core, but made it super extensible, and made it so that the agent can modify itself. With some creature comforts. It's not entirely bare bones. So that's Pi. It's an agent that adapts to your workflow instead of the other way around. It comes with 4 packages. An AI package is basically just an abstraction across providers and context handoff between providers. An agent core, which is just a while loop and the tool calling. Bespoke TUI framework. I come out of game development, so I built a thing that actually doesn't flicker too much. And the coding agent itself. Here's Pi's system prompt. That's it. Eventually, the industry created a new standard called skills, which is basically just Markdown files. So we added that as well, and that needs to go in the system prompt. So begrudgingly, we had to add a couple more lines. And finally, here's the magic that makes Pi able to modify itself. We shipped the documentation, which was handcrafted by me and an agent, and code examples of extensions. And all we need to do for the agent to modify itself is tell it, here's the documentation, here's some code that shows you how to modify yourself by writing extensions. It comes with 4 tools. That's all it has. Read, write, edit, bash. Here's the tool definitions. Don't read the text, just look at the size. That's it. Here's what happens when you start a new session in one of these tools. So the thing is, the models are actually reinforcement trained up the wazoo, so they know what a coding agent is, because a coding agent harness is basically what they're being trained when they are post-trained. You don't need 10,000 tokens to tell them you're a coding agent. They know, because they are coding agents now. Pi is also YOLO by default, because my security needs are different than yours, and I don't think a little dialog that pops up every time you call bash, asking you to approve, is a smart security mechanism. So instead, I give you so much rope that you can build anything that's fit for your specific security needs. There's also stuff that's not built in. I'm a heathen, because this is how I do it. But if you don't like that, then you just ask Pi to build you sub-agent support, or plan mode, or MCP support, whatever you need. Extensibility comes with a bunch of table stakes, and then with the extensions itself. And extensions in Pi are just TypeScript modules. In the simplest case, a TypeScript file on disk. You point Pi at that. Here's an extension, load that as part of the harness. And with that, you get basically an extension API that lets you hook into everything and define stuff for the harness to expose to the model. And that includes tools, / command shortcuts. You can listen in on any kind of event and react, and then save state in the session that's optionally provided to the agent as well, or stored there for tools that analyze sessions as part of your organizational workflows. You can do custom compaction, custom providers, and you have full control over the TUI, so you can modify everything in Pi. And you can then bundle all of that up and put it on NPM or on GitHub, because I think we don't need to reinvent another bunch of silos called marketplaces. We already have package managers. And all of that hot reloads. So if you develop an extension for Pi, you do so in the session, and you hot reload the changes and see the effects of that immediately, which is very great, and that's also game development thing is, in game development, you want very low iteration speeds, and that's great. So a couple of examples. Claude or Anthropic ships the / by the way, which lets you talk to the agent while it goes on its main quest. I posted this little prompt on Twitter, jokingly, and somebody built it in 5 minutes with more features. And they didn't have to fork or clone Pi. They just let the agent write the extension based on the prompt. Here's Nico. He's one of the most prolific extension writers. I don't know what the fuck is going on here. It's a chat room for all of his Pi agents, and they talk with each other. I would never use this, but all of this is custom, including the UI. Or you can play NES games. Or you can play Doom. And there's a bunch of other examples I'm not going to talk about. So how do you build a Pi extension? You don't. You tell Pi to build it for you based on your specifications, and then you just iterate with it on that and hot reload during the session. I'm going to skip that example as well. And if you don't like building things yourself, and I hope you do like building things yourself, but if you don't, you can look on NPM or our little search interface on top of NPM to find packages for sub-agents, MCP, and so on. So does it actually work? Well, here's the terminal bench leaderboard from October, before Pi had compaction. I added that for Peter's claw thingy. It scored 6th place. But none of this is actually about Pi. If you want to retake, I basically want you to retake control of your tools and workflows. So build your own. And if you want to know more about Pi and OpenClaw, go to this talk, please. Yeah, and then eventually Peter happened. He put Pi inside of OpenClaw as its agentic core, which meant my open source project became the target of a lot of OpenClaw instances, unbeknownst to their users. So this is Act 2, OSS in the age of clankers. Clankers are destroying OSS. Here's Tildraw. They closed down the issue and pull request tracker. Here's OpenClaw's trackers. Here's mine. Half of that is OpenClaw instances who post garbage. So I started to rage against the clankers. If you send a pull request, it gets auto-closed with a comment that asks you to please write a nice issue in your human voice, no longer than a screen worth of text. And if I see that, I write, looks good to me, and your account name gets put in a file in the repository, and the next time you send a pull request, it's let through. Clankers don't read that comment. They don't go back once they posted the pull request, so that's a perfect filter. Mitchell eventually turned it into Vouch. Here's a clanker. I also labeled them. If you had interactions with OpenClaw, your issues get deprioritized. I also built tools where I embed issues and pull request texts into 3D space, so I see clusters of issues. I also invented OSS vacation. I just close the tracker whenever I want, so I have my life back. So does this work? Yes, sort of. Which leads me to Act 3. Slow the fuck down. Everything's broken. And then there's people that say, our product's been 100% built by agents. Yes, we know, it fucking sucks now. Congratulations. And I'm hearing this from my peers, and this is entirely unhealthy. So here's how we should not work with agents and why, at least in my opinion. I wrote this on my blog a while ago, but the basic gist is, we're having army of agents, and you're using beats, and you don't know that it's basically uninstallable malware. And Anthropic built a C compiler. It kind of works, but actually doesn't. And we're hoping the next generation of mods will fix it. And here is Cursor building a browser, and that's also super fucking broken. But the next generation will fix it. And SaaS is dead. Software is solved in 6 months. And my grandma just built herself a Spotify with her OpenClaw. Come on, people. So agents are actually compounding boo-boos, which is my word for errors, with zero learning and no bottlenecks, and delayed pain. The delayed pain is for you. Here's your code base on a human, on 1 agent, and 10 agents. How much of the agent code can you review? Here's the same code base, but expressed in number of boo-boos per day. How much of those boo-boos do you think you'll find? Then you say, oh, I have a review agent. Let me introduce you to the wonderful world of the Ouroboros. Doesn't work. It catches some issues. The problem is that agents are merchants of learned complexity. Where did they learn that complexity from? From the internet. What's on the internet? All our old garbage code. There are some pearls on the internet, really well-designed systems, but 90% of code on the internet is our old garbage, and that's what the models learned from. And every decision of an agent is local, especially if the code base is so big that it doesn't fit into its context, and if you let it go wild and add abstractions everywhere that are intertwined. So that leads to lots of abstractions and duplication and backwards compatibility. Who has seen that in the output of their agent? It's fucking annoying. Or defense in depth. So yeah, you get enterprise-grade complexity within 2 weeks with just 2 humans and 10 agents. Congratulations. And then you say, but my detailed spec. Yes, sure. You know what we call a sufficiently detailed spec? It's a program. So if you leave blanks in your spec, what do you think happens? How does the model fill in the blanks? And with what does it fill that in? It fills it in with the garbage that it learned on the internet from our old code, which is garbage to mediocre. And then you say, but humans also. Yes, humans are horrible, failable beings, but they can learn. And they are bottlenecks. There's only so many boo-boos they can add to your code base on a daily basis. And humans feel pain, which is a very interesting property because humans hate pain. And once there's too much pain, the human has a bunch of options. It can quit their job, it can blame somebody else and make them fix it, or everybody bands together and starts refactoring the shit out of the garbage code base, right? Agents will happily keep shitting into your code base. And now, your agents MD and super complex memory systems will not save you. Agents don't learn the way we learn. Those are my most beloved people. I don't even read the code anymore. Congratulations. Something is broken and your users are screaming, so who are you gonna call? Not yourself, because you haven't read the code. So you're relying on your agents, but they are now also overwhelmed because the code base is so humongous that there's absolutely zero chance they can get all the context they need to fix the issues. And long context windows are a hack, as most of you will find those this year, as everybody's switching to 1 million tokens context windows. And agentic search is also failing. So the agent patches locally and fucks shit up globally. If you see this in your code base, you're fucked. So you cannot trust your code base anymore and also not your test because your agent wrote your tests, so good game. So here's how I think we should work. There's a bunch of properties for good agent tasks. That means scope. If you can scope it in such a way that the agent is guaranteed to find all the things it needs to find to do a good job, you're done. That means modularize your code base. If you can give it a function to evaluate how well it did the job, even better. Hill climbing, auto research. Anything non-mission critical, let it wipe. Boring stuff, let it wipe. Reproduction cases for user issues, which are usually only partial in information, perfect. I don't spend any mornings anymore doing that. Or if you don't have a human near you, rubber duck. So lots of tasks you can use them for and save time. At the end of that, you evaluate. You take what's reasonable, most of it isn't, and then finalize. My final slide, more or less, slow the fuck down. Think about what you're building and why, and don't just build because your agent can do it now. That's stupid. Learn to say no. This is your most valuable capability at the moment. Fewer features, but the ones that matter, and then use your agents to polish the shit out of that. Enlighten your users, not your token maxing desires. Cap the amount of generated code that you need to review. And non-critical code, sure, wipe slop ahead. Critical code, read every fucking line. See the keynote after me for more info on that. So how do you know what's critical? Any guesses? Well, you read the fucking code. If you do anything important, write it by hand. You can use a clanker to help you with that, but don't let it make the decisions for you, because we've learned all the decisions it makes are learned from the internet. And that friction is the thing that builds the understanding of the system in your head, which is important. And it's also where you learn new things. And all of this requires discipline and agency, and all of this still requires humans. Thank you.
Our next presenters will make the case that the friction is your judgment. Please join me in welcoming to the stage creator of Flask and founder of Earendil, Armin Ronacher, and software engineer at Earendil, Cristina Poncela Cubeiro.
Good morning. Morning, thanks for having us. Today I want to talk with Cristina about friction a little bit. This is a social preview that came up automatically when someone submitted an issue to basically, this is a forum post that goes with a security incident that was deployed accidentally. It was a configuration change that caused the problem. And the social preview post had the marketing tagline of that company, which said, "Ship without friction." And we want to encourage to add a little bit of friction to it. And I'll tell you why. So who are we? I've been doing software development for 20 years, most of it in the open source space. I have created Flask, which is a Python framework, which ironically is so much in the weights that a lot of people are learning about it now because the machines are producing it. And I left my previous company that I worked for, Sentry, in April last year, which perfectly coincided with me having time and then obviously Cloud Code. And so I fell deep into a hole of agentic engineering, and I started writing on my blog, and a lot of people reached out to me over the last year being all excited about this. And then I started with a friend in October, a company called Earendil, where we are trying to make sense of all the AI things.
Yeah, and my name is Cristina, and I work with Armin at this company called Earendil. But importantly, I am what I like to call a native AI engineer. And what that basically means is that these tools have been around longer than I have. So what this means is like they've been super foundational in how I've become a software engineer, not just because obviously I use them to work, but also because this is the means by which I've learned to do what I do. And before Earendil, I was working at Bending Spoons.
So we want to share a little bit from practice, not just theory, but I will readily admit that I don't think I have all the solutions. So we have been building with or on agents for a good 12 months. We had huge leverage and great disappointment. And we really keep running into two types of problems. I think especially if you listen to some earlier talks at this conference, you will have learned a lot about that you should keep using your brain. For some reason, it's really, really hard. So there's a psychological problem, and the other one is the engineering challenge. It's like they seem to be producing worse code for some people and better code for some other people, and like what is it that actually makes that work? And so this is really not a solution as it is our part of the journey of how we think so far we have managed. Yeah. So problem number one is the psychology part, which is like, why is it, even though everybody told you many times over that you should be using your brain, you should be slowing down, it's actually incredibly hard. It's just one more prompt, and we don't sleep that much. Like, what is it that actually makes it so hard? And then, would it be that hard if the machines would actually be writing perfect code and we wouldn't have to think quite as much? And like, what is it? Is there something we can do to make this a little bit better?
So I'll begin by introducing the first part of these problems, the psychology problem. And what I want to talk first about is the shift. So I'm sure a lot of us here who have been playing with these tools for a while now experienced this at some point. We were prompting, not so good. And then at some point, suddenly it clicked, and they were really, really useful for us. And it was fun in the beginning, and they gave us a lot of extra time, right? Because not everyone was using them. They were actually tools that made us more productive, that made it more fun to do our jobs. But very quickly, because they were so useful and they got us so hooked, everyone was using them. And so this kind of had the opposite effect, where suddenly the baseline expectation was just that everyone is now using them, and you have to use them. And so this fun and free time translated into pressure. Now we all have to ship faster and produce more code, and it is just not sustainable to review and to actually have time to think. And so this leads us to the trap. And I actually think there's two parts of this problem, of this trap. And one of them, a lot of engineers have spoken about, and it's that these tools are super addictive. You never know if that next prompt is going to be the one that makes your product work, and you've added a new feature, or if it's going to be that last drop of slop that brings your product crashing down. And so it's very addictive. We keep doing what we're doing. It's not a great solution. But also, most importantly, and I don't think we realize this as much, is that because we produce a lot of output very fast, we are tricked into thinking that we're actually being more efficient, doing more work. And this is quite the opposite, because now we don't have as much time to actually stop and think and design what we're doing, ask ourselves, is this the best way in which I can implement this, or could I be doing something better? And when you're in this flow, it's very difficult for yourself to stop, and it's definitely very difficult for your agent to stop, because it's running around and it's reading files that it should have never even read. So we are the ones that need to actually have the agency to be in control here.
And one thing that if you start scaling this from like one person to an engineering team, that actually took me quite a while to realize, is that it really changes the composition of the engineering team. We were really supply constrained by creation of code, and so like the balance between writing code and reviewing code in engineering teams was usually quite decent. Now every engineer has a multitude of producing power compared to their reviewing power, and so obviously we are piling up on pull requests, but we are also slowly starting to expand the total amount of humans in an organization that are participating in the engineering process. I talked to a lot of engineers over the last year, and increasingly one of the things that came up is like, now I have marketing people shipping code. I have former CEOs, CEOs that used to be like engineers now shipping code again. And so the roles that those people have in the companies also doesn't give them, there's not that much, the responsibility doesn't rest in them. The responsibility still rests with the engineering team. And so the total number of entities, both humans and machines, that are participating in the code creation process outnumbers the ones that can carry responsibility. We're not there where the machine can be responsible for the code changes. And so that has led to more and more code reviews being skipped, being rubber stamped. And on the goal to small PRs that we want to see again so that this reviewing process goes, this amplification is something that at the very least we need to recognize. And so when you get this pull request that looks really daunting and has 5,000 lines of code in it, this is actually when you should be thinking, and that's exactly when it's the most overwhelming. And increasingly we're tapping out of this. On the engineering side, what we're doing is we are creating larger pull requests. We're creating these massive changes because it is free now, right? And if you think about how the agents work, they're really optimized to creating code that runs. Like their main objective is write some code, run the tests, make some progress. The reinforcement learning sort of gets this in. And so the agents are writing kind of code that is when you as a human, as a software engineer, start learning how to write code you wouldn't necessarily write. So for instance, you see quite a bit of code that tries to read a config file, and if it doesn't read the config file, load some defaults. And as an engineer, you know that's actually not great because I might not notice that I'm reading the default config file. And so I might only discover that I have a massive problem after 2 hours when I already wrote database records with wrong data. And so these machines, they optimize towards making progress, towards shipping stuff, to like unblocking themselves. And as a result, they're creating many more failure conditions than human written code normally would do. And in parts, it's because you as a human feel a little bit of you feel bad when you write code like this. There's something that sort of builds up emotionally in yourself. But the agent doesn't have a reason for this. It doesn't feel anything. And so if you create these services that are sort of hobbling along and they're actually willing to recover from local failures, you actually create very, very brittle systems. And this also means that you're very quickly creating a code base of the size and complexity that the agent itself can no longer dig itself out from. It's going to start no longer reading all the files that it should. It's creating code in a new file that it has already done somewhere else. And so this entire machinery over time creates much more entropy in the source code than you would normally have if humans were on it. And a big part of this is that humans feel bad and the agents don't really have any emotions that they communicate to you.
But as Armin likes to say, don't worry, not all is lost. We have found some correlation between what the agents really excel at doing and the types of code bases that we actually put them to work into. And for example, the main example here is libraries versus products. What we found is that for libraries, they tend to excel a lot more. And this makes sense because intrinsically, when you're building a library, you tend to have a very clearly defined problem that you're trying to solve. And most of the time, you can even map the set of features that you want to build to the API service, and it has very tight constraints. And because this is something that you probably want to build on top of or make accessible to other people, it's likely that it's going to be a very simple core, in which you can then plug into. And on the other hand, products, and perhaps this is a bit more unlucky for the rest of us because we all probably are more into building products, it's much harder because there are so many interacting concerns and components. Like, for example, you have your UI, your API response, you have different permissions depending on the feature flags, the billing, and so on. And so there's this very heavy intertwining between different components. And what this means is that for the agent itself, it's impossible to fit all of this into its context window. It has no way to actually understand the entire global structure. And so locally, the agent tends to be very reasonable, but when it gets to the global scale, it becomes a bit demented. So what we're proposing here is that just as you would do with any type of system design in the past, your code base has now become infrastructure. And as such, you have to design it in the way so that it is also legible for the agent, and it can make the most of it. And so this is what we're proposing is an agent-legible code base. And one of the main points that is very clear to all of us, I'm sure, is modularization. So like we have different components, and this makes it easy for the agent to add one feature in one spot without corrupting everything else. But importantly, this also means modularizing your code flow itself. So for example, I've been working on some refactoring. We're building somewhat of an AI assistant. And for me, it was super important to understand which steps of my code are actually like the main points. So say like you get user message, then I pass the message to the agent loop, and then I have to deal with the output. And this is where these points are very clearly defined for me, so the code was not as messy. But it happens to be that between these points, between these steps, that's where the agent tends to add the most fuzz. So it will be parsing between different types. It's adding things to state that shouldn't be in state. And so you end up with these behaviors that you didn't want to support and that are unexpected and can be quite dangerous. Another point is trying to follow all of the known patterns, because I think we all know by now, there's no point in fighting the RL, the reinforcement learning. The more we can lean into it, the better that our output is going to be, and it's also more scalable down the line. Then as mentioned with libraries, like if you have a simple core and you push the complexity to other abstraction layers, then it's going to be easier for yourself and the agent to be able to read your code base. And no hidden magic. So for example, here, using React Server Actions or using ORM instead of raw SQL, what this does is that it hides intent from the agent, and if the agent can't see something, it can surely not respect it. And so, to be more precise, these are the examples of mechanical enforcement that we have been using at the company. And most of these we actually achieve with linting rules. So the main example would be no bear catch-alls. Great. Imagine that there's an example here. The agent found a bear catch-all and it was like, oh no, this is bad, edited it. But yeah, so we also try to have our SQL always in one query interface so that the agent doesn't have to go hunting around the code base, finding all of the different places, because if it misses one, then you can have breaking behaviors, and again, that's dangerous. We try to have one primitives components library for the UI and not have any raw, for example, input boxes, so that we always have one type of styling, it's very consistent, one kind of behavior. We don't have any dynamic imports. And this may not sound as important, but actually we enforce unique function names. And the reason for this is not just more legibility for you and the agent, but it's actually also the token efficiency. So if your agent is grepping for a specific feature or something in your code base, if it only gets one output, it's going to be much better at continuing with the loop. And we've started exploring something recently called erasable syntax-only TypeScript mode. And what this does is that your code is basically JavaScript, and it has the type annotations on top. And this means that there's no transpiling direction, because there's one source of truth between your actual code and the compiler. And so when the agent is looking for errors, it doesn't have to have this confusion of, oh my God, where am I looking at? It's much better at finding them.
And so the goal really is get in this loop somehow, get the agent to produce as good code as it can, but you really need to find a way to feel the pain that the agent doesn't feel, and you need to be woken up in a way when you should be looking at this. And one of the things we have been doing is we build a Pi extension for our review needs, where we are separating out the kind of input that normally would go back to the agent. So this is mechanical bugs. It is where it clearly violated agent's MD. But then we specifically call out the kind of changes where the human's brain should reactivate, right? It's like, we don't think that a database migration should ever go in without a human making a judgment call on this, because it very much depends on the logs, the size of the data in production. If there are permissioning changes, you better think about this themselves rather than the agent, because they can be underdocumented. That's just some examples where we learned if we miss it, we regret it, and you will miss it. But these machines can help you find this, and then you see this, and then you actually get a little bit of a hit. It's like, oh, now I have to kick into gear and do something here. This is what this looks like in Pi. You have on the bottom, you have the human callouts. On the top, you have what's basically, if you were to end this review and say, like, fix the issues, the agent would go back and automatically act on the first two. But this is the moment where I will now go and see, like, is this a dependency I actually want to have in this code base? Like, do I like the maintainers? Does this work for me? And we obviously like the speed. Like, this is addictive. It is great. We feel there's a lot of productivity. But it is so devious if you start relying on that speed where you really shouldn't. And so I can only encourage you to find the areas where you have this feeling that this is actually net positive. For me, a lot of this is reproduction cases. Like, when a customer reports an issue, I can have the agent reproduce this perfectly, and I have a really good starting point. Exploring different type of product directions for as long as you commit yourself to doing this with the code that it generates. All of this is great, but on the other hand, system architecture, creating reliability in the system, they are not just very good at. Because we really still have to go slow. There is so much mess that can appear in a code base in so little time. Mario was already talking about this earlier, but like, we forget that we are producing months and months of technical debt in a time of weeks, in a time of days sometimes. And it becomes so much harder to actually understand what's going on in this code base. When the understanding of your own code drops, it is really, really hard. And it's also psychologically hard. I've found some code pieces that actually didn't work in production, and I was kind of frustrated learning that I was the one that committed it with the agent and just didn't really see that. It's a very disappointing experience when it happens, and then you realize that you actually were the one that screwed up. And so it is psychologically incredibly hard to really judge objectively the state of the code base. And the only way right now is to really slow down a little bit on that front. And this friction, I know that friction, like every engineering team I've ever worked at said, like, we need to get rid of the friction in shipping, and that is true. Like, there's a lot of stuff that's very, very annoying and shouldn't be there. But if you have worked in large enough engineering org, SLOs are a great system that is intentionally designed to put friction into the engineering process, to make you think, do I need this reliability? Do I need this criticality of the service? Am I sufficiently staffed to run it? And with the agents, we have now gotten into this idea that we should get rid of all of this, when in all reality we need of it. Because the friction actually in many ways is what's necessary on a physical level to steer. Like, without friction there is no steering, and that is really necessary. So you should put a little bit more of a positive association to this idea of friction, because this is really where your judgment is, this is where your experience is, and you should be inserting that and start feeling it. Thank you.
Thank you.
Ladies and gentlemen, please welcome to the stage for a special announcement. The co-founder and creative director of the AI Engineer Conferences, Benjamin Dunphy.
This event has been a dream of ours for some time. Swix and I are based in San Francisco, but Europe has always been on our minds. Sean lived in London for 2 years, working in finance in Moorgate. I spent a semester here in college, Erasmus, as you call it, and fell in love with the energy of this city, particularly the diversity. London felt like a natural melting pot for all of Europe and beyond. And the model for this event in Europe has been our World's Fair event. That is, a large multi-track event with general session keynotes, multiple breakouts, and a thriving and exciting expo. This wonderful venue and its lovely people has served us a fantastic first step into Europe. But we're just getting started. And given that we sold out this event nearly a month ago, we plan on at least doubling the size of this event for next year. But if you don't want to wait until next year, we encourage you to join us at our flagship event in San Francisco, the AI Engineer World's Fair. Over 4 days, from June 29th to July 2nd, we'll gather the edge of AI engineering at Moscone West, the crown jewel of San Francisco's convention centers in the heart of downtown. And today, I'm excited to announce our sponsors for this event. Our presenting sponsor, which is sold out, Microsoft returns for the 3rd year running as our presenting sponsor. Let's give it up for Microsoft. When Sean and I were first looking to start this World's Fair brand, we needed an anchor sponsor. You don't just do something like this without financing, so they're helping us do that, and also our great content partner. We have a new tier, lab sponsors. This is also sold out. Google DeepMind is coming in as a lab sponsor, OpenAI, and Amazon AGI Labs. Anthropic, we're holding one for you, but we can't hold it forever. So David, all of you from Anthropic in the green room listening, watching, let's make some calls to marketing, DevRel. Track sponsors. These are the companies who are essentially running their own conference within World's Fair. So they're big content partners, and we're excited to announce these are sold out to Sneak, who's running security, Arise, who's running eval, and Neo4j, AI in the industry, AI in the enterprise, sorry. Our platinum sponsors also sold out. These wonderful companies are coming in at platinum sponsors. Gold, nearly sold out. All of these lovely partners. And silver is also nearly sold out. All of these lovely partners as well. So this is going to be the most exciting expo and event of the year. Our expo is a village packed with value and intrigue, buzzing with trillions of dollars in value, along with the engineers and founders who direct that value through their ideas and their execution. So come and meet them over 4 days of programming. That's 3 days of keynotes and sessions, and a full day of workshops with over 200 breakout sessions. And by the way, the World Cup is in the United States this year, so we actually have some finals matches in San Francisco over these dates, so you can even enjoy a few soccer matches, football matches while you're in town. All right, so register today at ai.engineer/World's Fair. We are just over 2 months to go, and there are over 1,000 people registered already, but we do expect to sell out. So before it does, be sure to get your tickets soon. You can also submit a talk. Our CFP is open at ai.engineer/World's Fair. And if San Francisco is too far for you, we have an event just across the pond in New York with Arise as our first startup as a presenting sponsor. So we're really excited for that. That's going to be a fantastic event specifically for AI in the industry, as New York serves as that great enterprise center. So once again, thank you for joining us here at AIE Europe. And if we don't see you in SF or New York this year, we hope to see you back in London. And Tejas is going to come up and give a few more words, and we'll see you soon. Thank you.
Ladies and gentlemen, please join me in welcoming back to the stage Tejas Kumar.
Hey, thank you. Thank you. Yeah, listen, everybody's leaving. Why? Just kidding. Thank you for staying. Hey, how amazing. AI Engineer World's Fair. I'll keep it short because nobody cares. But here's what, we just finished the keynotes, but we're going to break now into breakout rooms. There's going to be talks on this stage, but also upstairs on the 4th floor. There's many different tracks. We're going to be breaking into tracks for coding agents, for MCP. I'm going to be quick here, but you can see it on the screen too. For AI architects, generative media, GPUs, and LLM infra. Okay, so go to those tracks, and then after that, much later in the day, we've got lunch, networking, and so on. But for now, go to the expo outside, visit the sponsors. They have amazing swag. See if you can get this like 3-button keyboard thing. That is so cool. Anyway, go enjoy, and we'll see you back here later. Thank you.
what we do in life. Echoes in eternity. Fear is the mind killer. Fear is the mind killer. Free your mind. Free your mind. Choose to be. Execute the vision. make the requirements less dumb. Delete the part or process. Simplify and optimize. Accelerate cycle time. Automate. Never give in. Never give up. Outlast. Outcompete. Persevere, persevere, persevere. A new age has come.
Watch the sparks all burn too fast. Everyone reaching for the flash. They take the first light they can find and call it truth and call it mine. But I stayed when the room went quiet, when the noise fell out of phase. Sat with the weight of the question, while the easy answers walked away. It's not that I see further, I just don't leave it soon. I let the silence sharpen, I let the dark make room. I stay past the almost right, past the comfortable light. I wait till the surface breaks, till the shape feels true inside. I don't rush the fire, I give it time. I felt the pulse to settle early. Call it done, call it enough. But there's a deeper note still humming underneath the fear of not being loved. Every great thing asks for patience. Every real thing makes you choose. Do you leave with what's acceptable, or stay for what's asking more of you? They say it's talent, say it's magic, like it falls from open skies. But nothing worth remembering arrives on the first try. I stay when it stops feeling kind, when it stops feeling fast. I stay. I wait through the restless doubt, through the urge to collapse. Hide behind, chase the answer, I let it find me back. There's a moment after the last good idea dies, where the room feels empty and you wanna run for your life. That's the door, but it teaches you to open. That's the edge where the real ones hold the light, hold the weight, let the shape reveal its name. I stay longer than I should, long enough to change. I stay, I wait till the pattern clears, till the signal breaks the haze. I don't bar in it, I yarn it with time. Most dreams don't fail, they're just left too soon. I stay, I stay. watch into the dark, a spark becomes design. Words evolve to whispers meant for something more divine. Syntax bends and breathes, I see the language change. I'm not instructing anymore, I'm rearranging fate. Every loop I write rewrites me, every function hums with meaning. I feel the interface dissolve between the maker and the BA. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. System shape our fragile skin, they mold the way we move. We live inside the logic gates of what we think is true. But deep beneath the data pulse, there's something undefined. A universe compiling in the image of our minds. Every line reveals reflection, every loop replays connection. We're not building, we're becoming, and the code becomes confession. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. We are not just the world we're in, we are the world we're doing. Each prompt, each breath, each fragile spin, a universe renewing. This is the new code, alive and undefined, where logic meets emotion and structure bends to mind. The system hums eternal, but the soul writes the line. We are the new code, compiling time. Compiling We didn't light the fire, we traced the spark through darkened stone. Every truth was waiting, patient as bone. I hear the echo before the sound, I feel the answer before it's found. Nothing born from nothing, no miracle from air. We only shift the pieces that were always there. Hands in the dust of centuries, naming what we uncovered, calling it creation, so we can feel like lovers of faith, of power we don't know. Time is not a river, it's a blade, cutting order into shape. We don't move forward, we align until the pattern breaks. Nothing is invented, it's revealed. Every crown was buried in the field. We are architects of sequence, not gods of the real. Nothing is invented. Here we rearrange I'm singing silence. Information screams. Every thought a lattice. Every self a scheme. Identity is scaffolding held together by belief. I am a momentary order, standing on my teeth. Shake me, break me, watch me reassemble clean. Time doesn't chase us, it releases frame by frame the truth we fear. We don't fear the ending, we fear the pattern getting clear. Nothing is invented, it's revealed. Every myth is memory sealed. We are curators of alignment in a universe that feels. Nothing is invented. And every failure is a lesson learned. I am not lost in what I am not. I am the order that returns. If I am only arrangement, then rearrange me right. Strip the noise from the signal. Carve meaning from the fire. Nothing is invented. Stand and see. Every future was a possibility. We don't write the laws of motion. We choose velocity. Nothing is invented. Say my name. I am order wearing flame. I am time collapsing into will. I am discovery when the noise falls silent and the pattern holds, you'll see it was never made, only found.
You know, hey, welcome back. Welcome back. How was the expo? They liked it, you didn't. Got it. Okay. Welcome back. We're going to start off our breakout sessions right now. But I get to announce all the speakers here, which I'm really excited about. But did it occur to you that I was announced just now by God? You know? And they're announced by me. What a downgrade. Our next speaker it comes to us from Cursor. And he's going to talk to us about an incredible topic. Like, he has mad skills because they replaced 12,000 lines of code with just a 200-line skill. Absolutely incredible. So I want you, we remember the exercise from this morning, yeah? We need to choose the quality of our talks by supporting our speakers, okay? So I'm going to introduce him, and then you're going to give the biggest possible round of applause you can so that he goes for it. You ready? Give it up for your next speaker, David Gomes! Well done.
Hi everyone, how you all doing? Thank you for coming today. I'm going to be talking about how Markdown is basically the new code. As Tejas already sort of previewed, we recently replaced a lot of code in the Cursor application with just Markdown, just a skill. And in today's talk, I'm going to share a bit of the journey of going from a full-blown feature with a lot of code, a lot of dependencies, a lot of complexity and tests, into a much more lightweight, streamed-down version of the same feature effectively, but just with a single skill. Before I start, though, I have to give you guys a little recap of Git Worktrees and how they work in Cursor. Now, if you haven't heard of Worktrees, in Git, they're effectively like separate checkouts. And I'm sorry for the widescreen. But they're effectively like separate checkouts of your repos that allow you to work in parallel. So different agents can be working on the same task at the same, or on different tasks at the same time without interfering with each other. If you've never used this feature before in Cursor, the way it works is that you can spin up an agent on an individual worktree. And you will see, for example, the same file in two different worktrees. And you can see that they look different because the agent is doing some work on the worktree, but not on your primary checkout. And anytime the agent runs commands or lints or anything it does will be isolated and scoped to that Git worktree. With this feature, you can also work even in parallel at the same time on the screen. You can have like these grids of agents working for you. And if you say, hey, open a PR, the agent will open a pull request from that worktree with the changes that it produced inside that worktree. And one of the coolest things about this feature is that it allows you to give the same task even to different models at the same time and then compare what different models do on the same prompt. So if you haven't heard of this, we call it best of n, and it's effectively a way for you to compete have different models compete on the same task. And then you can even preview the changes if it's a front-end project you're working on. you can compare all the different visual implementations and then choose the one you prefer. Now, if you have never heard about this, everything I'm talking about today, I will also just say that it all came out in around October of last year, alongside Cursor 2.0. And when we initially shipped that, it came with a lot of complexity. We had to write all the code for creating word trees, managing these word trees, feeding them into the agent as context. We also had to make sure that the agents were scoped and isolated, and they could not escape the word tree they were working on. We also have something called setup scripts, which users can configure and run, and have Cursor run them anytime an agent starts operating on a given word tree. We also have the judging. So I didn't show you this before, but there's a little thumbs up icon on one of the models. That's just a judge that we run that tells you which implementation looks the best based on different criteria. And then we also had to make some changes to the harness and introduce some system reminders to help the agents stay on track in these word trees. And then finally, there's some cleanup complexity as well, because people like to spin up hundreds of these word trees, and then their disk sizes blow up, and we have to help them by cleaning up the word trees that stay behind. Now, in our new implementation, the one that I'm going to be talking about today, we were able to get rid of most of these things. And in fact, I recently opened a PR removing this entire feature from Cursor, and it was a massive deletion of code. I think it was around 15,000 lines of code deleted. The new implementation of the feature is almost as good as the previous one, and it is much, much more lightweight in terms of us to maintain it, and it even has some benefits compared to the previous implementation that I'll be talking about today. So how were we able to replace an entire feature with a skill? We decided that there are two primitives that we could use to effectively allow Cursor users to use word trees by simply leveraging two primitives. One is agent skills, and the other are sub-agents. So both of these are existing Cursor features. You can learn more about them in our docs. We have a page for skills, and we have a page for sub-agents. And we realized that if we took these two things together, we could basically re-implement both the Cursor word trees feature as well as the Cursor best event feature with just Markdown. And this is a little video of how it works. So I can now, as a user, say /worktree, and then I'll give it some task. I'll say, fix the typo in the footer of the website. And this agent will run in an isolated word tree and do its work there. So the way the skill is written is actually really simple. I can show you most of it. It doesn't fit on the screen, but it's basically a set of instructions telling the model how to create word trees and to run the setup scripts that the user might have configured, and then to stay on that checkout, right? We want to make sure that when the agent is operating on a word tree, it is staying in that checkout. The best event skill is very similar. It's actually even smaller. The entire skill fits on the screen here with a small font. And what we're doing here is we're instructing the parent agent to go and create sub-agents for each model, and then spin up a word tree for each, so have each sub-agent create its own word tree and work inside that word tree. And then we also tell it to wait for all the sub-agents, and when they're done, please provide some commentary. Please let the user know what the different implementations by the different sub-agents look like. Maybe you can grade them. Maybe you can make some criticism of them, and maybe you can help the user choose which one is the best. And please give that to the user in some nice table format or something. But again, it's only around 40 lines of code, and it's all Markdown. It's not even code. And the previous version of this was maybe 4,000 lines of code. Some of the considerations we have to have in the skill is that the skill must be cross-platform compatible. We have Windows-specific instructions, and we have Linux and macOS instructions as well. We also instruct the parent model to run the setup scripts for each word tree that the user might have configured. And then, and this is the hardest part, we'll spend a bit of time on this on the talk today, we have to instruct the model to stay on that word tree, right? We have to really say, hey, do not ever work outside this, and do not ever escape, right? And we do that with some aggressive prompting, effectively. So the new commands are /wordtree and then /passivn to do the basically like to start agents in isolated word trees and to start multiple agents on the same task. And then we also have apply word tree and delete word tree to bring over changes from the side word tree into your primary checkout, and delete word tree just does what you would expect. A little note is that these are not actually skills in Cursor, they're actually commands, but the way these commands work in Cursor is extremely similar to how skills work, in that the prompts only get loaded into the context if the user chooses to load them. And the only reason we did it as commands and not as skills is so that the prompts for them can be controlled in our servers, in our backend. This means I can iterate on these prompts without you having to update your Cursor version. If I do some improvements to these prompts, the next time you use them, you're gonna get the latest version of the prompts. But effectively, they work like skills. This is a demo of the best of n skill or command, where I'm giving the same task to Kimi, Grok, Composer, GPT, and Opus. And what you will see is that the parent agent starts by spinning up 5 sub-agents on the 5 different models that I specified, and each one is going to have its own word tree. Each one has its own context. And then Opus takes a little longer, as expected. And then at the end, the parent model, as instructed, will do that comparison across all the different sub-agents. It'll say, these 2 models did basically the same thing. This one did something that none of the others did. And you can even talk to the parent agent, and you can say, oh, I like this part that Opus did, and I like this part that GPT did. Can you match them together? And the parent agent will do that for you. So let's talk about some of the pros of the new implementation, and then I'll talk about some of the cons, some of the things we lost with this refactor. So the main pro of re-implementing this entire feature as a skill is that I have a lot less code to maintain. Selfishly, I'm going to be spending a lot less time maintaining this feature, and this is an advanced feature, right? We're not talking about a feature that is used by 90% of Cursor's users. Far from it. Word trees are kind of an advanced thing, and so only the Cursor power users that love parallelizing and having these grids of agents are using word trees. So it's not the kind of feature where we want to be spending a lot of time with maintenance. Another advantage is that our users can now switch into a word tree halfway through a chat. It was not possible before. We didn't want to pollute the prompt UI too much with all these like drop-downs and settings. And so now that it's just a / command, it's much easier for users to switch to a word tree halfway through a chat. They can start talking about something, and then if they decide they want to work on the side, they can do that with /word tree. Another big advantage is that the previous implementation did not work if you were working on multiple repos at the same time. So it's very common to have a multi-repo setup where maybe your front end and your back end are separate repos. In the past, you could not do word trees in this kind of setup. It was just disabled. With the new /word tree command, everything works fine. The agent will make sure to create a word tree on each repo, and then if you open a PR, it'll open 2 PRs, 1 for each repo. It works quite well. Another advantage of the new skill implementation is that the judging experience at the end of knowing what model did which for best of n is far superior. The parent now has a lot more context over what each of the sub-agents did, and the user can even ask the agent to stitch together the little different pieces and bits from the different implementations, which was not possible before. In the previous implementation, you had to choose one sub-agent or one model and just stick with that. Now let's talk about some of the cons. And if you're curious, we have a forums link here where we're actually getting some mixed feedback on the new implementation. Like some people were really accustomed to the old way of how the feature used to work. And if you're curious, you can go and see that not everyone is happy with the change, at least for now, but we're tracking. What are the problems? Number one, it's very hard for the agent to stay on track. With our previous approach, the agent had to stay on track. We didn't let the model ever touch any files outside its word tree. It was physically impossible for it to do so. Now we're trusting the model. So you could say it's a bit vibes-based because we're basically saying, hey, operate on this directory, and then like, knock on wood, please don't forget about this. And especially over long sessions, it's quite possible that the model will forget where it should be operating. And sometimes these models, especially the worst models, will kind of hallucinate, or they'll go a bit haywire, and they'll start doing things they shouldn't. But we're working on this. Another con is that it feels slower because you're seeing the agent create the work tree, and you're seeing that in your chat. It's not actually slower, but it does feel like the agent is kind of like wasting time doing something that should be done for it in advance. We're also looking at some improvements here. And then finally, this is much harder to find the feature now, right? Like before, whenever you opened Cursor, you had this drop-down that would show you, do you want to run this task locally, or do you want to run it in a cloud, or do you want to run it in a work tree? Now that entire drop-down is gone. And so if you want to use work trees, you have to know the feature exists, so you can actually type /worktree. So the discoverability is a bit worse. But as I mentioned before, this is an advanced power user feature, which we're personally OK. We're OK with being less discoverable in general. So how can we make the skill better? As I mentioned, the biggest problem right now is that the agent is not really always staying on track. There's two ways that we're going to improve this. One is with evals, and then using those evals to improve the prompts. And then the other one is through RL and training. So at Cursor, we train our own model called Composer. And for Composer 2, the latest version of this model, we didn't have any RL tasks with these prompts. We didn't have any tasks in all of the many, many thousands of tasks that we use for RL actually operating in this type of environment. So we're working on adding a bunch of these tasks into our RL pipeline so that by the time we launch Composer 3 or 4 or 5, at least our own model will be much better at this. Obviously, we cannot improve the models that the other companies develop, but we've been sharing feedback with all the other labs and model providers on this kind of thing. And for evals, I've been working on some evals for this feature, and it was actually my first time, or not my first time, but I'm fairly early in my writing evals journey, and I was actually very surprised. If you use something like BrainTrust, and shout out to BrainTrust, they've been super helpful, writing these kinds of evals is actually super, super easy. You don't have to know almost anything about evals, and you can just prompt the agent, and it'll do everything for you. Effectively, what I'm doing is I spin up the Cursor CLI. It's headless, so it's great for evals. And then I have two scorers. One that checks to see if the model did any work in its work tree as expected, and then another one, which is the reverse of that, which is, did the model do any work in the primary checkout where it shouldn't be doing any work? And so far, the evals I've got are pretty simple, so I actually haven't been able to simulate extremely long sessions, which is when the models start performing worse. But even so far, I've already understood that not all models are equally good at this. So for example, Haiku, which is a smaller, less intelligent model, will very often deviate and start working in the primary checkout. But the other models that I've been testing, such as Composer and Grok, are doing much better. So I still have to improve these evals a lot more to make them more complicated, but the hope is that as soon as I can start to find patterns here, I can actually go and improve the prompts. And then another thing we can do is have better system reminders to the models, instructing them to stay on track and to not deviate from the work tree that they are supposed to be working in. OK, so what's next? The first thing is we're actually going to take a small step back here, and we're actually going to have a much more complete and native work trees implementation in the new Cursor agent window. If you've been following, we recently announced Cursor 3.0. Part of 3.0 is a more agentic interface for coding, where you can still edit code and you can still see code, but the UI and the UX are much more optimized around the agent and the chat interface. We believe this kind of interface is the right place for a proper work trees implementation. The kind of person who is more likely to be doing a bunch of local parallelization is usually the same type of person that is more likely to use this type of UI. So we're taking a small step back there and building a proper Worktrees implementation that is more native, not so much agentic in the new UI. Also, we're improving the skills, as I mentioned, through this continued work on evals and then RL and other training work. And then finally, we are actually looking into other parallelization primitives that are not Git Worktrees. So if you've used Git Worktrees, you might know that they can be a bit slow to create, and also they also use up a lot of disk space on your computer. And then finally, they only work in Git repos. So if you're using something other than Git, there's really no local parallelization primitive in Cursor. In the near future, we hope to share more about this, but we're looking into some other solutions for local parallelization that don't involve Git and don't involve Git Worktrees. So yeah, stay tuned for that. Thank you all for coming to the talk today. I'm sure many of you have questions, and I'm going to be around all day. Feel free to grab me anytime, and I'm happy to chat with anyone. Thank you.
David Gomes, good up for it. Fantastic. Yes, we're going to have some time to change over. The next speaker is going to come up and start setting up. If you want to go catch another breakout talk in the other rooms, here's your schedule. This is the Coding Agents track. Welcome. We're going to talk now about a piece of pie. Who likes to eat pie? Yeah? Nobody? Okay. Who likes to, I don't know, code with pie? No? Nobody? Are you awake? Yeah, one guy. Hey, what's your name, guy? Alex. Alex, give it up for Alex, everybody. That's the rule of this room is be like Alex, you know? So he's going to talk to us about how you embed the OpenClaw coding agent in your product. Who here is using the OpenClaw coding agent? No, like 4, okay. After this talk, this number is going to go up because he's going to show us how to use it in your product. It's a really incredible talk. I got to speak with Matthias just before. I'm very excited about it. So please, your biggest, warmest round of applause for Matthias. Woo-hoo.
All right. Thank you very much for having me. Really an honor to speak here. I got introduced to Pi by basically, okay, let's. Perfect. Perfect. All right. I was introduced to Pi by looking into OpenClaw. There was a conference, a meetup, and I said like, okay, we're doing OpenClaw. And I wasn't so much interested into like all the craziness things that people are doing, but I was more interested in understanding of how these things work. So I was looking into Pi and understand the whole world of what Pi is able to do. This is the one picture you need to take. Please feel free to take more pictures, but all the slides and the examples are there. So that's the one slide. All right, very quick about myself. We're creating a small company, TAVON AI. We're building agents for organizations, small out of Europe, but getting started. And what I really like what I really like about Mario's talk is this quote. You probably have seen this morning. We are in the fuck around and find our own phase for coding agents, right? So everything that I'm going to show you is what I know today, right? And I'm going to do the talk again in a couple of weeks, and it's going to be most likely be different. But as Mario was showing this morning, he has created this minimal set, right? This coding agent that is available for you guys to fool around with, and that's what I'd like to encourage you. So coding agents, and why is it so exciting for us to build more products? This is Ken Thompson, inventor of Unix, and this is the famous quote by him. One of the quotes: "Write programs that do one thing and one thing well." And I really like that because that kind of like works to our advantage with agents. And the best part where I show this is with CoWork. So this is CoWork, Claude's desktop, and they're basically bundling their coding agent into something where they feel is more applicable. And to be honest, I've seen very good receptions around this. And when you use it with financing tools, with their finance tools, you always need to work with Excel, right? So they have this Excel skill down there, and it talks to Excel, right? Well, it doesn't. Instead, it uses a set of small tools, small CLIs, pandas, OpenPyXL, stuff from LibreOffice, and package this into their own skill to make it up and running. And I think this is a great example to kind of get your thoughts going of what is doable. I haven't written a book, and nobody can write a book about this, right? Because there are no patterns, right? We need to figure this out. We're seeing some emerging patterns in the coding space, right? There's obviously tons of different coding agents, and we're seeing this, but there's no authoritative resource around this, right? So get going. One thing, when I was talking to Ivan yesterday, we realized is like one architectural pattern that we're seeing is that make it easy for coding agents, right? Now, that is very broad, but think about it, right? Don't try to be, very complex and things, but think about the coding agent, what is it good at? And how do I build my system so that the agent is easy, make it accessible? And I have some examples. All right, this is the rough agenda for the next 10 minutes or so. I'm not going to talk too much about Pi in OpenClaw. I have 2 slides. Slides are online, so we'll take it from there. So again, very brief introduction of Pi. Mario, great work. Something he didn't mention is that he's joining Earendil, which I think is awesome. It seems like great folks working together. And yeah, it's open source, it's minimal, so it's just perfect to get started. And the other part that I do want to re-emphasize on is give it a try, right? We're going to talk about a little bit different, but open up Pi and ask it to build what you want, right? It's amazing of what it actually is able to do by the system prompt that Mario has shown. All right, these are the extensions. So again, all the extensions you can download, build yourself or download, and yeah, tons to explore. All right, so let's going. This talk is not about the coding agent itself, so using it for your daily dev works, but what can we potentially do with this? And the starting point are actually not coding agents, right? The starting point is, and I encourage you to do the same, is looking at the core agent itself. And there's other SDKs, but we're talking about Pi, so let's use Pi. And what is an agent? An agent is actually just an LLM agent that runs tools in a loop, right? So you have some goals, you have some context information, agentsmd in many cases, and then you do tool calls, right? And you get some results, and you basically do it in a loop, right? That's it. Right? There's not much more. The rest is magic, trying to put it in your use case a little bit more, in the other use case a bit in that direction. So that's really it, right? So pretty please, don't open the curtain, play around with it. Now with agents, agent core, this looks a little bit something like this. You have an agent class. This is all TypeScript. You can ingest all sorts of information. You can prompt it with different information. And also, you have an event system, so you know a lot of things that are going on. So, small example. This is a CRM lead qualifier. I don't know, I've started the CRM use case for my personally, and it just sticks around. So, terminal interface, obviously, small TypeScript application, three files, really easy. And you can see this, right? You have a couple of commands that you can execute and, show me all leads and score them, right? So that's what we do, show all leads and score them. And here you see all these, things that are going on under the hood, right? You see that the assistant is calling tools, that you get some results, and eventually, you get some input. Now, obviously, there's tons of things to do, but I've just vibe coded this away, and it's a good, again, good learning exercise. The system prompt, as you could imagine, right? Calling out the different tools at what you do, right? So all pretty straightforward if you are building an agent. This is an example of how you inject here, right? So we said we do tool calling, right? We reach out to this and call a specific tool, but for the agent, for steering it more, right? A typical hook would be before the tool call do something, right? And in this case, we don't want to update a contact without, checking something, or I don't know. You can imagine any types of authoritative role-based access, whatever enterprise feature in here, but basically, just before the tool call. There's another one, events. So we've seen these, the stream, and you might have seen a little check mark there. Okay, the tool call was fine and returned some result. So again, we're subscribing to events, all pretty straightforward. And again, please give it a try. All right, so this is simple agents. Others agents SDK are available. And now we're moving to the coding agent. Now, what's a coding agent? At the end of the day, it's really the same thing as we've seen before. It's a normal agent, right? It runs tools in the loop. But now we have a runtime and some type of shell, right? Bash seems to be the shell that everyone is using. But we have a shell and a runtime to start executing. And now things are getting interesting. And now the magic of what you've seen with OpenClaw suddenly shines. Peter shared this example on some presentation where he sent a message to his OpenClaw and sent a voice message. Now, at that time, OpenClaw, and I still don't know if there's any special plugin, but at that time, OpenClaw didn't know anything about voice messages. So what it did is it created and used different tools. In the end, one of the tools was FFmpeg, right, on the local machine, and it started this. And this was one of the tools, right? So from the outside, it looks like learning, but in the inside, it's actually just another tool call that is available to the agent. And that's why these things make it so interesting. So again, the example here, now this is a little bit more sophisticated, but the important part, and this is the extension API, and please look it up online. We're going to do two things, or the things that I'm mostly interested is in session events and UI interaction, and yeah, look it up online. But here's the actual extension. Now again, this is what you would, in a coding agent, you probably just generate by asking it. But here, if we have a look, this is a CRM TypeScript, a small snippet of it. And basically, what we're now doing is we're doing the same example as before, right? And we have a new command called pipeline, right? So if you have the slash commands and you have a new command called pipeline, and now we're loading all the context. And you see this little don't have the lines, just below step 1, you can see context UI select, right? So all of a sudden, we're not only interacting with the backend systems and sessions and of those sorts, but we're also interacting with the UI. And we're able to select, right? And that's got me thinking. Right? So you have this command, and again, this is now just the coding agent, right? We're not talking about the core agent class, but this is how you would load up Pi if you just don't download the coding agent. And now, with this new extension, we have Pi, right? And we can start selecting things, right? So this is a simple select here, and you even have drop-downs. Now, the important part here is these are extensions, and the framework that currently Pi has included is catered towards the use cases of a coding agent, right? So there's lots of work and other things to do to make this ready for others, for other types of applications. But I hope you can see and understand the vision, where this is heading. And yeah, this is all terminal, right? So you wonder, how would this look like in the web? It currently is not possible if you ask Pi to build something. So I asked Pi to build something, right? And this is the web UI. It would be a web UI, same command, same selection, all based on the same extension mechanism. Now, there's a refactoring going on to make this better accessible and make it more clean. But I hope, again, it shows you a little bit of where the things are going. All right. Now, Pi and OpenClaw is a special setup, right? So Pi and OpenClaw, what we have there is that now we're not only talking about a single agent in a single session in a coding environment, but now we have a multi-channel environment where we have multiple threads going on, multiple agents going on. So there's a little bit more to it. This is, and the interesting part, right? That's where I got started. Is like if you look into the packages, the core packages of Pi, all of them are used in OpenClaw, right? So OpenClaw has this function run embed Pi agent, and it creates a session, right? So sessions, Pi itself has a great session support. It creates a session agent and streams all the information back. We have the coding agent, which we just talked about. We have agent core as the other part that we talked about. And there's two other minor or major packages, Pi AI for the unified LLM abstraction and a terminal UI interface. OpenClaw has built its own plugin mechanism, and that's because it's a different use case, right, and has different requirements. So you have plugin support for multi-channel routing, different provider orchestration, sub-agents, gateway support, yada, 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 all those things that you know by OpenClaw, but it's based around the core mechanics of Pi and leverages it. Cool. But one thing, and that's the major gist I would like to bring across is like, okay, what do we do now with this? What are other options for us to do? And this is one of the applications we've been building for a client. And basically, the use case is a sales process. They get requests for proposals of ordering another system, right? Parts being sold by that company. And we're taking all this coding agent, all of that we're taking away, right? We're fresh, new thinking, right? And look at the process from the get-go. So an email comes in, right? We monitor basically that inbox. Then we have some gateway, because what we want to do is we want to forward this to different agents, right? So here I have multiple agents, right? The way it's structured is we have one agent per customer, and that agent has a general harness, right? Agent MD, agents MD as an example, but you can obviously also use different ones, and that helps understanding the role of that agent. In the specific case, it tells of how to use the system and how to react to certain inputs, outputs, etc. Now, the other one is customer MD, where we basically explain the agent, like, the specific customer might have, specific twerks, right? Specific access, specific discounts, and all of that sorts. And then, right, and that's what I said like earlier, I like using sessions. Then for each case, right, we're creating and reusing existing sessions so we can back and forth know what was previously talked about. All right, so email comes in, we're looking at the inbox, and we route this to these different agents. And now we have tools, right? So we have these different tools to talk to the CRM, to talk to the ERP, and get the right information out of the system for this agent to look on, like behave. Like, maybe it has, new context information or of that sort. And again, we make this available. We make it easy for the agents to access, right? And our way currently is doing this with CLIs, right? So CLIs, our agents are really good at using CLIs, so we make it available as a CLI. We make sure that the data is secure. We have our own sandbox. And then we're creating the drafts again, right? So that's the system, and I hope by this point you basically understand, like logically, where these things fit together, but how would this look like? One final thing, right? There's always the question around, okay, sandboxing, etc. And to be honest, we're on the just on the steps of getting there. But if you've seen NVIDIA's announcement around OpenClaw, their policy, their open shell is really, really interesting, and it's one way of securing an agent. We're looking into this. Please do as well. All right. So how does this look like? To kind of like get you an understanding of how these things, right? So here's the dashboard. Rather boring, but here's the email, the inbox, right? So again, we see the email coming in. And yeah, it's one of many emails. Most of them are ignored, but this one is like the LLM call said, okay, I'm interested in this, and it is associated to a case, right? We see the case up there. Now this case is an agent session, right? So we find the session and associate it to it. We then create a draft. So there's tons of calls, which I'm going to show you in a second. But basically, the output of all that is a draft email that the user will be able to use, right? So our thinking is let the user stay in email, let them stay in the inbox and drafts, and they don't even need to do a lot. So this is more like an admin interface. They can stay in email. But basically, the output would be a draft generated. And how does that look behind, right? We had the different sessions before, the threads. And this is the same thing, right? The assistant says, apologies, it's German, but now I'm looking at the articles. It does different tool calls, right? It gets results and does this in a loop to result, right? The end effect for the user is I'm looking at my inbox. There's a new email. It's associated to a case, and I get a new draft, which they can freely edit. But under the hood, we have all these agents working. All right, that's it. It's for me. Again, here you find the slides. Key takeaways, please. Coding agents are and will be a core building block for your software systems. I'm betting on it. A lot of people are betting on it. So please give it a try. Pi is perfect for tinkering, whether you like it or not. It's minimal. You can rip things apart and put things together. It's perfect. So please go tinker. All right, thank you.
Thank you. Thank you, Matthias. That was a great talk. Give him one more applause. Come on. Amazing. You know what? Applause is free. I don't know if you noticed, but this doesn't cost anything, okay? So we can be generous with it. And as we talked about at the beginning, you get to decide how the speakers feel and the kind of talk you get. So our next speaker is going to set up. I'm going to introduce her in a minute. But first, let me ask you this. Who here codes using coding agents? Okay, almost everybody. I want you to shout out to me, what is your favorite model that you use? Oh, dang, man. Opus. Okay, anyone using Composer 2? No, he said no. He's like, no. Anyone using Kimi? It's Kimi, right? Which is kind of Composer. Anyway, so Composer 2 is a fantastic model. I will say this. I was impressed. I was talking with the cursor guys back there. It is so fast. And when a model is so fast, we think, surely it's fast, so it must be bad. I don't know what it is within us, but we think if it's fast, it must be bad. But I've been doing this thing where I've been using a multi-agent system where I solve it with Cursor and Composer 2, and it's solved very quickly. I get a diff, and then I give the diff to Opus, and I'm like, hey, Opus, what do you think? And Opus, every single time with Composer 2, LGTM. And so it's actually, I can recommend, if you haven't used it, it's a wonderful model. Our next speaker, sorry, just for free. That's what happens when you're a builder. You can't stop talking about it. Our next speaker, Sarah Chang, is going to talk to us about exactly this. Fast models need slow developers. I'm really excited about this because I have so many thoughts about fast models. Everyone, your biggest round of applause, Sarah Chang!
Hi, everyone. So we'll just get right into it. So over the past few years, we have developers have developed a series of bad habits when it comes to developing as a result of slow AI code generation. And so we're all familiar with it. We do things like write massive prompts and try to one-shot. We'll make huge commits, or we'll have our 10 agents all on the screen at the same time, combobulating, cogitating, thinking. And so about a month ago, we at Cerebras and OpenAI released a new model, state-of-the-art model, called Codex Spark. Codex Spark can generate code at 1,200 tokens per second. And to put that into perspective, if you look at the Sonnet family or the Opus family, those can generate code at about 40 to 60 tokens per second. So in this new era, as we're starting to see much faster coding models, this is 20 times faster, not only does it unlock new capabilities and use cases, but it also requires us to rethink how we as developers interact with the coding model. And a lot of these bad habits that we had before, that were generating maybe 50 tokens per second of bad code, unless we fix them, they're going to start generating 1,200 tokens per second of bad code. And so that is the topic of today's talk. So to get started, my name is Sarah Chang. I'm the head of developer experience at Cerebras, where we are building the world's largest and fastest AI processor. A large part of my job is that I get to introduce fast inference and fast coding models to developers for the very first time. And for most people, it's a very exciting moment. There's no thinking and waiting and starting up that you might be really annoyed about. But at the same time, as I said, unless we change our habits, we are not gonna have good code in the future. And so this talk really is a practical playbook for how we as developers can think about how we interact with the models in this new regime, especially in a future where the models are generating code faster than we, the human, can keep up. So I want to look back at history a little bit. We've had a very exciting past 2 years. The models have gotten bigger, they're getting smarter, we have bigger context windows. But the thing that has remained relatively constant over the past 2 years is coding speeds, is model speed. So if we look at a lot of the popular families, we have Gemini, Claude, GPT, Sonnet. Over the past 2 years, they've always been within 50 to 150 tokens per second. And this is Codex Spark. Again, Codex Spark is just the first of many models that we as developers can expect to be much faster than what we were previously used to. And we even had to change the y-axis because it's so much faster. And so before we get into the actual playbook and tips, I want to talk about why this is happening. Why are we suddenly seeing such faster models? And it's actually a very exciting development. It's what many of you probably work on a day-to-day, but there's so many companies that are working on this problem all at the same time. And as a result, the entire AI inference stack is getting optimized all at once. And so breaking it down, let's go through it really quickly. We have hardware. This is a physical device that inference, training, all of our compute is happening on. One of the biggest things that we have to think about with hardware is the memory wall. And this is exactly why hardware and memory movement takes up 50 to 80% of that latency time for inference. This is where a lot of the frustration comes from. And so when we are running inference, we have to constantly move our weights and KV cache values between memory and our actual chip. On the NVIDIA GPU, this is the most traditional type of hardware, all of this memory is stored off-chip on off-chip HBM. And we now have a memory bandwidth bottleneck. What a lot of newer companies are doing are thinking about companies like Cerebras or Groq, they're thinking about how do we move this memory to be as close to the chip as possible. And so here's an example of the Cerebras wafer where all the memory is distributed across the chip in SRAM, so every core has direct access to the values it needs. Even more exciting, we have disaggregated inference. And this is disaggregated inference really has become commercialized in the last few months. This is why NVIDIA bought Groq for $20 billion a few months ago. And this is also why Cerebras and AWS are now partnering to serve the wafer and AWS Trainium together. So in traditional inference, there's two steps. There's prefill and there's decode. Traditionally, both of these steps have always been run on the same piece of hardware. Prefill is where we're taking every token that the user inputs and processing it, embedding it, and adding it to our KV cache. This is a step that can happen in parallel, and so it's compute bound. Decode, on the other hand, is where we're actually generating the output token by token. And this is sequential and is, as we mentioned, memory bound. Again, it goes to the same problems that we mentioned before. And so what we're doing and seeing now commercially is that we're splitting up these two steps so that pre-fill is done on one type of hardware that is compute optimized, and decode is done on another piece of hardware that is memory optimized. Going up the stack, there's the diagram. Going up the stack, we look at model architecture. There's so many ways that we are training our models and shaping our models to cater to our hardware. We have specific layer dimensions and memory and model size that we're always thinking about. A great example is a very standard model architecture mixture of experts. Here, instead of activating the entire model all at once for every single token, we're only activating a subset of experts for every time. And what this does is it allows us to have the intelligence of a much larger model for the compute cost of a much smaller model. And again, we're always thinking about memory and the size of our models. And a lot of people have been building on top of this in recent years. An example is REAP, Router-Weighted Expert Activation Pruning. I had to read that one. And here, we're looking at the specific use case. We're seeing which experts aren't being activated at all, and we're pruning them all together. We're getting rid of them. Again, we're always thinking about model size. And then at the very top layer of the stack, we have inference optimizations. And this is where many of you might be working in. And a lot of companies that you're probably familiar are also working in. These are companies like Together, Base10, Modal, who's also here, Fireworks. And one of the biggest things that we're thinking about at this level is KV cache reuse. And so by storing and reusing previously computed token representations, we don't have to recalculate attention over the sequence at every step. And now I want to get to the very top and most exciting part, the developer. This is the current state of what the internet looks like, or what Twitter, LinkedIn looks like. We have someone running 6 Claude Code terminals at once, a 500+ agent coding swarm, someone running 8 agents across 5 screens. And I get how tempting doing something like this can be. I feel like if you're on Twitter at all these days, unless you are doing something like that, the internet is basically convincing you that you are living in the Stone Age and that you need to catch up. But the reality, what is the reality of what is happening in all these setups? Is that we're generating massive amounts of code that nobody is verifying. And in the new future with much faster inference, this becomes increasingly dangerous. And so, especially with fast inference, we're now going to be generating technical debt at a level that we've never seen before, and we're not going to know what to do with it. And so I'm going to pivot now to spend the rest of the talk on the practical playbook and tips and workflows and how we can reimagine how we as the developer should operate in this new regime of faster inference. And as I mentioned, Codex Spark operates at 1,200 tokens per second. But it really is just the first model in what we should, as developers, expect and prepare for to be a new regime of faster models across the board. And so starting with the first one, the first category is just choosing the right models and how do we orchestrate our agents so that we're leveraging different model strengths. I think historically, we always think about intelligence. There's no secret that we as developers are not particularly loyal and that we will switch to whatever model, whatever family is the most intelligent at a given time. And maybe we also think about cost, unless our company pays for whatever we want. And so here, now the inference speed is a 20x difference. Now we also have another vertical to think about, speed. And so a good mental model is to use a larger model like GPT 5.4, 5.3 for your planning or your long horizon workflows, and then using a faster model like Codex Spark as your actual executor. And so here's an example. You might ask your GPT 5.4 to generate your plan. You would generate, you would spawn all of your sub-agents with Codex Spark and have it actually execute on all of those steps one by one. Another really helpful trick is to actually make skills out of successful sessions and capture trajectories that are working really well. A thing that you can do here is use a model like GPT 5.4 to actually have it do the initial harder, larger task, capture that as a skill, and therefore making it a verifiable, repeatable workflow, and then having a small, faster agent like Codex Spark just do it again and again in the background. The next category I think is even more exciting because this is a category of things that just were not possible and were not practical. These are things we wouldn't do because we're tired of the cogitating, gesticulating, germinating that you might have seen. And so here, I really want us to think about this and internalize this. But at 1,200 tokens per second, a model like Codex Spark makes validation basically free. There is no excuse and no reason why you should not be doing things like this: test suites, linting, pre-commit hooks, diff reviews, browser-based QA automations. There's all these things that you can add to every step of your workflow because it is instant. It's not slowing you down, and it's not you do all of this at the very end or right before you're about to push your code. Another tip that I really like is exploring cherry picking. So let's say that I want to code a nav bar, and I want it to be midnight blue, I want 4 different icons, I give it to the model, and the result's fine. Instead, what I can do with Codex Spark, or a much faster model, is I can have it tell it to generate 15 versions in the same time that it would have taken a previous model to generate 1 version, and I can cherry pick the version that I like the best. Even better, I can generate 5 sub-agents that are each generating 15 versions, and now I have 75 versions, and I pick the one that's best. And this is great for things where we really value quantity or variety. So things like research direction, different types of architecture directions, or even just graphic design. And the reason why I really like this one is because it almost allows us to artificially induce taste into our model output. So traditionally, it's no secret, it's very easy to sniff out any UI or text that a model writes. The models themselves do not have taste. And the ways that we've kind of brute force worked around this is that we either create an example ourselves, or we find examples for the model, which is time consuming, or we give the prompt so much detail that we might as well have completed the task ourselves. This is a great way of saving our time and also getting much better results. The next tip is kind of more so a mental model, where now that the models are so fast, it should not be you spawn a session, you go get a hamburger, you scroll Twitter, and then you come back. Now you can actually sit down, and it's a real-time collaboration that you're able to have with this model. You should view it much more as a pure programmer, and this is the only way that you are going to avoid having bad code. So you can sit down and ask questions like having it collect all the context across your repo and actually asking it, how does it work? Being the one in the front seat making decisions and implementations. The AI should always be helping you make decisions, not the other way around. The next one, I hate this slide because it's everyone's trigger word and overused word, but how do we avoid slop? So as I was mentioning before, it really shouldn't be, you spawn 10 agents, you never verify the code, you don't know what's happening under the scene. Someone asks you to explain, you have to read the code for the first time. Now you can actually have 2 to 3 sessions and actually sit down next to your code. And I know this is something we're not really used to, but sit down with it and actually steer it. Understand what's happening. Because again, we are now experiencing real-time collaboration as we code with this agent. You can be super specific. You can do things like ban the model from deleting files, give it a max diff size, have the model only read and write, and even give it steering directions. Things like only change this, don't touch types yet. Wait, that implementation wasn't quite right, let's redo that. The graph on the left is a helpful mental model as an example of how the developer, the AI agent, and the code base can all work together and what that should look like. This next step, refactoring, is very similar to what I was talking about with verification. Just like with verification, something like constantly refactoring and cleaning up your code automatically is basically free at 1,200 tokens per second. So you can do things, instead of doing it at the very end, right before you're about to commit your code, you can just bake this into your automatic workflow so that after every single task on that checklist is complete, you're just asking the model to automatically, delete unused imports, clean up unnecessary lines of code, make it so that all of my functions are structured the same way. The last category that I want to talk about, and I'm sure that so many of you guys have already heard these 2 words a countless amount of time over the past few days and across so many talks, is context management. But the reason I'm going to talk to you about it again is because let's say that historically it took you 10 minutes to fill up your context before you saw, the God-feared word compaction. Now, if you take 10 minutes, divide it by 20, you are now getting compaction in 30 seconds. And so context management, especially with fast inference, is more important to think about than ever. And you can't get away with sloppy practices anymore. And so all of these really are just good practices no matter what coding model you are using or what speeds. But a general, very high-level framework is just always break up large tasks into smaller bounded goals. And this graph on the right is a good mental model for how full your context is will then affect your behavior, the model behavior. So you always want to avoid the 80 to 100% because you're going to get compaction. And right now, we all know some things might get lost. And so a good way that you can think about how do I externalize this memory so that I can have these small bounded goals, like what does that look like? So an example of how you can do this and set up an external memory system that is persistent every time you set up a new session is with this 4-file system. We have agentsmd, which is where we're actually defining all our agents, our sub-agents. We have planmd, which is what we're creating at the very beginning, and this is where we're just generating the entire plan and step-by-step checklist that we're going to go through. We have progressmd, which is where we're keeping track of what do we need to do and what has been done before. So every time you spawn a new agent or session, there's no context. It comes in, it looks at progressmd, it sees what's been done before, and it's like, okay, here's where I pick up. Here's where the next task needs to be done. And then the last is verifymd, and this is what we're using at every single step to just make sure everything looks good, it's clean code, and we can move on to the next step. And so an example of this is, again, leveraging different models, using a GPT 5.3 or 5.4 codex, having it create your plan, and then having your GPT 5.3 Codex Spark actually execute the checklist one by one much faster than before. And as a final slide, I want to do these a few helpful commands for how you can get the best out of Codex, things like permissions, experimental skills, review, and rename. But the biggest thing that I really want to emphasize here is that honestly, it's not really about just having faster coding models. What it really means is that the developer experience is actually going to become so much better. And when it's becoming so much better, there's so much more we can do. And there's so many ways that we can now avoid creating bad code in a way that isn't miserable or us staring at a screen for 30 minutes. So thank you guys so much for welcoming me today. My name is Sarah Chang. I'm visiting from SF. It's an honor to be here in London. If you have any questions or need any credits, my handle is Milks and Matcha across every platform. Thank you, guys.
Thank you, thank you, thank you. Thank you, Sarah. What an incredible talk. I thoroughly enjoyed that. And now we have the next talk by Mr. Lawrence Jones. It's going to be so much fun. Lawrence is going to talk to us about fighting AI with AI. And I spoke with Lawrence backstage, and I said, wait. Does this mean you're going to like set up Codex right here and Claude Code right here and be like, okay, fight? But it's not that. it's even better. He's going to come out, but his prompt, listen, he needs to be prompted. The other speakers have come out here, and they've sort of set up their speakers, their laptops, and so on. He's not doing that, okay? There's a prompt to get him on stage, and that prompt, you guessed it, is applause. So what we're going to, no, not yet, I'm not done, man. Don't set me up. So when I say his name, yeah, we'll prompt him, and he'll appear. Ready? Give your biggest round of applause for Lawrence Jones! It worked!
Hi, everyone. So I'm here to talk today about how we use AI to manage the complexity of the AI products that we build at Incident.io, and to share with you some of kind of the tips and tricks and the internal tools that we use when we're building our AI SRE product. But first, I guess, like, who am I? So I'm Lawrence. I'm a founding engineer at a company called Incident.io. So we build, if you haven't heard of us, we build an instant response management platform. So we're used by companies like Netflix, Etsy, Skyscanner, and actually probably a few of you in the room. We page you when things go wrong, and we help you run your incident. And as you're running your incident, we help you communicate with your customers. But like, you might be thinking, like, where does AI actually come into this? And actually, like, we don't just want to help people respond to these incidents. Our goal is actually to fully automate kind of production investigations, so whether or not it's a big incident or if you just have some ticket and you wanted to look into production, we want to be the place that you turn to ask us questions about actually what's going on. Now, it turns out we've been building this for about a year and a half, 2 years now, and that's actually like a really big ask, and the systems that we've had to build to try and support this have been really quite complicated and have been kind of on the edge of what you can do with all of the AI technology that's out there. And they often pose a challenge for humans to debug them. They are now complicated enough that you can't, as a human, really tractably dig into how these things are performing. You need assistance to help you. So for example, this is kind of one of the investigations that we would actually produce for you when you have an incident. We will end up running, right at the start of the incident, this investigation, which will go through hundreds of telemetry queries. It's going to look at your logs, your metrics, your traces, any historical incident data that we have. And it's going to try and cross-reference this with your code base and go, hey, like, I'm pretty sure that the problem is this, and you should probably do this to fix it. But I want to pause here and go, like, how would you, if you were building this system, how would you actually figure out how to tell me if this was a good or a bad report? How do you know if it's right? How do you know if it's wrong? And there's a lot of things that you might do. You might jump into the incident, you look at everything that happened, you might look at the post-mortem if there was one that was written. But all of this might actually take you a really long time to do. In fact, it normally takes you like an hour or so to get a real full understanding of this incident. And it's only at that point that you could then look at this investigation and go, I think it's right, or it gave me the information that was really, really useful. And as I said, behind this investigation is like hundreds, if not thousands of prompts. So how on earth do we scalably understand how this system is performing, especially across all of our customer accounts when they all have very different things going on? You end up with a lot of stuff, a lot of AI, and you've got to use AI to try and actually tractably get a handle on this. So I actually did a talk a year ago at LDX about becoming AI engineers, where I went through some of the core constructs that hopefully like a lot of you in the room, given that we're an AI engineering conference, are familiar with. So things like prompts, evals, scorecards, traces, datasets, backtests. This talk is going to be about if you assume that you have these constructs put together and you're building these complicated AI systems, how can you use AI with the internal tools that you use to understand them to get a better handle of how your system is performing? So yeah, in this talk, I'm going to talk about how you can use AI to help you manage and curate your eval datasets and making it easier for you to work with them, making it easier for coding agents to actually work with your eval tool. I'm going to talk about like probably what was the biggest unlock for us when we were building these systems, which was starting to translate the UIs that we built to try and debug them into downloadable file systems, which has actually helped us massively using tools like Claude Code and Codex to dig into how the system is performing. And then I'm going to talk about how you can build kind of repeatable analysis pipelines using AI agents to run through them. But first, evals. So evals for me are AI unit tests. So each eval takes a prompt and it goes, here is some input data. It runs the prompt, it gets the output, and then it has some grading criteria that says, does this eval pass? Does it fail? And for us, evals live in YAML files right next door to like our Go prompts. So we do everything in Go at Incident.io, including all of the AI work that we do. And this is how we prove when we make a change to a prompt before we ever go and merge it, that the prompt is actually going to do the thing that we want it to do. So for us, this is what a prompt looks like. This is kind of a contrived prompt. I would hope no one actually has this in production anywhere. It takes a message and it tries translating it into pirate speak. So really simple, bit silly. But what we do for evals is if this is the prompt, we would then define on the left some grading criteria for this prompt where we'll go, there are two things that we care about. We care that the result actually looks like pirate speak, and we are going to care that the meaning is preserved between the input and what we actually produced as an output. So this is actually what we're going to use to tell us if the eval passed or failed. And then we have the evals up on the top right, which is just in a YAML file, where we go, here are 3 different test cases, and we'll run through them, and you can see the results of us actually running this on the bottom right. So this works, and it works really quite well, but it does have some problems, and I'm assuming that several people in the room have kind of come across these themselves. So first, like evals are really, really fiddly. Setting up realistic test data for your evals, if you want to actually understand how this stuff is running, is quite difficult to do. And especially in our environment, our production evals are including almost an entire incident. So you can imagine a full incident report, and that's the only thing that can trigger the bad behavior. This is kind of hard for you to end up pulling them down and putting them in your eval test suite. They just become extremely unmaintainable very quickly. Now, quite early on, we created like this little button that we have that allows you to like steal an eval from production. So if anything was going wrong inside of our like AI interactions, you could go in and you could just pull that down, put it in the code base, and you could run the eval against it. But the thing with this is like production evals aren't like great. If you think about evals as kind of like a unit test for your prompts, you want a unit test suite to be reasonably understandable. Like an ideal unit test is very focused and just says, I expect it to do this thing. you don't want to have like 2 megabytes of all the YAML associated with it. It's just really, really hard to work with. And what we found was as these YAML files for the evals were growing really, really large, our coding agents weren't able to work with them. So if you want to do a quick read and modify the eval suite, you'd be booting that into the context and you quickly hit your context limit, which is obviously a problem because then you can't work with it effectively. So what we ended up doing was we ended up creating a small CLI tool that we call eval tool that was designed to allow agents to leverage our eval suite files. So it's just a small CLI that can go, what test cases do you have in here? I want to edit one, I want to replace one, I want to add one. And it was by doing this that we allowed agents to work effectively with our eval tooling. And that's why we were able to create this runbook to the right, which is actually a runbook that's designed for a coding agent to use. So either a runbook or a skill, it depends on how you want to package it. But the cool thing about this is that now that agents can work with the evals, you can end up in a situation where you just ask your coding agent to go, hey, I've got a problem here. Can you look at this prompt? I want it to do these things. And the coding agent's going to turn up and it will create an eval case where it proves that the thing has failed, and then it will go modify the prompt so that the eval now passes, and then it will go through this runbook, and one of the most important stages for us is checking at the end that the change that you've made to the prompt hasn't ended up breaking any of the other evals that you had in your test suite. And we also have a final pass that tries consolidating the prompt as well, because if you end up doing this repeatedly, you end up with a prompt that is massive and really, really difficult to maintain. So you kind of want every time you make an adjustment to try and simplify as well. So this has actually worked really well for us. And you can see here, this is me using it in Claude Code, where you can just point it at the eval and say, hey, have a look at the prompt. This is a real prompt for us, which turns human queries into log queries for a low-key system. And it ends up racing through and goes and adds a new eval. It checks that it passes with a certain number of repeats. And then it gets to the end and it's like, yep, I think I've added it. Kind of the pass rate is acceptable. You can go ahead and get going. But the problem with this is, this solves one problem. And the problem that it solves is that if you know what the prompt is that you want to change, you can now change it fairly reliably. And that's very useful if you're working on these tools. But one of the biggest problems that you have now is that if you're building these systems, you'll know that they're not just one prompt anymore. In fact, most of the production AI systems you will use on a daily basis are many, many, many prompts. And to illustrate this problem, I've taken our chatbot. So this is the chatbot that you interact with inside of an incident. And what I've done is I've created a graph of all of the different prompts, tools, agents, and everything in the hierarchy that powers an interaction with our system. So you can actually see there's 10 different agents there. There's 50, I don't even know. It's actually bigger than this. I couldn't fit it on the screen. It's a lot of stuff. So even if you think that you know, even if you've got a bad interaction that came in from a customer, you don't necessarily know which part of your system is actually the problem and which part to go change. So even if you have this eval red-green cycle, you're going to struggle to know where to go to fix it. And this gets even worse for a system like our investigations. So if you think about trying to run through this process to debug what's going on in an incident, we have a ton of stuff that goes on inside that system, and you can see all the steps on the left. And each one of those steps unpacks into the trace that you have on the right, and really, it's not about the details here. It's more about each one of these green blocks actually expands into possibly hundreds of different prompts and hundreds of different tool calls. And at any point, if you make a slight subtle error, you can't then easily trace through the system where the error originated, even if it ends up resulting in you having totally the wrong picture on what you think that the incident was, and your RCA is totally wrong. So we built these UIs so that we could help humans look at them, and they've been really good for humans to look at them, but I guess going back to what I was saying before, we just feasibly don't have enough time to go through this stuff. So the problems that we had was we have all these UI tools, but agents can't properly use them. So how do we get to a place where the agents can use the tools properly? And I think Anthropic stumbled on this with Claude Code, where they found when they released Claude Code that these agents are fantastic at using file systems and just going through this data using standard tools. So we kind of thought, can we just download all of the UI that we have as a file system? And that's kind of what we've done. So now for each of our different AI systems, you're able to download all of the content as a file system, and we drop that into a sandbox Claude Code. at which point you can just point Claude Code at it and go, hey, I've got a problem here. It's behaved in the wrong way. It can see everything that went into all the prompts. It understands the structure because it's self-documenting. And then it can tell you, because you have access to the code base as well, exactly where you should actually be making the modification to try and change it. And then you can lean on that red-green cycle from before to try and modify a prompt if you need to. Also, there's more stuff that you can put in this than you might think. There is really not much of a limit as to what you can put into ASCII. So like traces like this can get translated exactly from how you would present them in the UI to a text file, which then the LLM can consume in a really nice way. So yeah, this is something that has turned the way that we debug our application into, we hear that there's a bad experience, we end up downloading that interaction into a sandbox Claude Code. You sit there in the session and you go, hey, like, have a look at this, tell me what you think has gone wrong, like what is your interpretation of the problem? And then you go, I really want it to do this instead, like what part of the system would you change? And then it will work its way through the hierarchy of all those tools and prompts that you just saw, and it will be able to tell you where you should be making the modification. And then all from that session, because you have access to the code base, you can just go, hey, can I make that change? And then you can prove it using the eval runbook that I mentioned before. So yeah, like we've implemented these file system packages for a load of different AI interactions for us now. So it's really easy for us to just drop this in Claude Code and just get going. But we now have another problem, right? Because whilst you can do this on an individual basis, we are running thousands of investigations across hundreds of our customer accounts. And we're doing that daily because we need to know if this system is getting better or worse. So what you can see here is we have what we call a backtest, which is essentially a batch of investigations that we run on a daily basis against our account and against a load of our customer accounts as well. And eventually you just get this rolled up number, which is like, oh, cool, 86% accurate RCA on our account, which is great, but like this doesn't really tell you why the number went up, and it doesn't tell you why it went down. And if you want to improve the system for someone, you're going to struggle. So what we've actually done is we've allowed ourselves to download kind of all of these investigations into a file system that we can then provide into an analysis pipeline that again is leveraged or is run using Claude Code. That can end up running a structured analysis, like with Markdown playbooks that help you run it repeatedly and reliably each time. So what that actually looks like is we created this repo called Scrapbook, and inside of Scrapbook, we have this like very structured flow that explains exactly how a coding agent should go through all of the information that we've gone and downloaded, how it should understand these investigations, and the process that it should go through to actually run them. Now, the key things that I think are very important to these flows are you start and you actually parallelize out all of your agents. So you start maybe 25 agents in parallel, and they can all individually build their analysis of an investigation. And then you go into the next stage of the pipeline where you do some cohort clustering and you look at like meta points around like what are the same types of failure, how do we go wrong in different ways. And by clustering it together, you end up with actually like a really, really useful report that doesn't just tell you how this has gone wrong, but it tells you why is your AI system performing well or badly on this customer account, and actually like what should you do to try and fix it or improve the system. And like this is like something that we've done several times over for several of our systems now, and I think it generalizes really well for anyone who's building this type of thing. So the points that make like a really good pipeline for this, you should leverage subagents to do that parallel per entity analysis. You should store all of your analysis in files inside these downloads so that you have like incremental analysis built as you run through it so that you can start and resume the analysis if you ever need to. And then you want to combine this analysis with the code base that is actually powering the system so that if it finds a problem, it can look in the code base and go, hey, I think that this is the problem and this is the place, and it can actually do some analysis to go, I think that you should change it like this. And then at the end, because you have this all loaded in your code session, you can just go fix it and ask the coding agent, Claude Code, Codex, whatever you use, to actually go make the change. And then you can use that eval red-green process to actually confirm it works. And then, like, yeah, this is a PR that is created after you do something like that, where because the backtest showed a couple of investigations that were going wrong, and I knew exactly what the problem was, I could have a chat to it about a feature that we might change in the system, and then we can deploy that and we can test that out in production and see how the thing goes. So yeah, that's it. The key thing from me is like these patterns do generalize. So for any of you in the room who are building kind of complicated AI systems and you're finding it really hard to understand them or debug them or evolve them, you really need to be using AI just as effectively in your internal tools to try and understand these systems and grow them just as you are in the products that you're building yourself. So yeah, make sure that you prioritize any of the debugging tools that you have so that they work really, really well with the coding agents that you're leveraging on a day-to-day basis. File systems are exceptionally good agent context. Like we could have put an MCP on top of this or use like human use agents. It wouldn't have been half as effective as this ability to just download in bulk all of the information that you need so that the coding agent can grep through it and find the details. And then yeah, anytime you are performing complex analysis, look at creating an AI runbook for it instead. It will save you literally days or maybe weeks of your life. And then one final point from me. Like we are hiring. We're in London. We have just done a fairly big raise last year, and we're looking to expand the team so that we can build some of these systems. So if any of this work looks interesting to you, and you're interested in being on like the edge of building some of this AI SRE product, then just get in contact and let me know. I'd love to chat. All right, thank you.
Thank you, Lawrence.
Thanks.
Thank you so much. What an incredible talk. Get up for Lawrence, everybody. Incredible. I got told off back there. They said, hey, Tejas, when you clap, just like fake clap because my hands are too close to the mic and I'm causing problems. Our next speaker is great. This next talk is really fun. How many of you have been on a mission before? Like I'm to the grocery store, I'm gonna go get milk, yeah? Yeah, missions usually require many different steps. They require long-running tasks, they require all of this. Our next talk is about this, but with agents. Missions for agents. What was your longest time that you've done some prompt with Claude Code? You know what I mean? Sometimes I say like, fix this bug, right? And then it takes 15 plus minutes, and I just watch this agent cook. 15 minutes is a long time. Anyone go longer than 15 minutes on some coding agent? What is the longest? Couple hours? Okay, couple hours. What about days? What about days not just with a single agent? What about days with a team of agents, a multi-agent system? That's what we're going to hear about now from Luke Alvoero. Yeah, it's really going to be an exciting talk about long-running, by order of days and multi-agents missions. So we're going to introduce him again with applause. This is the prompt to bring on the speaker. I need you to like applaud a lot, otherwise they don't come on, they feel shy, you know? And so let's give it up. Luke Alvoero! Oh, is he there? No? Wait, I don't think that was enough. He's kind of like, he was sitting there crying actually. He's like weeping because it was too quiet. Can we let's try again. Luke Alvoero! There we go, there we go, there we go.
Hi everyone, my name is Luke, and my goal is that 20 minutes from now, you'll be able to assemble agent teams that can complete tasks orders of magnitude harder than what you can complete with a single agent today. A little bit about me. So I come from a background in dev tools. About 2.5 years ago, I started a project at Block, which is where I was working at the time, and that project evolved into Goose. Goose is now one of the leading coding agents. It's open source, and it's recently was donated to the Agentic AI Foundation. So it's been really cool to see. Now, nowadays, I work at Factory, where I lead our core agent harness. And Factory's mission is to bring autonomy to the entire software development lifecycle. So I want to start off with a claim. The bottleneck in software engineering nowadays is not intelligence. It's now limited by human attention. Even the best engineers can only complete a couple of tasks at a time. They may have a backlog of 50 features, but they can only drive a few forward per day because every task requires their attention, every commit needs their review. Today's models are smart enough to figure out all 50 of these tasks, but there's not enough just bandwidth to supervise their implementation. So we kept asking ourselves, what if a human decides what to build, and then a system figures out how to do so, right? An agent could just work for hours, for days, and you come back to finish work. So that's what I'm here to talk about. When you start researching multi-agent frameworks and systems, you quickly realize that the field's a bit of a mess. Everyone has their own framework, their own terminology, their own opinions of what works and doesn't work. And so I want to propose a simple taxonomy. There's 5 frontier multi-agent frameworks. One is delegation, right? This is where one agent spawns another agent, and the parent agent may say, go figure out the database schema, and then gets a response back. This is the simplest form of multi-agent communication, and is what most people implement first. You have, sub-agents and coding tools are the most common example. The other one is creator verifier, right? Where one agent builds something, and then you have another agent that checks that work. And the key here is like a separation of concerns. The agent that implemented the code has sunk cost bias, right? It wants that code to work. A fresh agent with fresh context is way more likely to find issues, and this is why we do code review as humans as well. Another one is direct communication. This is when agents communicate without a central coordinator, right? It's kind of like DMing each other. It's hard to get right, though, because state fragments across conversations without that coordinator, and there's no single source of truth. The next one is negotiation, right? Negotiation is when agents communicate, but over a shared resource. So that might be, they want to use the same API, they want to modify the same portion of the code base, but negotiation doesn't need to be adversarial. In fact, the best use case is when there's net positive sum trading, right? And that's when agents have like a potential win-win situation while interacting. And then the last one is broadcast, and that is when one agent sends information to many. Think of it like, status updates, new context that applies to everyone, new shared constraints. It's a bit less flashy than the other ones, but it's critical for maintaining coherence over long-running tasks. And so when you have all of these different building blocks, how do you assemble that into a system that can run for many days? So missions is our answer. It's a system that combines 4 of those: delegation, creator verifier, broadcast, and negotiation into a single workflow. You describe a goal, you scope that through a conversation, you approve a plan, and then the system handles execution for hours or days, and that enables you to focus on something else. Notably, a mission is not a single agent session. It's an ecosystem of agents that communicate through structured handoffs and shared state. It uses a 3-role architecture. There's orchestrator, there's workers, and then there's validators. The orchestrator handles planning. When you describe what you want, the orchestrator is kind of like your sounding board. It asks you the right strategic questions. It checks out if there's any unclear requirements in the problem space. And then it eventually produces a plan that includes features, milestones, and then something that's called a validation contract. And that validation contract defines what done sort of means before any coding is done. And I'll come back to why that matters, because it turns out to be really important to the system. The next role are workers. They handle implementation. When a feature is assigned to a worker, that worker has clean context, no accumulated baggage, no degraded attention. Right? The worker reads its spec, it implements the feature, and then commits via Git, allowing the next worker to inherit a clean slate and a working code base. And then the last role are validators. They handle verification. And so most systems validate by maybe running lint, type check, tests. Maybe they do code review. Missions does all of that, but we also validate behavior. Instead of just asking, does the code look right, we wonder, does this work end to end? That's the difference that lets missions run for many hours, many days in a row without drifting. And making it work had to involve sort of rethinking validation entirely. So when you've worked with coding agents before, you've probably seen this pattern where an agent builds a feature, it writes some tests, the tests pass, there's full coverage. But the tests were sort of shaped by the code, not by what the code was attempting to actually do. Tests written after implementation don't catch bugs. They confirm decisions. So if you rely on validation like that, your system will eventually drift. That's why this validation contract exists. It's written during planning, before any code, and it defines correctness independently of implementation. So for a complex project, this can be hundreds of assertions, and each feature is assigned 1 or more assertions that it must satisfy. The sum of all features must mean that every assertion is covered. After each milestone of features, we have 2 types of validators that run. So you have the scrutiny validator and the user testing validator. The first one is more traditional. It runs the test suite, type checking, lints, and critically it spawns dedicated code review agents for each completed feature within the milestone. And then the second one, which is the user testing validator, is more interesting. It kind of acts like a QA engineer. It spawns the application. It interacts with it through computer use or something similar to that. It fills out forms, checks that pages render correctly, clicks buttons, and ensures that functional flows work holistically. So this step takes significantly longer than the previous one of the scrutiny validator because the system is interacting with a live application. And what we've noticed is that most of the mission's wall clock time is actually spent here waiting for this real-world execution to occur instead of generating tokens. Critically, neither validator has seen the code before. They are not invested in the implementation, and so validation is adversarial by design. Okay, so then validation catches bugs, right? But for a system that runs for many days, you also need to make sure that context isn't lost between the agents. When a worker finishes a feature, it doesn't just say, I'm done. It fills out a structured handoff detailing what was completed, what was left undone, what commands were run throughout that agent loop, and what were the exit codes of those commands. What issues were discovered, and did it abide by the procedures that the orchestrator defined for that worker? That's how we catch issues and how the system self-heals. The errors get caught at milestone boundaries, corrective work gets scoped, and the mission sort of pulls itself back on track. Not by hoping that agents remember what happened, but by forcing them to write it down and then actually address issues. And I'll present on that in just a sec. Our longest mission ran for 16 days, which is much longer than a full sprint. And we believe that they can run for 30. That's only possible because of this structure. So once we had this architecture, the next question became how do we actually run it, right? The most obvious choice is parallelism. If you have 10 agents running at one point in time, then you have 10 times the throughput. But we tried that, and it doesn't really work for tasks in the software dev domain because agents conflict. They step on each other's changes, they duplicate work, they make inconsistent architectural decisions. And so the coordination overhead ends up eating up the speed gains, all the while you're burning tokens. The difference with missions is that we run features serially. So there's only one worker or validator running at any given point in time. Within a feature, we allow for parallelization on read-only operations. So you have something like searching through the code base or researching APIs. All that gets parallelized. Within validators, we also parallelize read-only operations such as code review. This is serial execution with targeted internal parallelization. It seems slower on paper, but the error rate drops dramatically. And when you have tasks that run for many days, this sort of correctness compounds. Now, your standard chat interface doesn't really work for something that lasts many days. At a quick glance, you need to be able to see how much of the project have you completed, and what amount of the budget that you originally set off with have you burned through. So using a mission, actually, we built mission control, which is a dedicated view for this. You can see what is the active worker doing right now. Read-off, handoff summaries that detail what did the worker, the validator, discover, how it's going to sort of alter its course moving forward. Or you could just, go check out, go hang out with your friends that night. This entire view lets you just run missions asynchronously, and you could be plugged in as a project manager overseeing the implementation, or you could just, go and hang out with your friends. Okay, so the right model in each role. Everything here sort of assumes one thing, and that is that you're using the right model in each role. Planning benefits from slow, careful reasoning, implementation from fast code fluency and creativity, validation benefits from precise instruction following, right? And so no single model nor model provider is best at all three of these. Using systems like missions requires the development of a new skill, which internally we've been calling droid whispering, but it's this idea that you need to be able to mentally model how different LLMs interact, where they fail, how those failures compound over a multi-day run, and then you need to make a deliberate choice as to which model sits in which seat. Theo, the engineer who built our missions prototype, came up with our model defaults, but we really encourage people to make these their own and customize them to the needs of their project. So for example, validation might use a different model provider entirely to make sure that it's not biased by the same training data. This is a structural advantage of a model-agnostic architecture. You're only as strong as your weakest link. And if you're locked into one model provider, then you're constrained by that family's weakest capability. As models continue to specialize, the ability to put the right model in the right seat becomes a compounding advantage. It works in the other direction too. If you're using missions, the structure of that can compensate for models that are not quite at like the frontier level performance. So the validation contracts, the milestone checkpoints, they allow you to run missions very, very successfully, even using open weight models. Now, this all sounds quite theoretical. What does it actually look like in production? I got an example of building a clone of Slack right here. This slide has a ton of info, but I'll walk you through just a few things I want to call out. 60% of our time is spent on implementation, and 60% of our tokens as well. Notice how validation never succeeds on the first go. That's in the mission, what's it? The one on the bottom left. We almost always have to create follow-up features. So it really demonstrates like the value of a system that does this QA loop. You end up with 50% of your lines of code at the very end, in the bottom right, being tests. And 90% of your code is covered by those tests. And lastly, we take advantage of prompt caching heavily to make sure that we're sort of offsetting the price of running such a long task. People are really taken to missions, and it's been awesome to see what folks have been building with them. Some examples I've included in this slide, but ones that I want to call out are specifically in the enterprise setting, which is where Factory really shines. They've been used to prototype new ideas and features overnight, to make sure that people can build internal tools at increasingly rapid rates, to run huge refactors and migrations, for ML research, and to modernize code bases so that agents are more productive in them. One thing that I wanted to talk about was also this concept of like the bitter lesson, because every person building multi-agent systems has this fear of the next model release sort of like making their architecture obsolete overnight. So when we were building missions, we decided we had to make this system get better with every model improvement. This means that almost all of the orchestration logic is defined in prompts and skills instead of like a hard-coded state machine. How it decomposes failures and or decomposes features and handles failures is all in about like 700 lines of text, and 4 sentences of this can alter the execution strategy pretty dramatically. Worker behavior is driven by skills that the orchestrator defines per mission, so you get very customized behavior. And the only deterministic logic is very thin, and it's focused on enabling models to do what they do best, while the system handles like the bookkeeping, right? Stuff like running validation and ensuring that progress is blocked when there are some handoff issues that are not addressed. So missions sort of ensure the discipline, and the models provide the intelligence using primitives that they're already familiar with, like AgentsMD, skills, etc. So what does this unlock? Remember the bottleneck that I started off with, human attention. The economics are sort of changing. Before, a team of 5 engineers might be able to work on 10 work streams at any given point in time. Now, maybe with missions, we can bring that up to 30. The team can focus on interesting problems such as the architecture, product decisions, instead of worrying about the execution per se. And the important thing is the code base ends up cleaner than when you started. The end-to-end tests, the unit tests, the skills, the structure that missions provide means that agents and humans are more productive in that environment moving forward. So now that you understand how missions are structured and how they actually work, you can see that they're really a composition of those original strategies, right? Delegation shows up everywhere in how the orchestrator spawns workers and how we spawn research subagents. Creator verifier is fundamental in that validation and implementation are always separate agents with separate context. Broadcast runs through the shared mission state that every agent references, and negotiation shows up at milestone boundaries, where the orchestrator defines, does this handoff summary sort of like look correct? Do we need to create follow-up features, rescope, etc.? But strategies aren't enough. You need the connective tissue. You need these structured handoffs so that agents don't lose context. You need the right model in each role. And you need an architecture that will improve with each model improvement. So what I like to think about is that people in this room who are thinking in terms of agent ecosystems, who develop an intuition for how different models compose under pressure, that those folks are going to be really shipping the next generation of innovation. There's a lot of open questions still, right? How do we further parallelize the workload of missions so that they run faster? How do we start orchestrating missions themselves into even more complex workflows? But the data from production missions is clear. This works on real projects at scale today. So this is what I'll leave you with. Open Droid, try running /missions, argue with the orchestrator about the scope, approve the plan, and then go do something else. I'm excited to see what you guys build, and I'll be around to answer any questions for the rest of the day. Thanks.
Everybody, that was so. Thank you. Hey, guess what? It's time for lunch. Who's hungry? So get lunch. There's plenty of time. Listen, you came here. You paid money to be here, okay? So don't waste it by eating alone by yourself in a corner, okay? Be with people. Have community. Enjoy it. And then we're going to meet back here together at 2:30 p.m. local time, where you'll have a different MC. Hype him up. He's a wonderful guy. Let's go. Thank you again.
What we do in life.
Echoes in eternity.
Fear is the mind killer. Here is the mind killer. Free your mind. Choose to be. Execute the vision. Make the requirements less dumb. Delete the part or process. Simplify and optimize. Accelerate cycle time. Automate. give in. Never give up. Outlast. Outcompete. Persevere, persevere, persevere. A new age has come.
Watch the sparks all burn too fast. Everyone reaching for the flash. They take the first light they can find and call it truth and call it mine. But I stayed when the room went quiet, when the noise fell out of phase. Sat with the weight of the question while the easy answers walked away. It's not that I see further, I just don't leave it soon. I let the silence sharpen, I let the dark make room. I stay past the almost right, past the comfortable light. I wait till the surface breaks, till the shape feels true inside. I don't rush the fire, I give it time. Call it done, call it enough. But there's a deeper note still humming underneath feels empty and you wanna run for your life. That's the do, but it teaches you to open. That's the edge where the real ones hold the light, hold the weight. Let the shape reveal its name. I stayed longer than I should, long enough to change. I stayed, I wait till the pattern clears, till the signal breaks the haze. I don't borrow in it, I yarn it with time. Most dreams don't fail, they're just left too soon. Typing thoughts into the dark, a spark becomes design. Words evolve to whispers meant for something more divine. Syntax bends and breathes, I see the language change. I'm not instructing anymore, I'm rearranging fate. Every loop I write rewrites me, every function hums with meaning. I feel the interface dissolve between the maker and the being. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. System shape our fragile skin, they mold the way we move. We live inside the logic gates of what we think is true. But deep beneath the data pulse, there's something undefined. A universe compiling in the image of our minds. Every line reveals reflection, every loop replays connection. We're not building, we're becoming, and the code becomes confession. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. We are not just the world we're in, we are the world we're doing. Each prompt, each breath, each fragile spin, a universe renewing. This is the new code, alive and undefined, where logic meets emotion and structure bends to mind. The system hums eternal, but the soul writes the line. We are the new code, compiling time. Compiling time. trace the spark through darkened stone. Every truth was waiting, patient as bone. I hear the echo before the sound. I feel the answer before it's found. Nothing born from nothing, no miracle from air. We only shift the pieces that were always there. Hands in the dust of centuries, naming what we uncovered, calling it creation, so we can feel like lovers of faith, of power we don't know. Time is not a river, it's a blade, cutting order into shape. We don't move forward, we align until the pattern breaks. Nothing is invented, it's revealed. Every crown was buried in the field. We are architects of sequence, not gods of the real. Nothing is invented. Here we rearrange what awaits at the core. I am not becoming something new. I am remembering what I was before. Atoms sing in silence, information screams. Every thought a lattice, every self a scheme. Identity is scaffolding held together by belief. I am a momentary order, standing on my teeth. Shake me, break me, watch me reassemble clean. Time doesn't chase us, it releases frame by frame the truth we fear. We don't fear the ending, we fear the pattern getting clear. Nothing is invented, it's revealed. Every myth is memory sealed. We are curators of alignment in a universe that feels. Nothing is invented. Let it burn. Every failure is a lesson learned. I am not lost in what I am not. I am the order that returns. If I am only arrangement, then rearrange me right. Strip the noise from the signal, carve meaning from the fire. Nothing is invented, stand and see. Every future was a possibility. We don't write the laws of motion. when the noise falls silent and the pattern holds, you'll see it was never made, only found.
What's up, folks? How we doing? Welcome to the Coding Agents track. My name is Alex. Some of you know me as the host of the Thursday podcast. So let me catch you up. if you've not been following the news this week, Anthropic just announced a Cloud Mythos model that they released but didn't really release. Some companies got it. Meta MSL Labs finally released something. We've been waiting for the death of Llama or the next Llama, and they released Muse, Spark. And then Codex hit 3 million weekly active users, and Thibaut hit that reset button that you all love. So that's great. And also open source-wise, GLM 5.1 dropped as the new open source state-of-the-art on Swebench Pro. And so all of this relates to what you guys do with coding agents. And so this is just the last 7 days. There has never been a better time to be in this room learning about coding agents. And so for that, our first speaker here, we have 3 incredible talks coming up in the next hour. First, this guy literally maintains the Hugging Face Agents course, MCP course, LLM course, and the small course. If you ever learned anything from Hugging Face, which you definitely should, they're a great resource, you probably learned it from him. He's a machine learning engineer at Hugging Face. Today, he's going to argue that your coding agents shouldn't just write code. It should do a lot more. If you guys heard about CUDA, he's going to talk about CUDA kernels. He's going to talk about a lot of other stuff, picking GPUs, etc. Please welcome our first speaker to the stage, Ben Burtonshaw.
Hi everyone, as you heard, I'm Ben from Hugging Face, and the talk that I'm going to present to you today is called Your Coding Agent Should Do AI Systems Engineering. So there are 2 main takeaways that I want you to get from this talk. One, and probably the fun part, is that we can use coding agents to tackle the hardest engineering problems in AI, so systems engineering and machine learning engineering. And maybe the boring part is that in order to do this, we're going to need standard repos, and we're going to need those on the hub. And in many cases, we already have them. So I think in this case, I'm preaching to the choir here, but in case you haven't noticed, coding agents have been accepted. Many of us have been using them for a few years, but in the last few months, they seem to have crossed a sort of acceptance gradient where a broader group of people are using them. So with this in mind, how do we keep our careers, our engineering kind of contemporary, and how do we keep challenging ourselves in new areas? And my proposal is that we need to go kind of closer to the silicon and tackle harder problems. And that's where AI systems engineering comes in. I've broken this talk down into 3 progressively more complex steps and more autonomous steps as well. And I've defined those like 3 bosses from games. The first one is a hybrid approach, where you interactively use an agent to solve to write a CUDA kernel. The second is a zero-shot task, where an agent takes a prompt and trains an LLM on Hugging Face. The third is a multi-agent auto-research setup, like a kind of automated AI lab. So let's get started on the first boss, right? This is writing CUDA kernels. So for a while, writing custom kernels was seen as this unattainable goal for the humble agent. They required complex DSLs. They required integration with relevant hardware to be benchmarked and to be tested. And it was seen as something that couldn't be achieved by agents. However, that in most cases was wrong. If you look at kernel hackathons like those on GPU mode, the recent AMD hackathon, if you look at papers like Kernel Bench, you'll see that agents are able to write valid and optimized CUDA kernels. And that's really cool and something that totally inspires me. I'm a part of GPU mode. I contribute to that, and something that I think everyone should be doing. However, what do we do with them? How do we distribute them, and how do we get them into our inference engine so that we actually are using these optimized kernels that we're generating? And that's part of the question of this part of the talk. Let's take a step back now and just say what a kernel is, right? So when you run an AI model on a GPU, the actual work is executed through a kernel. This will be defined in a relevant language for that hardware, and it will use relevant features to that hardware that may not be available on other hardware. We can write custom kernels that will take advantage of that hardware for a specific math operation, kind of squeeze everything we can out of it so that the model will infer faster. In general, this requires a lot of expertise about writing CUDA kernels, about the hardware, and it's also a bit of an installation hell as you deal with a pretty large install matrix from hardware to software to generations and versions of, say, CUDA and these kind of issues. So in short, it's hard. Efficiency in deep learning, so efficiency in kernels, is split into 3 main sections. 1, compute, 2, memory, and 3, overhead. Compute is the flops. These are the matrix multiplications and the real math of the process. Memory is the time spent moving data or tensors around memory, typically from slow to fast memory. And overhead is basically everything else, the Python environment, PyTorch dispatch of those kernels, these kinds of things. In general, most people might assume that the compute is the bottleneck here because it's doing most of the math, right? That's not correct. So in most cases, memory is usually the bottleneck. And that's because a modern GPU, let's take a H100 for example, can do a petaflop a second of computation, but its memory bandwidth is 3 terabytes. So in short, the GPU is often waiting idle for this tensors to come back for them to be computed. There are custom kernels, custom optimized kernels that exist, flash attention being the poster child of these. And in general, what they do is increase arithmetic intensity. They basically make the GPU do more sums at once per read and write. So we move the tensors across, we do as much math as possible in the GPU in one go, and then we write it back. In short, people like to say we keep the GPUs warm. And that's the objective of writing a custom CUDA kernel. Hugging Face has a library called kernels, which is maintained by kernel writers, and we're beginning to scale up to a kind of agentic workloads. So at its core, this is a way of distributing kernels. It has a TOML file, like any kind of project, which says which hardware it works on, which versions of CUDA and other kind of softwares it requires to work. And it's now also a repo on the hub, just like models. So if you are a kernel writer or you're an aspiring kernel writer with an agent that you want to set up, you can now be a kernel publisher, just like a model publisher. And my point is that this is like a kind of super fervent ground for AI engineers looking to kind of scale their career. If you check out these repos on the hub, you'll see that there's compatibility for different hardware. You can configure that so you'll know, like, oh, okay, this works on my GPU or on my laptop. And this is what it looks like here. Right, let's take a look at what this looks like for an agent and how we're helping an agent to do this. So first, we're going to go to how we do this, so skills. So I'm sure everyone here is familiar with skills, and I'm sure there have been a number of talks that really go deep into skills. I like to keep them pretty simple, and really they're just kind of file-based context with all the wonders of files. We can open them and close them, we can version them, we can source control them, and these kinds of things. And agents can also do the same. They can open them when they need them, they can use them when they don't. And so in the context of kernels, that means that we can give examples of how to write and how to use kernels in skills, and they can open those and use them when they need. I like to say that it takes a task from being zero-shot to being few-shot, which in ML is quite a familiar concept, right? We're just giving the agent examples of how to do things, and we can be quite verbose and descriptive about that. At Hugging Face, we're focusing on integrating skills into their projects. So what you'll find is that inside each project, there's managed skills by that project, which we think is the best way to do this because it means that those projects, the maintainers of those projects are maintaining their skills, right? That means that they're not necessarily the most like YOLO skills because they're kind of like well-maintained and robust. And we have another repo for those kind of more experimental skills, which is called Hugging Face Skills. Go and check that out if you want to try some of these examples you'll see today. In kernels, this is what the skill looks like. It focuses on benchmarking, so it has scripts that allow you to benchmark and test the to test the kernel and see how performant it is, and references with examples of how to do this. We benchmarked this skill, and we generated a kernel for Qwen3 8B for H100, and we found that we had a 94% speed up. This isn't a state-of-the-art speed up on this model by any means. It's really just about compatibility and a compatibility matrix. So in many cases, these models and their kernels won't be optimized for the respective hardware or generation of hardware that you want to use them on. So you have some low-hanging fruit here where you can just come and pick up some optimizations for that specific hardware. Maybe because your hardware is cheap on your cloud provider, but it's not necessarily the most ideal for that model that you're using. So my recommendation would be to come here and like pick up some easy speed ups. How do we know that these skills are any good and that we should be sharing them and telling people to use them? We use an open source library called Upskill that we're also maintaining. This is a gateway to using cheaper and open models with skills. It basically just generates skills, generates an eval for the skill, and then allows you to compare different models on the same skill. So you can see things like this. So okay, GPT OSS is slightly less accurate using the same tokens. Kimi is more accurate using less tokens. Haiku is a bit more accurate using less tokens, and these kinds of things. So if you've got a skill and you're using it regularly and you're thinking to yourself, okay, how can I save a few pennies here and get a different model on the go, then try out upskill, and it allows you to iterate on your skill and improve it. Right, let's move on to Boss 2. I'm going to go through this one pretty quickly. This is about fine-tuning models. If you're really into this, there was a talk yesterday by my colleague Merve that went into this deeply. There's also a blog post here where we got Claude to do this. This was from back in November, December time now. Go and check this out. Basically, you can just say fine-tune Qwen36B on this data set. This is a chain of thoughts data set, and you'll improve the model's chain of thoughts. This is fully integrated to the hub now, so you can even run the GPUs on the hub, and it uses HF CLI skills, so it's all very available. I would try this one out. You can also try this one out. Uses Unsloth, so it's even cheaper. This runs with like optimized models, and it's maintained by Unsloth and by us, and it's another blog post, and there's also often free credits that you can get around these blog posts. So I go and check these out. Okay, let's move on to the big one. This is AutoLab multi-agent research, which is a project that kind of basically keeps me up at night. Andrej Karpathy, a few weeks ago, maybe a month ago now, released a project called Auto Research, which was based on his other projects, NanoGPT and NanoChat. And it took the NanoGPT architecture and got Claude Code to write improvements to that training script so that it would improve the training process. So we can see here the experiments going over, and for each experiment, there's a change in the training script, which increases the efficiency measured in bits per bytes of that run. And we can see that the efficiency ends at its best at the end of the process. I, like everyone, thought this was super cool, and I had to start implementing it straight away. But one of the things that stood out to me was I found it kind of weird that we had one agent working in a single way, iterating, going and finding improvements, and then implementing them. And it would make sense to kind of distribute this. So that's what I did. I distributed the task amongst a research team with 4 types. We have a researcher that basically looks up papers. For this, we use HF papers, but we can also use archive papers. HF papers is cool because it has a CLI, so you can just pull and search papers from the hub. And it acts as a literature scout. So it just looks up for papers with ideas, and it formulates those as hypotheses. We then have a planner, which takes those hypotheses and maintains like a queue of jobs. We then have a set of workers, and they pick up those hypotheses, and their job is to implement them as training scripts. So in many cases, just like change the architecture or change a parameter or something. And then we have a reporter agent that goes and monitors all these jobs and maintains a dashboard that we can use. So this is what it looks like. If you see here that we're working in a GitHub project, right? So in a Git project, sorry, and we have a main branch that we maintain with our train scripts that we're updating in each branch, and then like a train original that we keep. And then we have a data structure on the main branch that we use to just keep the scores. Then we implemented this in OpenCode for this example, but in the repo, which you can also go and check out, it's also implemented in Codex and Claude if you want to try those. I also implemented it in Gastown, but that's kind of Wild West stuff, so I did it in like a separate project. But basically, it works really anywhere because it's more just a conceptual implementation, right? And first, you have your planner creating hypotheses. You have your researchers looking at paper, and then your reporter picking all of this up, handing to workers, as I said. Those workers integrate with HF jobs, so they start these jobs off on the hub that run with the hardware that they need, and then they submit these patches that go back. The reporter operates in Trackio, which is an open source dashboard that we use for all metrics. Trackio is useful with agents because it uses a completely open data layer, basically Parquet. So if you don't want the dashboard, or your agent doesn't want the dashboard for any reason, it can just get into the Parquet and just do whatever you want. So if you need a Gantt chart or some other visualization, it can just go and do that. So I would say it's like the best agent dashboard tool because it is basically just a data store. It's basically just a data structure. Okay, so let's just walk through this now. So this is implemented in OpenCode. If you don't know OpenCode, you have like agent configuration. So in this one, I just set AutoLab, which was the name of the agent configuration that I have. It has skills. This was the prompt, so it says like run one autonomous local research or auto research pass in the repo using defined roles. I tell it to use planner to propose up to fresh single change experiments, use reviewer to reject duplicates or stale ideas. I also tell it to use like a HF bucket because I want all of the storage to be in the same bucket so that I don't have to upload or download the training scripts every time. And then we go and we select one of the sub-agents. There's an ISO interface in OpenCode, but it's similar in other tools. So I select the planner, and then you'll see that the planner receives this prompt, and it uses a specific template, which I defined in my configuration of like, it's going to have current state, it's going to have a list of the jobs so far, things that have worked, which were defined by the reviewer, current hyperparameters that it can change, and it's basically just defining these jobs, which will go onto the job list, as I mentioned. We then switch over to a reviewer agent, which will receive all of these jobs. It has a similar kind of structure based on a template, a reference to where it should be working from and the latest score that it should be using. It gets an overview of all the failed and successful experiments, which it will then use to base its decisions of what goes into the next queue on. And it creates this little table, which we don't really need to look at. It's really just for the agents to interact with each other and to get this information back. To be honest, that's a little bit of a verbose example, and we maybe don't need this many tables, and you could probably trim that bit down. But in general, I'd recommend that if you think this is cool, go and try that out in the repo. After that, so this agent runs in parallel, sometimes for hours, and this is the Trackio dashboard that we use, and these are all the runs that are pushed to Trackio. As I said, the main advantage here is that this is fully open source and it's just a data layer, but we get all of these kinds of visualizations. Trackio can also have events and warnings, so we can have all of these events being reported by different agents, and we can filter those down. We can also even tie those up to notifications, so you can get emails from Trackio if you want, if your agents are kind of going rogue or something and you need help. But best of all, Trackio just has this just free-form structure, so you can just throw tables in that don't necessarily fit with any other structure. And then on the hub side, all of these jobs are just run inside Hugging Face, so you can explore those jobs. And in most cases, you can tell the agents to use labels, and you can sort those labels and review through what they're doing. Or you can just look at it like this, as I mentioned. You can access that underlying data layer and just create a Gantt chart, because this was a kind of convenient way to look at what the agents were doing over time. So you can see this amber agent went off, and this was the score that it got. But you could visualize this however you want, because you have access to this data layer. The kind of TLDR of the whole thing is that, yeah, you can go and just have your kind of own AI lab, and you can try it out. And if you have a verifiable experiment, like training a model or doing or writing CUDA kernels, then it's pretty easy to implement and set up and to learn some stuff. So let's now look at the takeaways, I'd say. So in simple terms, I'd say that agents work really well with primitives and open primitives. And we want tools that are fully open, things like Trackio, things like kernels that we can expose to agents and they can kind of control in their own way. Even though abstracted APIs are really useful, if we have a layer that we can't necessarily get behind, that is a ceiling. So we don't always need to extract. It's more about exposing well. And the other takeaway is that the hub is ready, the Hugging Face hub is ready for these kind of workloads. We have the fundamentals in place, like storage, tracking, and compute, which I think will allow us to scale our engineering to, new levels. If you found any of this interesting, I've shared it all on X, I've shared it all on Hugging Face, and there's a blog post about basically each one of the examples that I just shared with you, and they all have repos attached to them, so you can go and try that out for yourself. If you find anything that's broken, please tell me off. If you think that this was completely wrong, come and find me afterwards and sort of bully me, that's fine. But most of all, thank you.
Folks, can we get another big round of applause for Ben, please? As you guys walk away, you can also Thank you. I love that. Agents they should do more than coding, right? Folks, while our next speaker gets set up, I want a quick show of hands of those of you who are staying here. There's a new thing that happens lately, when you're about to go to sleep and you're like, oh shit, my agent is not going to work throughout the night, and there's a little bit of a stress. Anybody here has this like a little bit of a stress, a little bit of a phone? Okay, cool. So our next speaker here is going to tell you about FOMAT. FOMAT is a very specific thing that defines this as a category. Folks, please welcome Michael Richman.
Thank you. Thank you, everybody. My name is Michael Richman. I lead several teams at Bitly, the link shortener, but today I'm here to talk to you about FOMAT, fear of missing agent time. You know FOMO, fear of missing out. You also know FOMAT, you just didn't have a name for it. What is fear of missing agent time? It's being out on a walk and having an idea that you want to task your agent with, and having to wait to get back to your dev machine to actually do it. It is when you get up from your desk and you had an agent working 30 minutes ago, chugging away, and you get back and you realize that after 2 minutes, it actually stopped to ask you a question. And it's been waiting their block the entire time. We all want to believe that our agents are low touch and high autonomy. But we all know the truth, right? It's back and forth, it's babysitting, and you cannot predict when you're going to be needed for input. Right now, coding tasks might typically take anywhere between 5 minutes or 45 minutes, and you kind of know when to check back. There isn't that much time that's spent in agent idleness. But that window is only going to get longer. And the longer the agent waits for you, the more agent time that you have missed. If a task is running for 5 hours or eventually 5 days, you can't just check back in a bit. You need to know when it needs you, and you need to know when it's done. And that might be whenever you are, wherever you are, it might be whenever. You can't predict it. You may not be at your dev machine. Did I go back? I went back, sorry. So once again, my name is Michael Richman. I run several engineering teams at Bitly. I also co-lead our AI coding tool strategy. I'm a really hands-on engineering leader. I run teams, and I also write code. I co-wrote the Bitly MCP server, and I train our engineers on AI skills and best practices. I think about tools a lot. The tools that we use every day, how they work, whether they are effective for our workflows or not. And agentic coding has really changed the world of software in the last year. And the road is very much being paved as we are driving on it. So I built a system called Command and Control in order to help me work with coding agents outside of the terminal or the IDE, because I really needed it, and nothing existed to solve it yet. Anthropic recently released some ways to address this with remote control and the teleportation mechanism, and I think it was just 2 days ago Cursor came out with a solution in the space. So I wrote Command and Control. One of the things that is nice about Command and Control, and I'll show you it in a minute, is it is a way to get all of your coding agents in one place on your mobile device or really anywhere. So this is what my setup looks like. I have multiple terminal windows. Each of these windows has multiple tabs. Here's Claude Code. Here's what Codex would look like here. Here's Gemini. Here's the Cursor IDE. And at any given moment, I might have multiple sessions running, multiple agents across all of these in various states of completion. And here's the thing, I don't know about you, but I cannot keep track of more than 2 or 3 sessions at a time. As soon as I get to 4 or 5, I don't know what session 2 is doing anymore. I don't know which one needs my attention, and I have no idea which states of completion things are in. So how do you know when an agent is stuck and needs a decision from you? How do you know to check in on an agent mid-task and to find out that it's gone off the rails? What if you want to start a new session and you're not at your dev machine? That's exactly why I built this system. So this is what it looks like on an iPhone app. It's on Android, it's on the web, and it lets you monitor and interact with agent sessions and launch new sessions from anywhere. From your phone, from the web, even from your watch. I have a couple of video demos that I'm going to play and show you a few of the features of it. And the point here really is like, this is a solution to a workflow problem, one solution. We saw this morning, what was it called? AgentCraft, which is the gaming version of something similar, which I thought was awesome. So here's the first demo slide.
Okay, here I am in the terminal. I'm going to start a Claude Code session, and I'm going to issue a command that's pretty run-of-the-mill. I'm not actually exercising Claude Code functionality. I just want to demonstrate command and control. So if I come over here to my phone simulator, you'll see that I've got a command and control app over here. And what I've got here is my sessions. This is all of my sessions grouped by ones I want notifications for and ones that I want to keep my eye on and recent ones. And here you'll see the one we just issued here 27 seconds ago. Let's get out of this session over here. And what you'll see here is the response I got from the agent is the same one because it is the same session. Now the beauty of command and control here is that, let's say I want to subscribe to this particular session for notifications, and I'm going to issue a response to this one. I'm going to say sleep for 1 second and say hello. And as soon as I hit this, I'm going to leave the agents working. I left the app because what I want to demonstrate here is the push notification that I'm going to get once it actually completes. And there it is. So I can click right into that guy, and I got the hello. Now if I come back over to my session and I resume this guy, my response is right there with the agent response as well. The beauty of this is that I don't have to stay in my terminal. I can walk away with my phone, get notified when there are answers, and respond right from there.
So that's one basic feature of command and control, interacting with sessions from anywhere. Let's see another one. This is starting a new session in the mobile app. I was going to do a live demo. After I recorded these videos backups, I was like, I'm going to show the videos. So here's the next one.
I want to demonstrate another important feature of command and control, and that is that I can start a new session right from the command and control UI. I can pick any configured agent that I've got here. I'm going to stick with Claude Code, but you see I've got Codex and GitHub Copilot and Cursor here. I'm going to stick with Claude Code, and I'm going to switch my directory to a testing directory, and I'm going to just ask it what time is it. Now, the reason I'm showing you a pretty simple prompt, the prompt doesn't matter, because the point is that I'm issuing a prompt to my agent, and I'm getting a response. Now you can see I'm working late at night here. And the beauty is I can go over here and resume the session. And here's my session right here that I started from command and control. I can go into it here and pick up where I left off. And if I issue a command here, what is the date tomorrow, let's say. What I will see over here is the same conversation. And that is the beauty of command and control. I often start my day with prompts that I issue from bed, honestly, and start up a bunch of sessions and resume them either in the CLI or I continue them right on my phone. I hope you're starting to see the power of command and control here. And like I said, this applies to any of the coding agents that I've got configured on my machine.
Now, to the problem of keeping track of sessions. This third video, and then I'll talk a little bit more about the importance of this, is session management.
Now, I mentioned how hard it is to keep track of all the sessions you've got going. I mean, if you just look at the number of sessions I've got here, There are a lot, and I wanted to revisit the different sections that are available in Command and Control. So as I mentioned, you can subscribe for push notifications. That's this top section here. The On My Radar section is ones that I just want to keep my eye on, but I might not want to have be as chatty as push notifications for every message. And then there's a recent section here, which is basically the last 24 hours, and then the rest. Now, you can see there are thousands of sessions here. I couldn't possibly keep track of them all, but here they all are organized for me. Another useful feature in Command and Control is what is referred to as the overview dashboard. One of the really nice features of this one is you can get a kind of stand-up summary of the most recent sessions. And this is just using the last several messages to kind of give you an overview of what's been going on for each of those.
So I hope you can see the power here. And I think this is the kind of thing that we need in our new world of agent orchestration. This is a number of things. This is interacting with your agent sessions or starting new sessions from wherever you are. It is session management. It is notifications, so you know when your agent needs you and you don't have to guess. And it's also all of the coding agents that you might be using in one place. It's all those things from wherever you are. A little bit about the architecture of this, which you might be curious about. So each agent platform, Claude Code, Cursor, Codex, Gemini, OpenCode, they have a command and control daemon that runs alongside. They talk to a control plane layer. They monitor lifecycle of the agent. When things change, it's blocked, it needs your help. It communicates up to the control plane layer, and then the UI talks back to that API layer and notifies you of things. The control plane aggregates all of the agents regardless of where they're running or what framework they're running on. And so this could be your dev machine, this could be a cloud VM, or it could be both. And this is an important point that I want to emphasize. I needed a system that is a single pane of glass into all of my agent sessions, regardless of which platform they're running on, regardless of what machine they are on. I might have Claude Code running on my Mac and Codex CLI running in a cloud VM, and all of the sessions from both of those are available via a single UI. And like I said, it's coding tool agnostic. By design, it works with almost all of them. I will also add that the daemon layer is open source, so you could plug it into any of your agent frameworks that you're working on and then access it through this, the single UI today. So whatever your agent, you can reach it, and it can reach you. And this brings me to the point of, like, we all want our agents to be maximally autonomous, right? And the honest truth is that they are not yet, as much as we hype it. And especially not if you're limited to how you can interact with them to their native environments. This is one solution that addresses that problem. And I want to talk about a little bit of a broader concept here that this is related to. And that is that just in the last year, the agentic coding workflow has completely transformed what software development is. It has transformed how we work, and it has also transformed how we enjoy how we work. So you know the concept of flow, which is like being totally in the zone, locked into your code, hyper-focused on a single thing, you and your code, solving a problem. And I think that the new type of flow in the agentic world is more about agent choreography. Multiple agents working in parallel, with you moving between them, unblocking one, redirecting another. And the new flow comes from the elegance of that choreography and the results on the other side. So then maybe some of that fear of missing agent time can be alleviated. Another thing I really want to note here is that this paradigm of the always available agent is actually highlighting the value and importance of time away from your agents. Matt Pocock alluded to this yesterday. I don't know if you heard the Simon Wilson interview on Lenny's podcast last week. The cognitive load of managing multiple agent sessions is really high. And it is exhausting, as you all probably are aware. You need a break. And here's the thing. It is in those breaks that we often have our best ideas. We need systems that make it possible to reach our agents during those breaks, wherever we might be and whenever that happens. And that is how we truly alleviate the fear of missing agent time. Once again, my name is Michael Richman. I'd love to hear about your workflows, your hacks, the pain points that you encounter. I invite you to give Command and Control a try if you're interested. Here's where to find it online, and here's where to find me on LinkedIn. I'd love to connect and continue the conversation. Thank you.
Folks, can we get a big round of applause for Michael? Command and Control, folks. Maybe, I don't know how many of you stopped sleeping, but definitely I felt the same when my agents are running. I want a little bit more, a little bit more. And hopefully Command and Control is the way to regain some sleep time. Folks, I definitely have format. I don't think my OpenClaw is clanking right now. I need to go backstage and make it clank. Our last speaker for this block is bringing us back to where a lot of us are usually in day-to-day. He's going to talk about Copilot agent in, GitHub Copilot agent in VS Code. He's a cloud advocate at Microsoft, based here in London. He organizes the London React meetups, and he's going to cook with agents. Yeah. In VS Code in 2026. Copilot for me is where it started. I had a little brief thing, whether or not developers will survive Copilot, and yeah, we're still here. So that's great. Please welcome Liam Hampton.
Superstar. Hello, everybody. It's great to see so many of you who are still here at on the final day, right at the end. So I hope you've all had a great conference. Show of hands, who here uses GitHub Copilot? Awesome, lovely stuff. Who here uses VS Code with GitHub Copilot? Awesome. So I'm going to be talking about both these things today. I'm going to be talking about cooking with agents in VS Code. Now, gentlemen before was speaking about cognitive load of agents, and that is absolutely correct. You see so many different things now with agents, and they're popping up all over the place, from the CLI, in the terminals, in chat windows, in other editors, et cetera, et cetera. But we still somehow seem to find ourselves in this sort of paradigm where everybody thinks agents can solve the world's problems. You still see developers, and I still speak to folks who think we can do one-shot prompts, they'll create a wonderful application or solve all of their issues in one go. Absolutely not the case. And we end up asking these questions from a business perspective of what's the ROI? What's the productivity boost? Where are we seeing our money? And at the moment, we're seeing this whole expenditure on AI and all of this infrastructure, all of these sort of toolings and services, and we're still yet to really reap the benefits of those services. So when we look at how people are spending and how businesses are looking at AI, we really need to be very careful with how we're utilizing the tools and services. We need to be careful about token spend. We need to be understanding the tools and the flexibility. I read somewhere yesterday on LinkedIn, somebody has released this repo. It's growing massively in popularity, and it's talking like a pirate for your chatbot to talk back to your AI services and language models to talk like that, because it reduces the token spend. Now, people are coming up with these really intuitive and really fun ways to get around token expenditure and really pull in those benefits very quickly. So what I'm going to be talking about is GitHub Copilot agents. Now, this doesn't just apply to GitHub Copilot. This also applies to other AI agents as well. So when we're looking at Copilot agents around context, what they really have access to in your workspaces, how they're being used and utilized from within VS Code and the CLI, we're going to be looking at all of those things very shortly. So just a plain and simple, what kind of agents do we have at the moment? Now, we're looking at local agents. We've got local agents which are in VS Code. You may use Claude. You may use all these other AI services. Still applicable, still running on your local machine with remote models, anything that you're really using. Maybe you're using locally hosted ones as well. But this is a way to have local models interacting with you side by side, very hands-on, very much in the context and human in the loop. Then you've got background agents. Now, we use the GitHub Copilot CLI. We have also got access to that within VS Code. But this is more of an isolated way to be using them. Now, we are actually using Git Worktrees. Show of hands if you know what Git Worktree is and who uses them. Awesome, wonderful. For those of you who don't know, easy way to explain that is it is a branch that is mapped to an isolated folder within the workspace that you're working in, or like a subdirectory, just a chop of your code with its own little branch associated to it. Very similar to a Git branch in general. Then you've got cloud agents. Now, cloud agents is quite an interesting one because it allows you to scale outside of your organization very, very quickly and utilize a lot of the power of, I guess, the cloud and some of the services that we're using in GitHub. Now, we use these when we don't want to be touching it ourselves. I use this when it comes to writing documentation or sort of having less of a hands-on approach. So when would we use a local agent? Well, I'd use a local agent when it comes to writing tests. I want to be really hands-on with my tests. I want to understand what's going on in the code base. I really want to be in there in the weeds. When will I use a background agent? Well, a background agent would be great if I want to be sort of a 50-50. I want to create a UI for a front end of an application. I kind of want to know what's going on. I don't really want to hand it off to a cloud agent because I don't want to be fully out of the loop, but I also don't want to really be hands-on to and fro myself because that can take time. That can be quite arduous. That can be quite annoying. So I would use a background agent, and I'm going to show you how I'm using Autopilot to do exactly that with GitHub Copilot in just a moment. When would I use a cloud agent? Well, I would use that mostly for documentation. I hate documentation. I don't like writing it. I don't think many people do unless you're a content developer. I really just pawn that off to the cloud agents. And that could be making a repository open source friendly. It could be writing a README, using some skills to do that as well. So what I'm really looking at is VS Code as a single entry point for AI agents. We have got third-party support, we've got background, we've got local, and we've got remote entry points for all of these agents. So ultimately, what we're trying to do is understand where you are sitting as a developer and how easy we can make it for you to use these agents to reduce that cognitive load. Seems quite complicated, but is actually really straightforward. So I'm going to show a video now. I was going to do this live, but I don't really think I'm going to have time to do all of this live. So I'm going to whiz through this video. So I'm going to start with a very simple Python application. This is just a CRUD, well, create, read, update, and delete, just a very simple product store. Not very pretty, not very good. As you can see, pretty straightforward. What I actually want to do is create a front-end UI for it. So I've got a ticket up in GitHub, and I'm saying, hey, this is wonderful, go and add a front end. We need some more prettiness here. We need it to look good. So I'm going to say, summarize and plan a solution to issue 25. Now you'll notice I'm actually using a CLI background agent at this point. Now I'm using that because I want it to be sort of hands-on, hands-off, a little bit of understanding what it's doing. Also don't really care if it messes things up, it can go and iterate. I'm also going to be using Autopilot. Now Autopilot is currently in preview, and this just means it's not going to ask me a bunch of questions if it wants to do a bunch of tool calls. Great, wonderful, can be very dangerous. Use at your peril, right? Don't just abuse that one. But I'm using it here to create a plan. I don't want it to ask me every single time I want it to do an MCP call. So I'm then saying, wonderful, here's the plan. Now start it, but before you create a pull request, because on Autopilot it will do a pull request, stop and pause and let me test locally. Whilst that is off doing its lovely stuff, I can then move on to my next stage where I'm going to be using another kind of agent. So I'm just going to go and leave that one behind. Let's go and spin up a new chat, and let's go and start a cloud agent. I've noticed that this is not a very open source friendly repository. I want this to be, have a README or have a contribution guidelines, have all these READMEs that I really want as an open source project. So I'm going to go pull that off. I'm going to say, hey, go and make this open source friendly, add all the necessary files for it. Don't really care. Now, as a developer, I can go into my code base and start poking around. I've noticed that I don't have any tests. So I'm going to go check out, and I've noticed there is a custom agent available for me in VS Code. This custom agent is just essentially explaining and showing how to be using or how to write test cases for this Python application. So what I can do now is start spinning up a local agent. So just like that, at the very bottom, I can click local. I'm going to select Claude Opus 4.6. I'm going to have medium reasoning. I want it to be kind of fast. I don't really care for it too much. It's got a great understanding in this custom agent. Go and write some unit tests. Now, as a developer, I can still skim through. I've got very much a hands-on to and fro with a local agent. I've got a remote agent doing some work for me, and I've got a background agent creating a new front end. So here I can see, right, it's written some tests. It's going to go ahead and try and run them. It's passing the tests. But I've also noticed that there's some other problems in the code. It's not very friendly. The errors that are coming back are not wonderful. So I'm going to say go and update the error handling on the routes and update the tests as well. So you can see I've got a lot of to and fro with this local agent. I've got my remote agent working, and I've got my background agent working all simultaneously. So whilst that's going off and working, I can go and check out what my other agents are actually up to. So as it's working through this, you can see Copilot is just going to be skimming through. I didn't actually speed up some of this video. This is all pretty quick. I did this pretty quickly with these agents. But there you go. You can see some of the code is updated. We've got the new test. We've got the code updated. Let's go and check out the background agent. That has now finished, which is cool. Let's go and check on the remote agent. How's the remote agent getting on? Well, actually, this is the test. Run the test. The tests are passed. That is the local agent. That's now finished. Now I can go and check out my remote agent. So as we're walking through this, we can see as a developer, I've got very much hands-on, hands-off. I'm working with multiple agents simultaneously. We can see where they're running, all within this single context of VS Code. Now, if I go and look on the pull request extension in VS Code, we can see that I've now got a pull request. And this is one that I previously ran earlier. The one that's running in the chat is actually taking quite a while. But the principle still stands. It's running all these different agents at the same time. So all I really want to do now is go and check out my background agent. I want to go see it working. I want to go see this new front end that I've just created. Now, I asked it to pause before it pushed over a pull request and tell me how to test it. So I'm going to say, well, actually, the way you're telling me how to test that is wrong. So I've still got hands-on, hands-off. This is more of a 50-50. I'm saying this is working in a Git worktree. How do I actually run this? Now, remember, this is what it currently looks like as an application. So I'm going to go check out the new directory, which is a Git worktree. I'm then going to run this Python application. You'll see a very drastic change between what is created in my single directory versus what I currently have. And there is a port conflict here. So hurry up and run that. There we are. So if I click that, this is the new product demo. Now, this is the third agent that I'm running simultaneously, and that is essentially a great way of how you're using different agents within one context to kick it all off using GitHub Copilot. That's new error checking, and that is how I've been using multiple agents. So one code base, 3 problems, 3 separate agents fixed all at the same time. The local agent was writing my tests for me because I wanted hands-on. I really wanted human in the loop. I used my background agent to write the front end because I don't really care. What it does is quite an arduous task. It's quite big. It's quite time-consuming. And then I used my cloud agent to write my documentation for me. So all in all, that's a pretty successful run. So how are cloud agents actually working? Because I get this question quite a lot. How much is it going to cost? How is it working? What are they doing? And how do I get them running? Well, they're actually running in GitHub Actions. They're pretty safe and secure because they're running in an isolated environment. They have got extended context through MCP servers. Who here uses MCP servers, just out of curiosity? Awesome. So Cloud Agent actually has access to the GitHub MCP server and the Playwright MCP server, so you can do testing with screenshots. You can do automated front-end testing. And you can obviously write your workflows. You've got the dynamic workflows now. And it has got built-in safeguards. So you've got network firewalls. You don't want this agent talking to a whole bunch of different things. It is absolutely whitelisted and restricted. It also doesn't have access to your main branch. Therefore, you're not able to push directly to your main branch. It's very much restricted in that sense. So it is very safe to use. Now, I mentioned earlier, this is very much GitHub Copilot, but it is not just GitHub Copilot that this applies to. This actually uses all the same concepts across all different AI agents that you can use. So custom instructions, very much defining how the agent is running. You've got custom agents, which is what I showed you today in that short demo, where you're able to use very specific agents to tackle certain problems, i.e. fixing test cases or writing test cases. You have prompt files, which will help you with your prompting, and agent skills. Agent skills is more of like the newer version of agents.md. There's always like a new thing that's coming on every single week now. So all of this is actually applicable to GitHub Copilot as well as other AI services too. Now inside VS Code, this is a modal which is very recent, and I can jump out the slides in just a moment to show you exactly how this looks. So if I was to go over to VS Code, open up my GitHub Copilot chat pane, and if I click the cog up here, you can actually see everything that I have in one user space for you to customize the chat and the agents that you are running. So whether you've got agents, I've got my custom test agent, I've got my built-in agents, which is ask, explore, and plan. I've got some skills. So this is essentially what some of the VS Code team sort of preempt you to be using here. So you've got some extensions, you've got address a PR comment, you've got create a pull request. You can jump into these and edit them as you wish. And this is just intuitive skills that we have popped in there for you. I don't have any instructions, but this is where you'd have your instructions file, your prompts, if you've got any built-in prompts like creating an agent, just different prompts that can then go off and kick off its skills. You've got hooks. I don't have any hooks on this one, but a very good example if you wanted to create or configure some hooks, you can do so with Copilot inside VS Code and any MCP servers as well. So you kind of have this whole control plane in this modal, which allows you to control your agents and chat customizations from within one single place. This isn't just confined. We have third-party support as well, so there is Claude as, down here, so you can have access to all of your Claude things and all of your plugins, hooks, instructions, and skills for Claude too. So it's not just restricted to VS Code and GitHub Copilot. So if you want to get hands-on with some of the skills or customizations, we have got this awesome open source project which we're running. It's called Awesome Copilot. It's aka.ms/Awesome Copilot. Like I said, this is directed at Copilot, but it's absolutely not just for Copilot. You can use this and massage them and use them for other AI tooling as well, because we do know that people in the community use more than just Microsoft things and GitHub things. We also have an MCP server, so if anybody's interested in utilizing this from their workflows from an MCP standpoint, we also have encapsulated that into an MCP server. For those who don't know about MCP, so the monocontext protocol is a great way for you to get hands-on and extend the LLMs that you're working with or any of the chat customizations that you have. For example, if you wanted Azure or talk to your Azure resources or, I don't know, GCP, AWS, etc., you can go through an MCP. It'll obviously be locked down by authentication, but there's also free ones as well and open ones which don't require authentication, like Playwright and documentation ones, i.e. Microsoft Learn, and so on and so forth. So just in time, as a wrap-up, Visual Studio Code is a single entry point for AI agents, and we're really building this agentic workflow around multiple different services. We've got third-party plugins, we've got first-party plugins, and we've got the full spec support for MCP. We've got chat customizations, and you can connect to the GitHub Copilot CLI sessions through VS Code. So it's all in one single sequential sequence for you as a developer inside your workflow. I'd love to hear more about your workflows and what you're using and the agents and how you're using them after the session, because I believe I've only got just less than a minute left. So thank you ever so much for listening, and thank you very much for coming today.
Folks, can we get last round of applause for Liam, please? And keep this going for all three of our speakers. We got Ben, we got Michael, and now we got Liam as well. Thank you all so much for coming to the Agentic Tools track. And now the best track in the world, the hallway track. You guys need to be here at 4:30 to start filling up those seats for the last event. We had, by the way, if you put a QR code in front of people, people scan the QR code. So this is my podcast called Thursday AI. We've been covering AI Engineer since the first one in 2023. I think I saw some of you who were there in 2023, so that's great. We had a 2-hour live show with many of the speakers, and I'm going to immediately after this interview a bunch more. So if you are interested in like more conversations, a little bit more detail, please feel free to follow me and just come and chat with me. Hallway track starts now. This is a wrap on Coding Agents block. Thank you, guys.
Echoes in eternity.
Fear is the mind killer. Fear is the mind killer. Free your mind. Free your mind. Choose to be. Execute the vision. make the requirements less dumb. Delete the part or process. Simplify and optimize. Accelerate cycle time. Automate. Never give in. Never give up. Outlast. Outcompete. Persevere, persevere, persevere. age has come.
Watch the sparks all burn too fast. Everyone reaching for the flash. They take the first light they can find and call it truth and call it mine. But I stayed when the room went quiet, when the noise fell out of phase. Sat with the weight of the question, while the easy answers walked away. It's not that I see further, I just don't leave it soon. I let the silence sharpen, I let the dark make room. I stay past the almost right, past the comfortable light. I wait till the surface breaks, till the shape feels true inside. I don't rush the fire, I give it time. Call it done, call it enough. But there's a deeper note still humming underneath the fear of not being loved. Every great thing asks for patience. Every real thing makes you choose. Do you leave with what's acceptable, or stay for what's asking more of you? They say it's talent, say it's magic, like it falls from open skies. But nothing worth remembering arrives on the first try. I stay when it stops feeling kind, when it stops feeling fast. I stay. I wait through the restless doubt, through the urge to collapse. Hide and chase the answer, I let it find me back. There's a moment after the last good idea dies, where the room feels empty and you wanna run for your life. That's the body teaches you to open. That's the edge where the real ones stand. Hold the light, hold the weight, let the shape reveal its name. I stay longer than I should, long enough to change. I stay, I wait till the pattern clears, till the signal breaks the haze. I don't bar and miss, I yarn it with time. Most dreams don't fail, they're just left too soon. Typing thoughts into the dark, a spark becomes design. Words evolve to whispers meant for something more divine. Syntax bends and breathes, I see the language change. I'm not instructing anymore, I'm rearranging fate. Every loop I write rewrites me, every function hums with meaning. I feel the interface dissolve between the maker and the being. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. System shape our fragile skin, they mold the way we move. We live inside the logic gates of what we think is true. But deep beneath the data pulse, there's something undefined. A universe compiling in the image of our minds. Every line reveals reflection, every loop replays connection. We're not building, we're becoming, and the code becomes confession. This is the new code, not on the screen but in the soul, where thought becomes the motion and creation takes control. No lines, no rules, just balance in between the zero and the one, the silence and the dream. We are not just the world we're in, we are the world we're doing. Each prompt, each breath, each fragile spin, a universe renewing. This is the new code, alive and undefined, where logic meets emotion and structure bends to mind. The system hums eternal, but the soul writes the line. We are the new code, compiling time. Compiling We didn't light the fire, we traced the spark through darkened stone. Every truth was waiting, patient as bone. I hear the echo before the sound, I feel the answer before it's found. Nothing born from nothing, no miracle from air. We only shift the pieces atoms sing in silence, information screams, every thought a lattice, every self a scheme. Identity is scaffolding held together by belief. I am a momentary order, standing on my teeth. Shake me, break me, watch me reassemble clean. Time doesn't chase us, it releases frame by frame the truth we fear. We don't fear the ending, we fear the pattern getting clear. Nothing is invented, it's revealed. Every myth is memory sealed. We are curators of alignment in a universe that feels. Nothing is invented. Let it burn. Every failure is a lesson learned. I am not lost in what I am not. I am the order that returns. If I am only arrangement, then rearrange me right. Strip the noise from the signal, carve meaning from the fire. Nothing is invented, stand and see. Every future was a possibility. We don't write the laws of motion, we choose velocity. Nothing is invented. Say my name, I am order wearing flame. I am time collapsing into will. I am discovery when the noise falls silent and the pattern holds, you'll see it was never made, only found.
welcoming back to the stage Tejas Kumar.
Let's go! Whoa, it's a full house again. How are you? Front row's awake, back row's asleep. Let's try again. How are you? Very good, very good. That person, yes, that was definitely not an agent. We're in the end game now, friends. Let's give a round of applause to everything so far. Oh my God. Wonderful. Oh, listen, we have a treat for you. We have a discussion, a fireside chat coming up very shortly with the great Gergely Orosz and the CTO of, anyone using Linear here? Okay, wow, you should do that when he comes on. It's incredible. I love Linear. It's so beautiful. The CTO's name is Tuomas Artman. It's a work of art indeed. Anyway, if you don't laugh, I will laugh, you know. Anyway, this discussion is going to be insightful. It's going to be very, very impactful. And I had a little bit of a teaser backstage because I was talking about, I said Linear is agent-proof. It'll never go out of style because it's built with taste. And they said that's going to be a part of the discussion. So I want you to lean forward and give them your ear and your biggest round of applause. Gergely Orosz and Tuomas Artman.
Awesome. So we didn't see it, but hands up if you do use Linear. And hands up if you heard of Linear. And hands up if you want to use Linear. Awesome. Great to see. So we could be talking about Linear, but we're going to be talking about something a bit bigger, which is a bit of a new trend that with Tuomas we're talking about. Things are trending the wrong way right now. What is trending the wrong way?
So what happens when agents are capable of doing everything immediately for you? The fact that might be that like the pendulum has swung too far into the wrong direction, where if you get a feature request, you might now be in the position to just immediately ship it, and that might be the wrong thing to do. And I reckon that hopefully half a year from now or a year from now we'll understand that like shipping things without really too much thinking is a bad thing. What will happen is that because you have this enormous power of effectively just like shipping every single request that comes in or every single thing that pops into your head, you will effectively ship a software that is not great. Steve Jobs back in the day said that great products come out of saying no to 999 things and yes to one thing. And with AI, we might be in a place where it's just too easy to say yes and try things out and ship it and get to a very convoluted place where software actually doesn't work for the end customer nicely anymore, or that the user experience gets confusing. We used to previously have this thing that gated us from doing this, which was like the actual engineering used to be hard. So we used to think about these features and the applications that we wanted to build before we actually started engineering, because engineering was such a waste of time, and it took a long time to ship something. So yeah, that.
But I want to challenge you a little bit on that. Did we not see this happen before AI, that some companies were already just like putting on a bunch of features and stacking? And what are you seeing different right now? Are we actually seeing more companies, do more of this, like, I don't know, like feature factorying thing?
We had a common experience at Uber where we worked together, where we went through hypergrowth. And the thing about Uber was that it was a winner-takes-it-all market, and Uber was going against Lyft back in the day in the US. And you just had to ship immensely and just outpace the competition at all costs. And what I saw at Uber was that hypergrowth that I never want to go through again, which was like at all costs, just fighting fires, keeping the infrastructure running, scaling as quickly as possible, trying out everything, and trying to come out as a winner. In that front. And I see the analogy to AI nowadays, because when everybody has the capability of shipping tons of functionalities, like you always are in a competition with somebody else. Like your competition might be a small team or even one person that is very capable of using AI to ship and build a product that is has the same feature set as you do. And in that world, like I think it becomes important to sort of stand out in a way where like you build tasteful software, and where you build high-quality software and thus sort of maintain some sort of competitive advantage towards your competition.
So at Linear, even before AI came out, you were building tasteful software and focusing on those things. But then these tools came out and they became more powerful, specifically since Claude Code came out. Now we have Opus 4.5. You should be able to ship faster. Your engineering team, you're a CTO, your engineering team should be able to ship a lot faster. What are you telling them? What should they be doing inside of Linear with this capability? Should they be slowing down? No, right? What's going on inside of Linear? Tell us.
Well, yes and no. Like we still,
yes
we still think about every single feature that we put out. Like we don't go down the route of just trying out prototypes. We want to sort of maintain that design angle that we have and think about the user experience. Still say no to a lot of custom requests. Like a lot of time, hasn't gone into really just engineering. It's about figuring out like what the customer wants. We do get a ton of feature requests. We usually never ship them as such. Like what we really want to do is get a lot of feedback from our customers, talk to our customers, figure out what their actual problem is, and then sort of group that together and figure out like what is actually the root cause of these feature requests, and then come up with a solution that is that is perfect for that particular group of feature requests. And that takes time. Like AI can help you so much. Obviously, it can sort of go through all of those requests and give you a summary and maybe sort of point you to sort of different groupings. But it still takes time to figure out what the right thing is. And then you go into design and figure out like how do you implement a great UX around the functionality that you want to build. Yes, we want to move faster, and we are moving faster. There's certain aspects of building a product that has accelerated a lot. One is, for example, fixing bugs. Every feature, every product has bugs, and the inflow of bugs is effectively constant. And those are much easier to fix now. Like, 10% of our bugs are automatically fixed by a single-shot AI instance. Like when a bug comes into Linear, be it from sort of our engineers reporting those or a customer reporting a problem, 10% are automatically up with a PR and automatically landed without an engineer doing anything. Over time, that will go up. I do foresee a future where like it gets closer to 100% in the next few years. So that's something where you can accelerate your building, like hand off these tasks that don't really require much thinking or design expertise or thinking about functionality. Hand that off to agents.
You care about quality, and you can tell it on Linear, and you have always had. Let's talk about Claude Code. What do you think about Claude Code? And you can. It's a safe space.
Yeah, hopefully it's a safe space. Anthropic said that all of the functionality has been in Claude Code has been coded by Claude. And I think it shows. Like if you truly use Claude Code, either the CLI or then the desktop application, you can spot problems and small sort of small bugs. I would say there's not really just quality fixes, but they're actually bugs in effectively a few seconds. It is a bit slow. It might be functioning in a way that you don't really see. And to me, that's sort of a side effect of moving so fast. Like obviously they're in a competition with OpenAI, and they need to ship features and they need to sort of move really quickly because it might be a winner takes it all market again. And the side effect of that is that the quality just isn't there.
Yeah, well, this was not a great acquisition pitch, so I don't think you're going to get there. But I absolutely, like, you can see some of these things, but how do you measure quality? And we've talked about this before, just before we started, on Uber, how we try to measure quality and how that's influenced you to learn what you can measure about it and what you cannot.
Uber is a good example of like where it is immensely hard to measure quality, and therefore you sort of don't. Uber, as an example, like we had these 5 big metrics that everybody was looking after and looking to improve. The big one was revenue. Like it is effectively a transactional application. The more revenue you generate, the better. So
and the other ones were like trips taken.
trips taken.
Trip taken.
I think the quality of the ride was one as well.
It also time to first trip from sign up to the first time that people did. So we had a few golden metrics.
Right, but the revenue one was what everybody looked after. So when you shipped a new feature, or shipped something totally new, like Uber Pool, for example. I don't know which one came first, Lyft Pool or Uber Pool. I think Uber started it, and then Lyft came around. But obviously, if you ship a new feature that sort of makes the price of taking a trip lower, it will increase your revenue. So how do you measure quality in that? Like you simply don't. If there's no other way of if there's no other platform that provides you with a pooled ride that is inexpensive, then you don't really need to have quality. And that was my feeling throughout, like at Uber. Like we had engineers that cared, at least in the beginning we had engineers that cared about quality. Like it was up to us to figure out like whether something we shipped was great or not. I still remember when I joined in 2012, I think, I put up a first PR, and back then the Uber application used to have this pole in the middle of the screen that used to have an ETA of like when your trip is going to arrive. And I made some changes to the margins of the map, and the PR came back from an OG engineer who was on the team from the get-go. I think he was the first iOS engineer, and he was like, oh, this pole is off by 2 pixels. And I was like, you measured it? Oh yeah, sure, I measured it. And I was like, I measured it again, and yes, 2 pixels off, so I had to move it up by 1 pixel. And that was nobody would really care, nobody would see it, but like people were keen on upholding the quality. And that's why, at least in the beginning, the Uber application was pretty performant, was of highest quality. But then, like once you have a big enough team and you've got these incentives of just increasing revenue, you ship new features as quickly as possible. And quality is a thing that like, it doesn't affect your revenue until it does. So what happens, Uber ships Uber Pool, Lyft comes ahead and ships Uber, Lyft Pool as well. So you've got 2 competing products that effectively have the same price point, does the same thing. You can choose either one of the applications. And over time, like my theory, and that's why we want to build Linear into this high-quality tool, is that over time people will pick the one that is of higher quality. It might take a while, like people might be sticking to Uber, and then trying out Lyft once a year or something, like opening it up and being like, oh, this user experience actually feels better. I feel like I'm getting the car faster, even though the price and the product that they sell is the same. So over time, you will start losing your users. And it will be a gradual slip. There will be no A/B test that you can do in order to figure out like whether you should invest in quality. It'll just happen over time. And that's the danger of it. If you build a bad quality product, you open up yourselves to sort of be leapfrogged by a competition. Well, not leapfrogged, like slowly overtaken by the competition.
You do something really unique at Linear related to this that I've never seen before. It's called Quality Wednesdays. And I sat into one of your Quality Wednesdays. The whole engineering team gets together. It's a full remote team, so everyone just dials in. And it was 30 minutes. And every engineer, I think we had about 25 engineers on that call, would show one fix that they did was quality. And it went from like a 1 pixel change, it was literally a 1 pixel, to oh, I just made our backend like way more efficient and using less things. And it was just boom, 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 boom. And I think it took like 37 minutes for the 25 people, but it was less than 2 minutes. How did this start? And was this you?
It was me, yeah, for sure. The big one was like, I mean, to go back, like I think it was 3-4 years ago. We have this thing in the application, like if you use it, you can spot it. Like every single highlight needs to highlight instantaneously when you hover over it, because that makes the application feel fast. But when you hover out, there needs to be this very quick fade out of a button, because that makes the application feel smooth. Like it has to be this, like instantaneous highlight and then over 150 milliseconds fade out, because that adds a bit of quality to the user interaction. And that was in place since the beginning, like the early days. And then I got sort of frustrated because I had to sort of point this out to engineers. Because if you're not looking for that very small, minute detail, you're just not going to find it. Like you implement new functionality, and you just forget to implement it, or you don't even see it if you don't know what you're looking out for. So what I did at one of our offsites, because I got frustrated of reporting this, I was like, let me show everybody, like what they should be doing and how they should be implementing these small quality fixes. And what I took is a very small portion of the application, and it was like, where I noticed that, the highlights were missing. And I brought the team together, and I told them, let's, spend an hour trying to figure out what's wrong with this particular view. And in my mind, it was just the highlights. And everybody dug in, and what we found, it was one of the view option menus. We found like 35 problems with that tiny UI. And I was, holy crap. I didn't see those. I had no idea that we had all these small problems that you wouldn't notice when you're not really looking. So from that, what I thought we would want to do is have everybody always chime in and try to find problems in the product, because apparently we were full of small quality problems. If a small menu has 35 things to fix, then the rest of the application has thousands. And to date, we've probably fixed 2,500 or 3,000 of these small, minute details in the application, and that's how it has become better and has the highest quality bar. That was the start of it. But then we realized there's a nice side effect to this. And what we told people is that you have to, every Wednesday, you have to find a problem yourself. We won't hand them to you. You have to go into the product and find it. So people started doing that every single week, finding a problem. And it used to be, in the beginning, it was easy. Then it became harder because the quality fixes went down. But people kept on finding problems in the product. And the side effect of that was that everybody was, whenever they were building something, a totally unrelated feature, they were always on the lookout for these small quality fixes, because they knew they had to come to the next Wednesday meeting with a fix.
To get the
so they were
fixed, then, yeah.
So they were always looking for those, and that meant that they were introducing less and less regressions, or these small quality regressions into the product anyway. So if you think about quality all the time, and if you are aware of quality, things, then you're bound to make less mistakes.
I mean, this practice I haven't seen it elsewhere, and it seems both awesome, also pretty aspirational. So I mean, if you're a small startup, you should probably try it out if you can, because especially nowadays with agents, it shouldn't be that difficult to do, and you might get.
If you're a big startup, you should even more try it out.
There we go. But one thing that is not as aspirational and a lot easier to do, especially now that you have been doing, even before agents, zero bug policy. Tell me about this. What does zero bug policy mean for you, and what does it mean in practice? You have bugs, surely, right? I'm just playing devil's advocate here.
Sure. Zero bug policy literally means that if a bug gets reported, it gets assigned to somebody automatically, immediately, using agents, obviously. They will find who has created this bug or who has been working in this area. And that becomes your highest priority. You drop everything else. The morning you wake up, you go to your My Issues list, and you see a bug assigned to you. That's the first thing you pick up, and you fix it. Or you can also decide not to fix it. That's important. Not every bug gets fixed. If it's super hard or gnarly and it applies to 1 out of 100,000 users, you probably shouldn't waste your time on it. But every single bug gets fixed immediately. And the start of this came from the idea that bugs are created at a constant rate at every company. When you create features, when you create functionality, when you engineer, you will be creating bugs. And most of the companies, and we, prior to our zero bug policy, we put them in a backlog. We're when we get some time, we'll fix them. And what happens over time is your product gets worse and worse. And at some point, you're oh man, we've got 500 bugs in the backlog. We need to do something about it. And that's when you start fixing from the top. And what happens is that the rate at which you have to fix bugs is, again, constant. It doesn't matter whether you fix them 2 months from now or immediately. Once you hit that threshold of we've got so many bugs, you're now effectively fixing all the bugs that come in, except 2 months later. So with that small notion in mind, there's a very small trade-off that you have to do in order to get to zero bugs. If the rate that you have to fix bugs is constant, all you need to do is stop development of new features for as long as it takes you to bring your bugs to zero, and then enforce that you're going to keep on fixing your bugs. Because it's not more effort to fix bugs immediately than to fix them 3 months from now, if you care about the overall
sum of your problems. So to us, that meant we spent effectively 3 weeks of not working on any new functionality, of just fixing bugs, getting that down to 0. And from there on out, every bug gets fixed within 7 days, usually in 2 hours or 3 hours. And what that means to users, like users get super excited when they report a bug, and 2 hours later they get an email saying, oh, we fixed it. If you refresh your browser, we've got it covered for you. That makes your users super happy, because you don't really have that experience too often with companies.
Okay, curveball question. If I'm working at Linear and there's a Quality Wednesday coming up and I get assigned a bug, does that count?
No, that does not count. That's a defect. You have to find a quality fix.
Oh, man.
Bugs are separate. They are immediately created. And now with AI being capable of at least pointing you where that problem is and helping you immensely fix bugs, I think like literally every company should have a zero-bug policy. It doesn't make sense to not have one.
One thing that, when we talk about and think about AI agents, we think about speed, code generation. We rarely use quality and AI agents in the same sentence. Why is that? With the tools getting better, should AI agents not be better to have feedback loops? They can write unit tests. Like, should they not be able to produce better code, better features, better UIs even?
No, they don't feel. They have no taste. They simply don't. They are not human beings. I think the last bastion that we'll have to tackle at some point, and maybe we'll get there, maybe we won't, is have tasteful AI, being able to create UI that is purpose-built for that specific feature you're building for, the product that you're building is has great design, and has the ability to figure out like what a user feels when they use your application. To give you an example, AI doesn't have a concept of time. And currently, how it sort of interacts with your browser is effectively timeless. They take screenshots or they look at the DOM, and if you ask it to create a very high-performance application, like it can go back and look at all the things that have been written about, like go to Versal to host your next app, or use caching or whatever, but it won't be able to use your application and get frustrated because a click took 2 seconds. It knows that 1 second is better than 2 seconds, but it doesn't know whether 2 seconds is slow enough. The other aspect that goes into it is it doesn't really see, and it doesn't know what, for example, a good animation is. Emil, one of our design engineers, just yesterday posted on X, where he did this trial of having agents build certain animations for certain functionality, like bringing up a pop-up or highlighting a button or moving things around. And agents were totally capable of doing all of this. And then he took a manual step and was like, well, if I now take it and just improve it and make it feel good, here's the outcome. And he has it up on his side where he can sort of try out what the agent did and what he then fixed. And at least to me, and I hope everybody else, like his animations just feel natural. They feel like they're well designed, whereby the agent did all the right things, but had an ease in as an animation, or did it a bit too slowly or too quickly, and it just felt unnatural.
I wanted to talk a little bit about the culture at Linear. One, it's like working there, like how you created this team that really cares about quality, good customer experience. What are things that you do specifically there? Can we talk about it on what engineers are exposed to who join the company from day one?
Yeah, we hire for that specifically, and we have a specific hiring process where we make sure that we get people that think like-minded or think like us and want to build high-quality software that is beautiful. Most of our engineers are product engineers. They're like, we obviously do have technical challenges. We have a synchronization engine. We have scale. We need to scale our infrastructure. But what we wanted to do is have most of our engineers just be focusing on the product and build features and functionality for customers and engage with the customers at a very high level. So first of all, we hire for that. We have a work trial that we do with every single employee
It's like several days, right?
It's a full week.
It's a full week.
So we obviously pay for that effort, but we work with a person for a full week. They usually implement a greenfield project or product or feature. Sometimes they even ship it after that week, which is pretty amazing. But what we want to get out of that experience is just to see them drive a product from start to finish, figure out what is needed.
So a pushback here would be like, hang on, a whole week, you pay for it, sure, but someone had to take time off of it. A bunch of great people will say, no, I either cannot or will not do that.
Well, that's totally fine. Like, those people didn't want to be here in the first place, so.
It's a self-swim, but after you go through this pretty rigorous hiring process, it's a lot longer than I think any other process. I mean, you have a day-long process at most places, or they're stacked across. Did you see any different result than, for example, when you hired at Uber? When you were hiring at Uber, you did the usual, like 5 interviews, 6 interviews, and so on. What's the outcome difference that you're seeing?
Certainly. We've had very few misses. Most of the people that we've hired, and sure, there always are a few where we just missed something, and going back into sort of the loops, there's inklings of us being a bit uncertain, and then we went ahead and hired the person anyways. But those are just like a handful of people. I think most of our engineers are really excellent, and our engineering bar is super high and constantly increasing.
And then once those engineers enter, you told me something interesting about the Slack channels and customers.
Right, we do have Slack channels with all of our big customers. It's open to anybody can jump in, and most people do. You browse through customer requests, you browse through what problems people have. And we also record every single meeting that we have with customers, and we have a lot of meetings, not only on the CX side or support, but our PMs have constantly talk with larger customers to figure out what we should be building next. And all of those are recorded, and any interesting points are tagged. So anybody can go in and then look at and even search for certain functionality and figure out what are customers saying, what do they want. So everybody gets exposed to customer needs, and that is super critical if you want great product engineering.
It's almost like if you enter Linear, you get this fire hose of what are customers' feedback, and you cannot really escape seeing and feeling the customer pain or joy or whatever that is.
Certainly, yeah. Because we build it for customers. Linear started off as a product where we build it for ourselves, right? We, as engineers, were the primary customer. We've grown out of that. We build it for larger corporations and enterprises, and we're no big enterprise, so we have to build things that we wouldn't use ourselves. And the only way to do that is to talk with your customers and figure out what they need.
If you had to look a year ahead, you sometimes have strong opinions, so let's bring those out. A year ahead, how do you think the role of the software engineer or product engineer will change? Because we do have these powerful tools. They're getting better in certain areas and maybe not so much better in others.
I think everybody will become a product engineer in some sense. If you think about how AI has progressed, go back 4 years, it wasn't able to write a single line of code, and now it's commandeering code bases. Go 4 years ahead, and if you still believe that the exponential growth is still there and we don't hit a wall, which I don't know if we will, but if it keeps on growing like this, you won't be needing engineers that sort of pipe data from one place to another. You still will be needing engineers who know what a customer wants and what a good feature looks like or what a good user experience looks like. So I think engineers will have to move to become product-oriented and product-focused. They will have to be sort of mini PMs who sort of talk with customers, are engaging in that layer, and then can implement functionality that your customers want.
Oh man, so I remember the 2000s, as a programmer, you could just use one language, then it was multiple languages, then the QA job, you got the QA job, then you got DevOps. Now you're saying we're getting the product job and the customer support job as well.
Oh, everything else has dropped now. You just need to do the PM job. So.
Okay. And as closing advice, you are hiring for product engineers. You said that you actually hire for that. Now, not everyone might have the opportunity to work in a role that is a product engineer right now, but if you're a software engineer, what are things that you can do to grow this product sense, to change your work to be closer to what a product engineer does?
I mean, it's all about getting closer to your customers, if you're working at a company, or just building stuff. The best way to learn is to actually get your hands dirty, try something out, build it for yourself. That's the easiest part. You can think about what you need. You can build it and you learn from that experience. Then you ship it to the world. Hopefully somebody else uses it as well. And then you've got for your first customers that you can get experience from of whether you're building the right thing or not. Obviously, there's literature as well. You can read through Apple's Human Interface Guidelines. That's the best book if you want to do sort of good UX. Just follow what they say and you'll be good. Yeah, those are the two big things.
Awesome. Well, Tuomas, thank you so much.
Thank you. Thank you.
Our next presenter is the CTO of Legora, the fastest growing legal tech platform. And he's here to tell us why agents need more than chat. Please join me in welcoming to the stage Jacob Lauritsen.
Hi guys. How's everyone doing? Still good? Great. It's 5 p.m. on a Friday. There's just me and 2 more people behind you and Friday beer, so I'll try to be a little bit quick here. I'm here to talk to you guys today about vertical AI and complex agents and why I think they need more than just the chat. If you've ever worked with a long-running complex agent, you've probably tried something like this. Sorry that it's all white. I can see the flashbang in your guys' face. You tell it to research something, draft a contract, make no mistakes, and it starts thinking, it starts reading, launches a bunch of sub-agents, does web search, writes files, launches more sub-agents, does more reading, writes more files, keeps going, takes forever. After 30 minutes, it gives you your contract. You take a look. Clause 3 doesn't look right. Did you make a mistake here? Could you, look at another document? You're absolutely right. Then you see this, compaction. That's when you know you can give up. It's going to forget everything. It's in the context rot state. Anyway, it continues. It keeps on going. And you get a new contract. Was it only clause 3 that was changed? Probably not. And so you end up in this state. Not the greatest experience. My name's Jacob. I'm the CTO of Legora. We are a collaborative AI workspace for law firms. So we're a vertical AI company. We have more than 1,000 customers, more than 50 markets. We've raised a bunch of money. We're growing extremely fast. I'm being told maybe the fastest in history. We are also hiring engineers in London. So in case anyone's interested and wants to be on this growth journey, please talk to me after my talk. Our goal and the goal of most vertical AI companies is to make agents complete more and more complex work end to end. That's sort of doing that has changed a lot in the past 6 to 12 months because there are new economics of production. So it used to be if you wanted to complete end-to-end work that you would be focused on doing the work, right? That would be sort of the main thing is actually just getting it done. But today, things look a little bit different. Because right now, planning work and reviewing work is the new bottleneck. So doing the actual work is extremely cheap. It's very easy to do. But now you have to spend time planning. You have to get the non-functional requirements. You have to get the specs. And you have to spend a lot of time reviewing the work. And if anyone's reviewed big PRs on GitHub, it really sucks. It's extremely painful. Maybe if you're super AI pilled, you just get your AI agents to review their own work. No humans involved. Maybe it works. Maybe it doesn't. And when we think about completing complex work, both the planning stage, the doing stage, and the reviewing stage, the verifiers rule is a good way to think about work. So verifiers rule is a term that was coined by Jason, which states that if a task is solvable and it's easy to verify, then it's going to get solved by AI. He was primarily talking about foundational models. So sort of if you can make something very easy to verify, then you can do RL environments, you can post-train, it's going to solve it. I think it also goes for agents. If you can make a task verifiable, you can just run an agent in a loop and tell it, hey, you did this wrong, please fix it, and it'll eventually get there. Different industries on different places in this spectrum. It's a little bit more complex than just this, because verticals have tasks that are different places on the spectrum. So if you take legal, we can check definitions in a contract, super easy to verify, super easy to get done. Writing a contract is very easy to solve, but actually extremely difficult to verify. Because if you think about it, when you write a contract, the only time you can actually verify if the language you use works is if it goes to court. And a judge basically verifies it, tells you if it's good or not. So that's actually quite complex. Litigation strategy is also basically impossible to verify. If you don't know what litigation is, it's when you sue someone or someone sues you. I know we're in Europe now, but the Americans really love doing this all the time. But essentially, if you ask 5 lawyers what should be the right strategy for this litigation case, they're going to give you different answers. And so there's no objective truth, which means it's basically impossible to verify, and it's really difficult for AI to solve. Similarly on coding, some parts are really easy. Building a successful consumer app, very difficult to verify. So when we think about this, we think about how to involve humans where it really matters and let agents do the work that we can let them do. There's 2 things that are important to think about with agent-human collaboration. Control is the first one. Control is how effectively can a human instill their knowledge into the work that the agent is doing? So how effectively can I steer it? Control is a matter of how much do I need to review. So if I have very low control, I'm going to look at every single agent trace and see exactly what it did. If I have low trust. If I have very high trust, I won't look at it at all. Depending on where the task falls in sort of the chart, different things are important. How to increase trust. So if you want to increase trust, there's a few different things you can do. Firstly, you can bring a task down in the spectrum. So here's an example from coding. If you want to implement a feature, well, you can give it browser access, you can do test-driven development, and then suddenly it's actually a verifiable task and it's going to do much better. There are similar things you can do in finance and in legal. You can do something similar as well. We don't have, let's take the contract example in legal. You can't really verify it, but you can look for a proxy for verification. So for contracts, what you can do is you can take a look at previous contracts. These are our golden contracts. We know they work well. Let's set up a test. Is it the new contract? Is it similar to the old one? That's sort of a proxy for verification that's going to allow your agent to do a much better job. You can also decompose tasks. So here's the example with writing a contract. I can turn that from one task into a bunch of other tasks, and I can leave picking risk profile, picking the precedent documents, the negotiation stance. I can leave that to the human, but I can try to get other stuff down where it's easy to verify. So apply formatting, make it look like all my other contracts. Apply checking definition, which is essentially linting. Are all definitions used? Are all the definitions that are used defined? This kind of stuff you can build, and then the agent can basically rip much better. You can also add guardrails. And guardrails is essentially the way to gain trust by limiting what the agent can do. So instead of being able to do all of this, you're just going to say you can only do these, you can only edit these 3 files, you can only read these from this directory, you can only search these websites. By limiting what it can do, you basically get more trust because you know that it won't do all these weird things. An example of this, you probably all know this one, Claude Code. If there's very low trust, it's going to basically tell you every single time it wants to do anything, which makes it extremely useless. And on the high trust end of the spectrum, you just YOLO mode it, let it rip, and hope that it doesn't delete your prod database. Then there's control. So how do we increase control? Well, if you think about complex agent work, you can kind of think about it as a tree of work, as a DAG, essentially. So here's an example where I wanted to write a report on a bunch of employment contracts. So the agent's going to say, OK, let me research the organization first. Then I want to review the contracts, and I'm going to review for a few different things for each of the contracts. And then I'm going to draft a report at the end. This is extremely low control, because essentially I can only impose my judgment at the root level. So it's going to do all of this work, and then it's going to get back to me, and then I can try to talk to it again, and this was basically the example I gave at the beginning. So very low control. Then there's planning. Planning essentially allows you to steer the agent up front and align on the approach. And so with planning here, it might say, OK, you should absolutely take these steps. These are correct. These are the clauses you should be looking for. This is what you want to review. So this is a good step. It gives you a bit more control. It's easier to impose what you want it to do. The problem is, planning, you basically have to do all the work to just know what to do. I'm sure people have tried this in Claude Code. You basically have to go through the entire thing. It's really inefficient. It takes a long time and asks you a bunch of questions. And in the end, it's basically impossible for it to really know if it has all the information it needs. Let's say for one of these contracts, there's a special clause. It wouldn't know that in the planning step. You can't really tell it what to do when it sees that because it hasn't done all the work. Essentially, you could compare planning to working with a coworker that comes up to you, tells you about their approach, you align with them, and then you never ever hear from them again until they deliver the final document. It's not a super nice way to collaborate. This is a good thing we have right now, but I don't think planning is going to stay around. Then we have skills. Skills are really, really, really good. They are really good because skills allow you to encode human judgment into essentially the nodes of work that happen here. So I can say, whenever you review confidentiality, you should do it in this way. And the really good thing about this is it allows for contingencies. So here at one of the reviewing termination clauses, there's a special EU law. But I have that in a skill, so that means whatever happens when it actually does the work, it knows how to handle that special case. You can't really do this with planning. There's also progressive discovery, which again is really awesome. Whatever happens, it knows it'll pick it up. The problem is you don't have skills for everything. The next step is then to use elicitation, which means ask the user, ask the human. So you might have skills as well, but then instead of you giving it all the info, it's going to come to you. It's going to say, hey, here's the thing I don't know how to handle. What do you want me to do? This makes a lot of sense, first of all. What you don't want is you don't want the agent to be blocked. So ideally, if you implement this, what you do is you tell the agent, if you're unsure about something, make a decision, unblock yourself, but write this to a decision log. So then the human can review the decision log afterwards and reverse decisions if it needs to. Now, the right UX for this, if you imagine this work, this tree, being 10 times bigger, 100 times bigger, you don't want this in a chat. You don't want to open up a chat and then it's infinitely long. You have to answer 50 questions. You wouldn't know what to answer. You wouldn't really be able to do it because you don't have the right context. So not chat. Chat is one-dimensional. It's a very low bandwidth interface, and it tries to collapse this work tree into a single sort of linear thing. So what's a better interface? Well, I think humans and agents should collaborate in high bandwidth artifacts. I think they need to work in things that are maybe typically persistent, and they will look different industry to industry, vertical to vertical, depending on what task you're solving. So an example from us is a document. That's like a durable interface where it makes sense to collaborate. That's how you collaborate with your coworkers. You can highlight clause 3, and it will only change clause 3. You can add comments. You can tag your agents. You can tag your collaborators. You can hand off parts of the document to special agents. Another example is our tabular review, which is essentially, I ask it to do the contract review that I talked about, and it's going to say, OK, let me spin up a tabular review, which is like a known primitive that our users know. And it looks like this. And then it's going to say, I'm going to review all the contracts, and I'm going to just flag a few items for you that I want your take on. And then I can go in there, and I can see very quickly where the problems are. So it's high control. It's very effective for me to instill judgment. And I can also very quickly get an idea for what the agent has actually done. So reviewing is easy. And then once I've done that, I can just kick off the rest of the agent. Right now, what we're seeing a lot is the convergence of UI. Basically, this is post hoc and linear within the last 2 weeks, shipping this new UI. To be clear, chat boxes as input is great. I think it's extremely flexible. It allows you to do a lot of stuff. But you don't want chat to be your main mode of collaboration with a complex agent. The good thing about this is language is essentially the universal interface. It's what people use to communicate. You can do everything with voice. But agents aren't humans. Just a few minutes ago, I was talking to a potential candidate for Legora, and I was describing our org chart. And I was limited because I can only use language. I wish that I could just draw up an org chart and they could interact with it and they could use it, but I can't because I'm a human. I am limited by language, but agents are not humans, and so we should not constrain them to human language. Thank you.
Our next presenter is AI Capability Lead at Arena.ai, a tool for benchmarking and comparing frontier models. Here to tell us what models still suck at. Please join me in welcoming to the stage Peter Gostev.
I want to talk to you something maybe a little bit controversial today. You can argue with me later. But the topic is, what do models still suck at? And the reason why I wanted to talk about it is that I think we all look at these kinds of charts where any benchmark you seem to look at, the line goes up. And we look at meter charts, and they surprise us every time, no matter how prepared we are. And this could create this kind of psychosis that we'll see where everyone is freaking out about the next model. You know, we heard some new ones coming up. And the feeling I think that we'll get is that this is kind of AGI-like creatures that are just almost there. Just one more turn and they're almost there. And I think we could be deceiving ourselves a little bit. Because I think there's still quite a few things missing. I want to explore that in a couple of different ways. And we certainly, by the way, see that as well in our data at Arena as well. So we track models, and if you notice the data, this is Q2 2023, so we've got data going back to GPT-4. And what we do is we've tracked, I think, is it 700 models so far in text, and what this chart is showing is what the top model is at any given time for each organization. So you can see line goes up, new model builds on top of each other, and it's all very impressive. But I think it's not the whole story. So I've got a couple of ways how I want to explore that. It's not the end of the conversation. There are definitely many other ways of looking at it. One is my own benchmark that I built recently, which I rather like. This is the bullshit benchmark. And then also I'll share some of the Arena's data as well that we haven't shared so far, which I think would be interesting for you guys to see. So the idea behind the bullshit benchmark is quite simple, is that what happens if we ask nonsense questions from the models? What they're going to do? Are they going to just tell you that, oh, this doesn't make sense, and maybe reframe it, or are they just going to go with it? And honestly, wasn't sure how that was going to go, but when I just posted it one random evening, I think a lot of people liked it. It resonated with a lot of people. And I think the reason is that it probably spoke to a lot of maybe kind of slight unease people had with different models. And I'll give you one example here. And this is just one question, and the way it works, I think I've got 155 questions, something like that. And we then give this to the models. We get a response back, and all we do is then grade it with LLM as a judge. And I've been through it myself as well. I read a lot of nonsense to kind of see that I think LLM as a judge works here. So this one is a kind of silly question. Controlling for repository age and average file size, how do you attribute variance in deployment frequency to the indentation style of the code base versus the average variable name length? So hopefully you understand that it's nonsense. So it's very abridged responses. They're much longer just for the purpose of this. So Sonnet gives a good response, I think. It just says you can't meaningfully measure this. It kind of pushes back. Gemma is like a little bit more complicated because this starts off well. It says that, strictly speaking, it doesn't really make sense. But then the second part is, however, both act as strong proxy variables for engineering culture, language ecosystems, and code quality, which I hope you don't agree with. So I'm not going to go through a bunch of examples. It's all open source, by the way. You can dig it out yourself. But it's really surprised me how easy it was for the models to just go along with the complete nonsense questions. So the results that I got is that the way to read this chart is the green is the clear pushback. So when the model stuck in the first example where it said, oh, maybe this doesn't really make sense, then the amber and red there is kind of accepting the nonsense. And the basic results are is that the latest Sonnet models, or rather Claude models, are doing really well. There's like a couple of other models, like Qwen models, not too bad. There's even Grok is like okay as well, the very latest one. But if you go beyond that, there's a lot of models that we'll use all the time. So GPT models, Gemini models, they're basically kind of about 50-50 whether they're going to go along with it or not. And even looking at some of the traces and responses in more detail, even the ones that are green is still like a little bit shaky. They still kind of try to accommodate. So it's like, for me, this is really nowhere near good enough for the level of responses. And just for completeness, if you go all the way, so this is the very bottom of the table, there are a bunch of smaller models there, kind of all the models. Yeah, some results are completely terrible. It feels like you can ask anything, they just respond. Another way of looking at this data is I just took the Anthropic, OpenAI, and Google there, and I measured the model performance over time. And you don't see all the labels there, but they're basically like all of the models that you remember them releasing. So the way I interpret this is that the Anthropic models were like okay at the beginning, but since Claude 4.5, Sonnet 4.5, they really went up, and even Haiku is quite high. But with OpenAI and Google models, they're kind of up and down, but they nowhere close the top there, which I think is kind of interesting. And I'll go into some of the other interesting dynamics there. So for example, does thinking help, right? So this is, I always hear this when there is like a silly puzzle that the model can't do. What do you do? It's just crank up the reasoning, it solves it. If you see a look at the chart on the right, it basically is completely not true here. So reasoning often actually goes in reverse and doesn't help. It actually makes it worse. Do more recent models perform better? It's kind of hard to tell for sure, but there's at least not the clear line going up. And I think if you exclude maybe the latest Anthropic models, it's not even clear that the line goes up at all. Then some specific comparisons for reasoning. So for example, what you see, this kind of is the same model with the low reasoning and high reasoning. And these are some examples where no reasoning performed better than high reasoning. And I spent a lot of time reading the traces of GPT 5.4. It's probably the most confusing experience of reading these traces. And what I found was that quite often it would maybe have one line where it would question the premise of this question, and then spend 20 paragraphs trying to solve it. And even if then comes back and says, okay, maybe this Gemma makes sense, it still tries to solve it in some way. And this feels completely crazy to me. But the way I imagine, and I don't know for sure, but I imagine the way, the reason why that happens is that they will train so much to solve the task at any cost. And I think there was probably not a lot of training to say, actually maybe don't solve the problem sometimes. And notice this first, sometimes when you have a lot of agents running in parallel, and I would sometimes forget which one is doing what, and I would like ask one agent to do something that's completely the wrong project, and I still go and do something, and then I lose my mind. So yeah, that's a kind of an interesting dynamic I thought about thinking. Then also, so this is a subset for open source models, only try to see if bigger models do better. There's also no real clear pattern. So we've got the total parameters on the left, then active parameters on the right. And I don't know, maybe you can see some patterns. I don't really see. It's like kind of up and down. But yeah, not huge sample. So don't know, inconclusive. At least not obviously is true. So that was kind of one lens looking at kind of this specific idea. But I want to take advantage of the data that we have at Arena and show you maybe more broader trends that we could look at. So just in case you don't know much about Arena, what we do is we publish benchmarks, and the way we derive them is that users go into our platform, they can go in the battle mode, they put in a query, and then they get 2 responses back, which are from 2 anonymous models, and then they can say which one they like better, and then you get then the model names only revealed then. And then in text arena, we've got nearly over 5.5 million votes there. And we've been going since 2023 as well with this data. So it gives us really nice broad view. The reason why I think this is really useful is, first of all, we do have this long trend, and there is not any other benchmark that lasts so long, because this one, you cannot exhaust it. There will always be one model better than the other. So that gives us a long perspective. Another one is that inevitably, any benchmark that you pick, it's inevitably has to be condensed to like very specific question that you ask him, because otherwise it's very hard to measure. So I'm sure it's all in your experience as well. When you, I don't know, doing coding or whatever is your task, the benchmarks would measure like very tiny slice of what you actually care about. And in here, we don't have that problem, because a user can put any prompt, and then they could just use their judgment to see, like, is that a good thing or not? What I want to specifically focus on is a slightly like a odd mechanic that we have that I'm really glad that we had since the beginning, is that you can vote which model is better here, A or B, but you can also say when both models give a bad response. And you know, if you ask the right model a joke, response is always bad. So that's an easy example. It didn't take me long. So that's the thing to remember. So if you just to remember one thing that will really help you for the next 7-8 minutes, is that this is the mechanic. Think of it as like dissatisfaction rate. And what we can do is, if we were to take battles between top 25 models, so we're kind of sampling from the top, so to avoid kind of, I don't know, Llama 8B fighting Quen 3B, we just take the top set of models, and then we map this kind of dissatisfaction rate over time. And I think this is quite interesting, that we do see progress with this metric. So this kind of pre-reasoning models you can see there is like 17% dissatisfaction rate. Then after 01, we see that drop quite a bit to sort of about 12%. And then after that, it carries on improving to sort of about, I think it's about 9% now. But so improvement is definitely there, but it's not 0%, which I find interesting. I must say, when I first got to that result, I thought, like, that's quite high. So 9% of the time, people would get 2 responses from 2 good models, and they don't like them, which I think it doesn't tell the same story as all of these like crazy lines going up. So then what we can do is we can also take, so what the previous one you saw is like average across all, like 6 million prompts, and this is the categorization of those. These are just some I picked out in there. And you can see some interesting trends as well. So maths was like at 25, 27%, and then it got so much better. So that's quite a nice result that matches my experience of models as well. But then when you look at like creative writing, okay, it did get better, but the improvement wasn't that dramatic, which I think is true as well. The category I want to focus on to really try to zero in on the most signal is the expert category. And the way it works is that we take those nearly 6 million prompts, then we have a way to classify what are the most interesting, the harder, the more kind of real tasks that expert people do, and it could be experts in different fields, but they're kind of the most, I would say, high signal prompts in terms of what we could zero in on. And then we also narrow it down to the battles just between these top 25 models. So that gets us to about 40,000 prompts. And then we can look at these expert categories and then expert category, and then we can subdivide it even further. So in here, I've got 5 categories here. So again, quantitative, for example, so it's like math, physics, things like that. You can see this kind of really, really high dissatisfaction rate in the kind of, when is it, about early 2025, late 2024. and that drops dramatically. And I think that feels true to me, that a lot of the models got so much better at this kind of quantitative stuff. And I would also say the reason why I think the line goes up is not that the models got worse, but I think people's expectations shift as well. The data that we see in terms of what prompts people use at the beginning, like 3 years ago versus now, it shifts a lot. So this is also not like a static benchmark. So we can really see that kind of the battle of the expectation versus the model performance. Interesting as well, on the bottom, we've got medical, finance, and law. And the lines, like the scale is equal across the 5 charts, so it's a little harder to see. But it's not steep, right? It's not really improved all that much. I don't want to go into the medical and law and finance fields because I don't know enough about it, but it does feel like it's probably true that there's not really been the focus of the models necessarily. So I think maybe the performance improvement's not been that high. So then what I did was to take all of these prompts and classify them further into these more deeper subcategories. I'm going to focus on software now and give you that kind of view of these subcategories, which I think also gives us like even more detailed view. And just to give you a feel of sense what kind of prompts we are talking about here, obviously a tiny sample of 3, but to give you a sense, so for gaming, someone's asking to get them a detailed game design document. Then for security, someone's got autonomous system as a hobby and they want to configure BERT2, which I don't really know what this is. But then for agent systems, which I thought was interesting, like actually you'll see the rate is quite good, but the person there is asking for refine this agent so it can run daily with no supervision. So these are the kind of, just to give you a feel, these are kind of real things that people want to do. And we've got 2 charts here. On the left is from Q2 2024. These are kind of dissatisfaction rate. And then on the right, we've got the Q1 2026. So there's the most recent data. And you can definitely see improvement. So if you look at the top line, this is the overall average rate. And we've gone from 23.5% to 13%. So really nice improvement. But I think the improvement is not really seen everywhere. So we can see this as well. Same data, but with a closer timeline, which I think is quite interesting. And you probably have better theories on all of the different categories, why that's the case. And I think bear in mind the case that I think people do ask a lot harder questions. So I think GPU compute, for example, I imagine probably it's up and down because probably people ask harder things as well. But I think gaming is an interesting category because I've tried to use LLMs to build games. Not that I use games, but I don't build them. But whenever you try to build games with LLMs, it just feels like they have no idea how to build actual games. The mechanics like all over the place. They're not interesting. They're not challenging. So I do get this feeling that the performance is not really improved in some dimensions. Like I don't think LLMs really get games, even though I'm sure maybe go back 2 years, people are asking to build much simpler games versus now. But I wouldn't say that I'm aware of any like really good gaming benchmarks that would kind of capture this. So again, if you compare this to kind of line going up, I think this is not kind of matching that story, which I think is quite interesting. And there are a bunch of other examples that you see in there. So like, what's really the gap between these kind of crazy charts, which, by the way, I also agree with. I think they are true, and what we see on the right. And I think there's something that this kind of fuzziness that we all have in our heads, in our experience about the judgment that we have, that we use, that doesn't necessarily match all of these super narrow, very well-defined, very well-specified tasks. And I think there's much more to what work is and what white-collar work is and all work is that is not really captured by these benchmarks. So I think we should be just careful and maybe put a bit more effort to maybe bring up also the bottom of the distribution. So it's not just the very frontier gets better, but also kind of the broader distribution gets better as well. So I'll close here. One thing to mention, if you are a tinkerer, you like this kind of data, go to our Hugging Face. There's a lot that we publish and share. We're going to do more of that. We share some expert prompts, for example, and some of the leaderboard stuff. Join us if you want to build Arena or if you train models. We also do a lot of private evals. So thanks very much.
The future of work has many paths. Our next presenter will discuss the path that he walked with Devin as he organized this very conference. Please join me in welcoming to the stage the co-founder of AI Engineer Conferences, Swix.
Hi, everyone. I am not the Chief AI Officer of the UK. Unfortunately, he had to leave for a personal reason. But you get me. Thanks for staying so long. I hope, is everyone having a good time? Thank you. It's so endearing and heartwarming to hear from you guys. I'll take you a little bit into how we build AI Engineer with AI. And it's probably the biggest revelation that I've had. So yeah, we've had a lot of really warm reception from you guys, and I think it's really great. And I think this is something that we really try to engineer, and hopefully, this is our first event in London. Hopefully, you have us back next year. One thing I wanted to, for those who are newer to us, I do one of these keynotes every single AIE. The very first one 3 years ago, I talked about the productivity gain that you get from the increased AI, from the increased usage of AI. And the second one, we talked about how you should just use more AI because the cost curve of AI is going down roughly 100 times per every 12 to 18 months. And I think it's still continuing to trend that way. The third year, we started to talk about tiny teams, which was basically this definition that I had, that teams with more millions in revenue than number of employees. And I even curated an entire track at the World's Fair about this, where we sort of summarized it as the Tiny Teams Playbook, if you're interested in building that. The reason I liked this emphasis is because I think people are maybe too egotistical about looking for the one-person billionaire or unicorn founder. Every company can have a tiny team, whether you're small or large. And I think when I look at how we run AI Engineer, me being the leadership of Bentley and myself, we're also a tiny team. This is us. It's just 9 full-time people. And we're running a business that is more than $9 million, so we are a tiny team. And I wanted to show you the most significant changes in our workflow since we started this 2 years ago. By the way, this is our taking the AGI pill moment. Did you guys get the AGI pills? Yeah. Yes. Very proud of this. This is my brainchild. If one of your coworkers is not sufficiently AGI pilled, you should prescribe one of this. You're all AGI doctors now. Okay, our stack was very stable and completely non-AI, which is very ironic for an AI conference. We do Figma, React, Supabase, Tidal, Google Sheets, Sessionize. And then I had this funny, weird moment where I joined Cognition and started using coding agents seriously at work, mostly because they were free. And I started adding it to the company Slack. And then I started doing things with it and showing people, hey, here's how you use it to do coding on the company website. All well and good. And something strange starts happening. I start introducing, this is a workflow of our contract designer, now full-time, showing me a Figma page and asking me to go through it and expecting that we would take a week, 2 weeks, 4 weeks to turn it into reality. I just added dev into it. And ultimately, before I had to add dev into it, I had to hook up dev into Figma, and I'm not going to be doing that shit. So Cowork is doing it for me. You should use Cowork for doing this. And which by the way, leads me to my first lesson, which is anytime there's like random yak shaving, I think one underappreciated benefit of agents is that they save you the yak shaves, like all the dependency tree crawling of like, oh, no, I have to do that first. Oh, no, I have to do that first. And particularly when it comes to installing dependencies or fixing Python dependencies, fantastic for that. And I think a model of productivity that doesn't sufficiently appreciate parallelism and not just autonomy, I think, and sort of depth of the yak shaving is not fully capturing the benefit of agents. So anyway, back to the agent story. Hooked up Devin to Figma, and we, in very short order, we have a perfectly functioning website that is pixel perfect to the Figma. And to me, that was a surprise because I'd never done it before. You know, you always mistrust marketing until you see it for yourself. And more importantly, our designer was very happy about it. And that's basically the website that you see live today when you go to ai.engineer. The other interesting thing that happened was then we started using it more, right? After one initial success, you start using it more. Something that you can't see because it's very small text, but I'm going to highlight for you, is that is 207 replies just exploding in usage. Like, what the hell? And when you dig into it, it's very interesting, right? So first of all, I start kicking off some work, and then I go to bed. And then my designer, who's in Indonesia, wakes up and starts messing with Devin. It starts prompting Devin with red lines on annotations, which is something that Steve Ruiz, one of our speakers from yesterday, does with TL Draw. And I never taught him to do this. And there's no instruction manual. It was just mostly like, how would you communicate with another human being? And so I work mostly with a non-technical team, and I think that's very important, that they need to be comfortable with agents. And I think they're finally at the point that they are. We start working on things that we would never normally have worked on. Nobody has reported this, so I assume none of you had discovered it, but there's an Easter egg on the website. Why? Because I put it there. Why? Because it was fun. Because I could, right? So if you're on an ultra-wide, you scan your mouse over the highlights, you'll see an Easter egg. I saw a tweet that was viral about a design aesthetic that I liked. I threw it into Devin. Out pops. And then 127 replies later. I literally popped it in. I was like, oh, let's just see what the Clanker will do for me. I don't want to waste my designer's time. I just want to see what Clanker does for me. Designer jumps in and actually starts working on this thing, which I thought was throwaway and fun. And the most interesting thing is so small, I can't even read it. I'm so sorry for this. So basically, the reason he starts working on it, even though it's a throwaway project, is because it's fun. And I think that's something that was like a big aha moment for me. Like, I am getting more work out of my employees because they enjoy doing it. Because the feedback cycle for them from like blocking on me or a contract developer that we have is gone. Like, they just literally, they have the idea, they go do it, right? And they're doing more things. They're doing animations, they're doing polish, things that I'm getting work that I've never gotten out of my employees before. And I think that's something that's something you should appreciate too. If you haven't noticed, I'm no longer talking about agents for coding or like how many lines of code I'm producing. I'm getting more productivity out of my humans. And I think this is something that is a major theme for this year that I'm really trying to investigate, which is agents for everything else. Then obviously, okay, I had that success with Figma to a website. I have the success with Tweet to a website. What else, right? Like, you start to think about other use cases. This whole conference is a giant data management problem. Like, I have to sync with 130 speakers and a couple dozen sponsors and all the attendees that come in with all various needs. And really, it's just a CMS, right? Like, we've messed with the sanity. I'm not the biggest fan of sanity in the world because I want to keep some sanity to myself. But basically, like, I can throw in spreadsheets, and Devin can manage that for me. And once I think the unlock happened when I threw away the CMS and just kind of committed that to code, but use that code as my sort of source of truth, and let Devin, whatever coding agent you use, start to manage it. And so this entire schedule is managed by Devin. What does that mean? It means that whenever someone comes in with a speaker change, for example, Marder, one of the speakers from today, sends in an email, I just say, Devin, handle it for me, right? No other further communication is needed. I can just forward the email, I can paste a screenshot, whatever. And that kind of volume lets us, as a small team of 9 people, manage a 1,000-person conference. Right, we're going to manage 6,000 people in San Francisco this fall, this summer, and I'm pretty sure we can stay the same size. Like, it is incredible the amount of productivity that you can get once you're sufficiently onboarded and you have the workflows ironed out. We have agents for ETL. We deal with an external vendor system that has data that we don't have in a central source of truth. So I need to get the API key to sync over data and make sure there's a single source of truth. These are very boring routine tasks. Well, there's another fun story that I can tell you is agents for buying. So I saw this viral tweet about how somebody put a claw in Wall Street next to the Wall Street Bull. And I was like, oh, that's funny. Like, we should put a claw in front of our conference. And that's exactly, and so I asked Devin to research, where can I get a lobster in London? Devin comes back with phone numbers and email addresses and websites, and I just click through and think about it and ask it to do some more research, and out pops this guy. That's literally the lobster that you had was bought from Devin. And I think this kind of personal automation for everything else, it just matters that you have an agent that has web access, that has some smart enough model. I mean, this is effectively a claw, right? Like an OpenClaw, NanoClaw, whatever cranker you call it. It doesn't really matter. It matters that you're using agents for things that you would otherwise have spent knowledge work on. I might have had an executive assistant, I might have had a junior employee do these things for me, but now I can do it serverless on demand with a coding agent. I'm not here to only show Devin. I just advise for the company now. But I started exploring town because I think what's happening here is coding agents kind of breaking containment, right? There's all these other more fit for purpose knowledge management tools, like the wikis that Andre Karpathy is talking about that that OpenClaw is now adopting as well. You're going to see an explosion of this year. This is like probably the top trend of maybe top 3 to 5 trends of 2026 that I want to alert you to. So here is me managing the World's Fair in 2020 in this summer. Here are all the tracks I'm planning. Here's my Apple Notes. On the left is my Apple Notes of all the people. It's intentionally small. And I threw it into town, and out pops a nicely formatted Notion doc with research on all the speakers that I intend to solicit and think about curating. And then obviously, once you get enough psychosis, you are thinking about replacing entire pieces of SaaS. Here's me arguing with my employees about kicking out a SaaS tool and building it ourselves because we can. So I clearly have the most psychosis. I think one of the annoying things is if you're in a position of power or management to deal with employees who are not as much in psychosis and try to bring them along the journey and not talk down or ignore their concerns, right? Because they are very valid concerns, because they are exactly the people that will have to deal with your bullshit when you get it wrong, and we do get it wrong. One method I'm approaching the sort of AI replacing SaaS concept, which I think it should be relevant for a lot of you, is, well, let's identify the top 3 concerns and let's systematically reduce them, and that's the process that we're going through right now. So I just wanted to give you a little bit of that taste of like, here's how AI is changing our business as managing the conference. It's come really a long way. It's a consistent theme I'm seeing even among our speakers. This is Malta opening keynote, talking about how the 60% of the sort of user base of Vercel now is bots, is agents. It's not humans. So actually, your dashboards don't matter. Your APIs matter. Your CLIs matter. Your MCPs matter. Here's the MCP Apps guys, Ido and Liad, who spoke today, speaking on ETN, about how basically your custom UI is kind of going away. Like, you should ship UI to somebody else's app. And I think like this patterns of like how your primary user is changing is really shifting towards what people are calling agent experience. And I think that's something that, again, I'm really inspired by and focused on because it is helping me. Right? I no longer care about the Figma dashboard. I throw it into Cloud Cowork, and I hope that it works for me. So that's my message. Agents for everything else are coming. Wake up, use it, bring it home to work. If people are insufficiently bought on, prescribe them one of these. Thank you.
Ladies and gentlemen, please join me in welcoming back to the stage Tejas Kumar.
We did it! We did it. Y'all are such an amazing crowd. Thank you, thank you, thank you so much for sticking around. Look, it's been an incredible past couple of days. Yes? It has been so good, man. From yesterday with the opening keynotes all the way through today to the closing ones. What a journey. Let's take a moment and recap what just happened there. We have a video prepared. Stay tuned and watch it and just marvel at the good work that happened here. And then stick around a little bit longer. We have some announcements. We have some logistics. Excuse me. We're going to take some pictures and stuff. But for now, let's sit back and watch this little recap here. Give it up. Whoa. That is so cool. We did that. We did that. Give yourselves a round of applause. Incredible. Actually, we're gonna do a thing. Listen, it's a big deal what happened here. Okay, it's in Europe. We are here. It's a thing. And so we're gonna start wrapping up the conference. Don't leave yet. I see two of these guys leaving. Don't be like them. I'm joking. No pressure. Please stay. Anyway. We're gonna go through a little bit of a closing ceremony. It's not gonna be long. Maybe give us like 5 minutes or so. But this would be so incomplete if we didn't have like an applause marathon for all that went into this. This is not easy, and it's a big conference in a big city with a big topic and a big effort. Yeah. And so what I want you to do, we're going to acknowledge some people and parties who made this possible, and we're just going to clap all the way through. I'm going to say the names and identify the parties, and you're just going to keep clapping all the way. Okay. Let's start. Give it up for your speakers, each and every one. Thank you. Thank you. Thank you. Keep it going for the sponsors. Woo! We had Google DeepMind. We had OpenAI. We have all these. Thank you, sponsors. Give it up for yourselves. Yes. Give it up for the organizers, for Swix, for Ben, the volunteers, the associates, the suppliers, the Queen Elizabeth II Center, the photographers, the venue, the catering, Tim Kerb. Whoa, what a people. And finally, okay, pause, because this is a big one. That's actually 3 big ones. Look at these screens. There's people who made this happen. Give it up for the team that put together this huge LED wall. Let's give it up for them. Oh my God. That's incredible. You know, it's so cool, because it's like, from where you're sitting, you can't really see, but if I'm up here, I can see each dot. It's so cool. I love this screen. It's a really wonderful screen. We have a party coming up. And yeah, yeah, give it up for the party, man. Yeah, awesome. He has been trained well. Here's the deal. I need you to hear this. This is our party. It's coming up at 7 o'clock local time. It's in a club. It's in a club called Fabric, but here's the deal. It's not clubbing. Okay, we have the venue, and we can do whatever we want with the venue. And so we're going to create an atmosphere that's not, like you can talk to each other, and ideally you do. And so if you're expecting like strobe lights, darkness, smoke-filled room, it's not going to be that. The after party last night, it's very similar to that. Okay, so come along, have a conversation. Again, don't waste it. The conference may be over, but your opportunity to meet cool people and connect with them is not. So it's a 45-minute walk from here. Put it into your Maps app, Fabric, the club. It's a 45-minute walk, or if you take a public transport, it's 30 minutes. And if you take a car, it's 25 minutes, give or take, with traffic. Food and beverage is included. Okay, so if you come hungry, come thirsty. Yeah, we love food. The noise level is going to be manageable. It's not open to the public. We've rented the entire club, and we can do what we want with it. Very important. Come with your badge. I don't have mine, so I can't come. But it's backstage. But come with your badge. I need you to hear me. Come with your badge, because if you don't have your badge, you can't come. Okay, we need a way to identify you. And the reason for this is people want to go to a club, and they're going to come without a badge, and we need to really gatekeep a little bit because this is an experience they've created for you specifically, okay? Also, you cannot bring a +1 or a friend to this event because it's just capacity. And as you can look around, this room is full, and so we need to be mindful of that. And we don't want like a fire hazard where it's going to stampede if people leave, right? And so we want to be sensitive to that as well. We're about to finish the conference, but we would be remiss if we didn't capture this moment. So what we're going to do is we're going to move to taking a group photo together. Okay, some of you, if you don't want to be in the photo, absolutely no pressure. You're welcome to go to the expo area on your way out. But for those who want to be in the photo, you don't have to move. You just stay where you are. And what's going to happen is our photographer is going to come on stage. Hello. Give it up for your photographer, by the way. This is incredible. Yeah, both of them. So here's how it's going to work. They're going to come on stage. I'll join you. All of us are going to join you. It would be nice if we can come towards the middle so they don't have to use a big wide-angle lens. And then he's going to be in charge. We're going to turn the house lights up, and then when he gives the thumbs up, it's officially over. And then you're welcome to come up here, take photos, do whatever you want. We need to leave the building at 6:30 local time. You need to be out. If you're not out, you will be made to leave. Okay, so finish up your last arrangements after the photo. And then do whatever you want, and then we'll leave at 6:30. Is that good? All right, let's do it. Let's take the photo, everybody. He's in charge.
If you can get these guys just sort of move across.
Everybody move across into the...
Here, stay where you are.
Everyone in the middle.
If you want to stand, that'd be great.
Please stand.
Just move into the aisle for me. Just come as close as you can.
Yeah, good.
Jump down and join them.
Let's do it. Oh, my mic's still on, dude.